Good morning, friends. Welcome to Unacademy Gate MEPIXC. This is your educator Apuroop, and this is a very special event, an 8 hours marathon class on complete revision of strength of materials. Yes, last time we had an 8 hours marathon session on complete revision of machine design, and this time I have another 8 hours marathon session for you on complete revision of strength of materials. Yes, in a single session, we are going to revise the entire syllabus of strength of materials. So all of you who are preparing for GATE 21, this is a must session for you because I have told you that you only have 15 to 20 days left, and what you need to do in these 15-20 days, you need to repeatedly revise your concepts, you need to repeatedly revise your theory as well as practice same problems again and again and again. You don't have to read anything new, you don't have to study any new concept, any new chapter, any new subject. You have to revise the same thing again and again. So even if you have the revision of strength of materials before, even if you have had revision course of strength of material before, no issue, you still have to participate in this 8 hours marathon session. You still have to watch this entire session because beta you need to repeatedly revise your concepts. So give me these another 8 hours and your concepts of strength of materials will be completely refreshed. Welcome everyone, welcome Ved, welcome Shadab, welcome Dhananjay, welcome Gogol, welcome Aditya. Good morning everyone. Good morning. All of you, please hit the like button and don't forget to share this session to as many people as possible, because remember, sharing is caring. Sharing knowledge is a very noble cause. That's what we are doing here, and you can also participate in this noble cause by sharing the link of this lecture to all your Telegram groups, all your WhatsApp groups, all your Facebook groups. All you need to do is just copy the URL of this and paste it in your groups. Tell them that we are live for 8 hours marathon class on strength of material, complete revision of strength of materials. And trust me guys, you are going to love this session, and I need your love and support so that I will be energetic throughout this session. You can understand that for 8 hours, if I have to be this energetic, then how much support I need from you guys. And what will be the support? Your one like, your one share, and your attendance is all the love and support I need to complete this 8 hours marathon class. Okay, I am not one of those people who can take hours and hours of class, because beta you have seen me, so that I need your love and support in order to complete this marathon session. तो बेटा 8 घंटे की इस मैराथन सेशन में जब जब मुझे फील होगा कि मेरी एनर्जी लो हो रही है, whenever I will feel that my energy is getting low, then I will see this screen and I will see who is watching me and I will read all your live chats. So show your love and support in the form of your live chat, in the form of your likes, in the form of your shares. Thank you so much if you have already done that. Good morning, good morning, good morning. Thank you so much, thank you so much. यस मेरे भाई, इंजीनियरिंग मैकेनिक्स की, थ्योरी ऑफ मशीन्स की, वाइब्रेशन की, सबकी मैराथन क्लास लेने वाले हैं. आई हैव ऑलरेडी प्रॉमिस्ड यू दैट वी आर गोइंग टू रिवाइज all the subjects of design, and whenever I have promised you, you might have noticed that I have fulfilled my promise. तो बेटा ये promise भी मैं fulfill जरूर करूंगा और आप लोगों के सामने ऐसे बहुत सारे सेशंस लेके आऊंगा जब तक आपका गेट कंप्लीट नहीं हो जाता. गुड मॉर्निंग एवरीवन, गुड मॉर्निंग, गुड मॉर्निंग. Thank you so much, thank you so much. Okay, so beta, those of you who are watching me for the first time, let me give a quick introduction. My name is Apuroop, all India rank 320 in GATE Mechanical. I have done my MTech from IIT Kharagpur and my specialization was design. I have 2+ years of working experience in Mahindra Research Valley in the field of design of cars. Then I have 6+ years of teaching experience for GATE and ESE, and I teach subjects related to design, SOM, MD, EM and TOM. And if you want free lectures of these subjects, then all you need to do is open this link tinyurl.com/Apuroop, and you are going to get all my lectures, all my notes in this link. I have provided the link. Just click on that link and you will open this awesome page. You will find ebooks of all my subjects, and you will also find these Excel sheets. What are these Excel sheets? So beta, whenever I take any lecture series of SOM, crash course of SOM, quick revision of SOM, machine design, quick revision of machine design, whenever I take any lecture series, then what I do is I create an Excel sheet for that lecture series, so that you will get all the lectures and all the notes of that lecture at one place without any hassle. तो बेटा आपके एक्सपीरियंस को हैसल फ्री बनाने के लिए मैंने ये एक्सेल शीट्स बना दी हैं. इफ यू ओपन एनी एक्सेल शीट्स you will see that all the lectures here are given one by one. You will find the YouTube class link, you will find the PDF link, so that you can navigate through this. You can watch any lecture anytime, you can download any PDF anytime. You don't have to ask anyone, you don't have to search anything. आपको कहीं जाने की जरूरत नहीं है. If you need the subjects of design, if you need to study the subjects of design, then all you need to do is open this link, tinyurl.com/Apuroop10. Don't forget to share this as much as you can. Good morning Harshit, good morning Satish, good morning Chandrakiran, good morning Rohit, Saurabh, Rahul, Jayant, good morning Ajoy. Very good morning to all of you, very good morning to all of you. And beta, don't forget to follow me on Unacademy. You can just go to unacademy.com and you can search my name Apuroop, or you can open this link unacademy.com/@Apuroop, and you will go to my Unacademy profile. Follow it so that whenever I will be live, you will get the notification, and you can watch all my free special classes at one place. Why do you need these free special classes? Because I have taken special classes on some very important subjects. PYQs of SOM, PYQs of MD, PYQs of machine design, engineering mechanics, then crash course of theory of machines, crash course of vibration, and right now recently we have started most expected question series, where we are solving all the important questions of all the subjects of design. We have completed SOM, we have completed MD. Tomorrow we are going to start most expected questions of engineering mechanics every day 2 p.m. 4 p.m. where you will get the link tinyurl.com/Apuroop10. But beta, in order to watch the special class, you need to follow this very simple 3 steps. Download the Unacademy learning app, register in the app, and when you will open the first class, you will have to use this code Apuroop10. Use this code and all the special classes will be unlocked. And apart from that, you will also unlock Unacademy Combat. What is Unacademy Combat? It is India's biggest quiz competition based on GATE, where you can win exciting prizes, and also you will get to practice new questions. It takes place once in every 2 weeks, and the next one is on 26th of January 6 p.m. and the registrations are completely free. All you need to do is download the app, register, and use the code Apuroop10. Okay, and all of this will be unlocked. Okay, and we have recently started new batches for GATE 2022, GATE 2023, and ESC 2021. And trust me, these are one of the best batches ऑनलाइन राइट नाउ इन इंडिया. इंडिया में आज की डेट में गेट 2022, 23 और ईएससी 2021 की ये सबसे बेस्ट बैचेस हैं, बिकॉज द बेस्ट टीचर्स आर टीचिंग दीज बैचेस and the best of the students are learning in these batches. So if you want to learn from the best, if you want to be the best, if you want to be among the best, then join these batches right now. Take Unacademy Plus or Unacademy Iconic subscription. Unacademy Plus subscription will give you full access to all the live classes, full structured course where you will be able to ask any doubts you want. You can take part in weekly tests. There will be lots and lots of crash courses, rank improvement batches. So it's a complete package to get into IITs, to get into PSUs. And if you want a more personal help, if you want a personal coach, then you can take an Unacademy Iconic subscription, where you get a coach who will be monitoring you 24/7, where you are making mistake, what you need to improve. All of that will be taken care by this personal coach in Iconic subscription. So beta, if you take an Academy Plus or Iconic subscription, you are going to get amazing tools which you need for your online learning, where you will get live polling and leaderboard, which will make problem solving a fun game. Okay. Then there will be live interactive classes, doubt solving sessions. There will be multiple batches by multiple educators, so many batches, and the best thing is one subscription and you will get the access to all these batches. You can open any batch, you can join any batch. Okay, all you need to do is use Unacademy Plus or Unacademy Iconic subscription. So you can take the subscription for 1 year, 1.5 year or 2 year, and when you are subscribing, don't forget to use this code Apuroop10. If you use this code, you are going to get 10% off, as well as my personal guidance and my personal mentorship. If you use this code, means you are coming to Unacademy believing in me. So I will be with you throughout your preparation. You will ensure that I will monitor you, guide you, prepare you and help you throughout your preparation. Okay. So all you need to do is pay 60-50 rupees per month or 54 rupees per day. You can pay this in EMI, easy monthly installment, without any additional cost. Okay, you can also take an Academy Iconic subscription for 1 year or 2 year. Okay, so I will see you soon on this Unacademy platform. Okay, now this is the entire syllabus of strength of materials. Let's quickly see what we need to complete, what we need to finish. Introduction to stress, introduction to strain and material properties. These three are the basics of stress and strain, the basics of strength of material, right? ये तीन चैप्टर जो हैं वो strength of material के pillars हैं, basics हैं, where we learn a lot of basic concepts. Okay, and trust me, 70 to 80% theory questions from strength of material will be from these topics. ठीक है, 70 से 80% जो SOM के basic concepts के क्वेश्चंस होते हैं वो यहीं से आते हैं, थ्योरी क्वेश्चंस जो होते हैं वो यहीं से आते हैं. ओके, देन आफ्टर दिस ऑल दीज चैप्टर्स आर बेस्ड ऑन द कैलकुलेशन ऑफ स्ट्रेस एंड स्ट्रेन. हाउ डू वी फाइंड स्ट्रेस एंड स्ट्रेन अंडर डिफरेंट लोडिंग कंडीशंस इन डिफरेंट मेंबर्स. So axially loaded members, then torsion in circular shaft, then shear force and bending moment diagrams, bending stresses in beams, shear stresses in beams, deflection of beams, complex stress and strain, pressure vessels, and last but not the least, columns. So this is the entire syllabus of strength of material, and one by one we will complete all these chapters. So beta, this will be our first chapter, introduction to stress, introduction to strain and material properties. Then this will be the second chapter, this will be the third chapter, this will be the fourth chapter, this will be the fifth chapter, sixth chapter, seventh chapter. Complex stress and strain I have divided into two different chapters. So this will be chapter number 8 and 9. Then this will be the 10th chapter, and columns will be our 11th chapter. So in 11 chapters, we are going to finish the entire strength of material syllabus. Will you be taking Tom revision for GATE 21? Yes, I am planning to take revision classes of Tom and vibration next week, and I will soon update this in my Telegram channel. मैकेनिकल के बच्चे कब क्या एसएससी जेई, बेटा एसएससी जेई के लिए आई डोंट हैव एनी आइडिया बिकॉज दिस इज फॉर गेट. Marathon will be completed today. Beta, it is an 8 hours marathon session. So it will be completed today. Okay, there are 24 hours in a day. So 8 hours will be completed today only. Okay. Good morning, good morning, good morning, good morning, good morning. Okay, thank you so much, beta. I will be continuously reading all your chats. I will be continuously reading all your comments. So beta, show all your love and support in the form of hearts in the live chat. Whenever I will be seeing that my energy is getting low, whenever I will feel my energy is getting low, then I will look at this live chat and your responses, your attendance will fill me with the energy. Okay, तो आपका ये जो response है, आपकी ये जो chats हैं, आपका ये जो attendance है, आपके ये जो likes हैं, this will be my energy booster for this session. Okay, so thank you so much for all the love and support you have shown me till now, and I expect the same amount of love and support for this marathon class, because I really need this, guys. I really need this. I really need you throughout this 8 hours marathon session. Thank you so much, guys. Thank you so much, Ajay, Grubler, Prabhakar, Varikuti, Sonu, Saurav, Varun, Ajoy, Sandeep, Saurav. Thank you so much, Harsdeep. Thank you so much, Jai. Thank you so much, guys. Thank you so much. Lovely, lovely, lovely. This fills me with so much joy, so much happiness that my students are always with me. Thank you so much. Now hit the like button and share this link to as many people as you can. Let's start this marathon journey with our first chapter, Introduction to Stress and Strain. Introduction to Stress and Strain. This is going to be our first chapter. Let's quickly revise the concepts of Introduction to Stress and Strain. Okay, so let's first understand what is stress. Okay, this is a quick revision. This is a quick revision. So if you need to understand the entire concept, if you have any doubts, then you can watch my full lecture of strength of material by clicking on this link, tinyurl.com/Apuroop10. Just open this link, you will find Excel sheet of SOM. So if you have any doubt in any topic, any lecture, then you can just go to that lecture, you can watch. I have explained everything in detail in that SOM lecture. Okay, thank you so much, and let's start this. So beta, stress is what? Stress is basically the internal force per unit length per unit area on any given plane. Let's say you have a body and at any point you want to find the stress. So you consider a plane passing through that point and you calculate the internal force on that plane per unit area. This is the basic definition, the general definition of stress. Okay. Now it is defined as internal force per unit area at any given point on a given plane, and its SI unit is Pascal Newton per meter square. I always make this mistake. This is Newton per meter square, but we usually calculate the stress in Newton per mm square. Okay, and 1 Newton per mm square is equal to 10 to the power 6 Newton per meter square, which is what? Megapascal. So this is our choice of unit, megapascal. Okay, now in order to understand what is stress, you need to first understand, or what are the different types of stress, you need to first understand the different types of load. So load can be divided into two: force and moment. Force and moment. And when do you get the moment? When the force is not passing through the centroid of the area, then we get the moment. Now force can be of two types. We can have axial force, we can have transverse force. What is axial force? Let's say okay, so let's say we have this cross section and the force is acting like this. So this is known as axial force, where you are calculating the stress on this plane. Okay, and what will be the transverse force? Let's say you have these type of forces and this is the plane where you need to calculate the stress. So beta, you can see that the force here is normal to the plane and the force here is parallel to the plane. So axial force and transverse force. Just like that, we have bending moment and twisting moment. So what do we mean by bending moment? If the moment is acting about the parallel axis, means let's say this is the cross section. If the moment is acting about y axis or z axis, if this is mz, then this is a bending moment. And what will be the twisting moment? If the moment is acting about the normal axis, let's say this is mx, x is the normal axis of the cross section, then it's a twisting moment. Now based on this, you can understand the types of stresses. Due to force, we have direct stress, and due to moment, we have indirect stress. Now forces are of two types, axial and transverse. So stresses are also of two types, axial stress and shear stress. Moments are of two types, bending and twisting. So stresses are of two types, the indirect stresses, bending stress and torsional stress. So you can relate the load and the stress. Okay, so these are the different types of stresses. Now in another chapters, in different chapters, we study about each and every stress. हर एक चैप्टर में हम एक पर्टिकुलर टाइप का स्ट्रेस पढ़ते हैं. From second chapter onwards, we calculate all these stresses, right? Then stress tensor, probably the most important concept in this particular chapter. So what is stress tensor? at any point, if you want to calculate stress, what do? You consider three mutually perpendicular planes. अगर आपको किसी भी पॉइंट पे स्ट्रेसेस निकालने हैं तो आप तीन म्यूचुअली परपेंडिकुलर प्लेन्स कंसिडर करते हैं. दिस फ्रंट वाला प्लेन इज योर एक्स वाई प्लेन, दिस साइड वाला प्लेन इज योर वाई जेड प्लेन, and this top wala plane is your xz plane, right? And on every plane there will be three stresses, one normal and two parallel. You can see on every plane three stresses, one normal, two parallel, means one sigma and two tau. Okay, so beta overall we get 9 stress components. So at any point if you want to find stresses, you calculate these 9 stress components, right? Now you can show these 9 stress components in the form of matrix. आप इन सारे 9 stresses को matrix के form में show कर सकते हैं. So when you show them in a matrix form, you get this x, y, z, x, y, z, right? First element is what? Sigma xx, or you can just simply write it x. Second component tau xy, then third one tau xz, then tau yx, sigma yy, tau yz, then tau zx, tau zy, and sigma zz. Okay, so this is known as what? Stress tensor matrix. Now there is a characteristic of this matrix. What is that characteristic? That this is a symmetric matrix. What do we mean by symmetric matrix? The elements above and below the diagonal are symmetric, same. So tau xy is equal to tau yx, tau xz is equal to tau zx, and tau yz is equal to tau zy. So if three stresses are equal to these three stresses, then you don't need to calculate all the 9 stresses. You only need to calculate 3 plus 3, 6 components, because these 3 will be equal to these 3. तो आपको टोटल सिर्फ 6 निकालने होते हैं, right? But this is in case of triaxial stresses, right? ये triaxial loading के केस में. But in our syllabus we don't have triaxial loading. In our syllabus we only study biaxial loading. Triaxial loading you study in further studies. For example, if you get into IITs or NITs, if you are into post graduation, MTech कर रहे हो, then you study triaxial loading. Okay, so in our syllabus we only study biaxial loading. Okay, now this concept tau xy equals to yx, xz equals to zyx, and yz equals to zy is related to complementary shear stress. What do we mean by complementary shear stress? According to complementary shear stress, if you apply stress on any one plane, this side wala plane is what? YZ plane. So if you apply shear stress on this YZ plane, then there will be another equal and opposite shear stress on its perpendicular plane. तो इसका perpendicular plane ये है, तो यहां there will be another equal and opposite shear stress. Why? So that the moment will be balanced. In order to keep the moment balanced, okay? Because if there is only tau xy, this one and this one will form an anti-clockwise couple. To balance this, there is a clockwise couple. So if there is tau xy, there will be an equal and opposite tau yx. This is the component of, this is the concept of complementary shear stress, and this is why we have this. इस complementary shear stress के concept की वजह से ही हमको ये चीज मिलती है. You can get all these in 1 mark theory questions, conceptual questions. ठीक है, ये सारी चीजें 1 mark के conceptual question में पूछी जा सकती हैं. So you have to keep all these things in mind. Whatever you need to keep in mind, whatever you need to remember, that is all what I am writing here. So whatever I am writing here, understand that you have to memorize it, you have to keep it in mind. आपको ये दिमाग में बैठा के रखना है, आपको रट लेना है. Okay, you have understood all this. Now it's time to memorize it. Okay, and don't take it in your ego. ठीक है, इसको एकदम ईगो पे मत ले लेना कि अरे ऐसे कैसे, अपन आज तक कुछ नहीं रटेले हैं, आज तक अपन सब कुछ पढ़ के गए, समझ के गए, अपना दिमाग इतना तेज. बेटा, आई नो all of you are very smart, all of you have understood all the concepts, but it is also very important that you memorize them so that it will be easier for you to recall them. Okay, so this is the time where you need to repeatedly go through your short notes, go through your theory, so that it will be memorized, it will stuck in your, it will be imprinted on your mind, so that it will be easy for you to recall them in the exam. क्योंकि एग्जाम में बैठ के आप सोच नहीं सकते कि अरे वो क्या था कॉन्सेप्ट यार, वो दिमाग में आ रहा है, मुंह पे नहीं आ रहा है, हाथ में नहीं आ रहा है. So you can't do that. Okay, if you take too much time to recall each and every concept, then beta 3 hours will be very less time for you in the exam. So that's why all of this should be memorized, imprinted on your mind, so that whenever you have any question from any subject, any topic, you will quickly recall the concept, you will quickly recall the formula, that yes, this is the concept from this. So you will quickly write the formula, you will quickly put the values, and you will get the answer. Okay, so that is what you have to do, that is what you have to do. You have to memorize all this, you have to imprint all this in your mind. Okay, so whatever I am writing here, you have to memorize it. Okay, mug it up, kuch bhi karo, ratta maro, jo karna hai karo, make your own short tricks for remembering them, but you have to remember them. Okay, next concept is biaxial stress or plane stress. What did I tell you? We don't study triaxial stress, we only study biaxial stress. And what is biaxial stress? Biaxial stress means all stresses in z direction are zero, so you only get stresses in x and y direction. So all these stresses can be shown in a single plane. इन सारे स्ट्रेसेस को आप एक सिंगल प्लेन बना के शो कर सकते हो. दैट्स व्हाई दे आर नोन एज plane stress. Okay, so you can show all these stresses like this. Okay, all the stresses are lying in one single plane. So if they are lying in one single plane, you don't have to make the entire cube, you can just make a rectangular element and you can show all your stresses. So this will be your sigma x. I am writing sigma xx as sigma x because you don't need another letter. If I am writing sigma x, means it is sigma xx. Okay, this will be sigma y and this will be tau xy. Yx is equal to xy, so you don't need to separately show it. Tau xy is tau yx, and you can show this in the matrix form like this. मैट्रिक्स के फॉर्म में इसको ऐसे शो कर सकते हैं, सिग्मा एक्स, सिग्मा वाई, टाउ एक्स वाई एंड टाउ वाई एक्स, where टाउ एक्स वाई एंड वाई एक्स both are equal. So this is what? This is biaxial or plane stress. Why do we call it plane stress? Because all the stresses are in one single plane. Okay, and in our syllabus we only studied this. Yes, good morning Prem, good morning Bharti, good morning Harsh. Yes, good morning Ganesh, good morning everyone. Please hit the like button and please share this link to as many people as you can. Okay, इस लिंक को जितना ज्यादा हो सके उतना शेयर करो, तबाही मचा दो. आज लाइक बटन फूट जाना चाहिए. Everyone must know that this is Unacademy Gate MEPI XC channel, and you guys love this channel. You guys are a part of this channel. You guys are a part of this family. Okay, thank you so much. So beta, now pure shear stress. In case of biaxial stress, we have certain very important state of stresses, out of which this is one, pure shear stress. What do we mean by pure shear stress? Pure shear stress का मतलब है that there is only shear stress acting on these planes. There is no normal stress. So we will have this tau acting on these mutually perpendicular planes. Okay, and if you show them in matrix format, then it can be shown like this: 0, tau, tau and 0. ठीक है, आप इसको इस तरीके से शो कर सकते हैं, 0 टाउ टाउ एंड 0. ओके, so this is what pure shear stress. And when do you get this? Under torsional moment. If the body is subjected to only twisting moment, then you get pure shear stress. And another very important state of stress is hydrostatic stress. So what is hydrostatic stress? Hydrostatic stress means you have normal stresses on all three planes equal. तीनों प्लेन्स पे या दो प्लेन्स पे नॉर्मल स्ट्रेसेस आ रहे हैं, इक्वल नॉर्मल स्ट्रेसेस आ रहे हैं. ओके, एंड इफ यू शो देम इन द मैट्रिक्स फॉर्मेट, then it will be like this: sigma 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 and all the other components will be 0. okay, बाकी सारे component क्या हो जाते हैं? 0. now this is a triaxial hydrostatic stress. if you have only two sigmas, then it will be a biaxial hydrostatic stress. okay, so triaxial hydrostatic stress, biaxial hydrostatic stress, it can be tensile, it can also be compressive. okay, so these two are very important state of stresses. okay, so that's all for introduction to stress. now let's move on to introduction to strain. अब strain में basic concepts क्या हैं? first of all you need to understand different types of strain. okay, so strain is nothing but the measure of deformation, how much deformation there is under external load, right? if you apply external load on any body, the body is going to deform. So strain is the measurement of that deformation. okay, कितना deformation आ रहा है ये हम measure करते हैं strain के terms में, right? now strain can be divided into two types: normal strain and shear strain. what is normal strain? normal strain is the measure of change in size. ठीक है, normal strain क्या है? it is the measure of change in size. and shear strain is the measure of change in shape. size कितना change हो रहा है? length, diameter, weight, volume, all of this, how much they are changing, that is normal strain. and shape कितना change हो रहा है? how much angle by which it is rotated, that is measured by shear strain. okay, now normal strain are further divided into longitudinal, lateral and volumetric strain. why? because there are different dimensions of the body and all the dimensions are going to change. so that's why we have different types of normal strain: longitudinal, lateral and volumetric. I hope all of you remember the concept of this, right? shear strain is only shear strain. okay, this is denoted by epsilon and this is denoted by gamma. now let's move on to the definition of normal and shear strain. so normal strain is the measure of what? change in size. it is the measure of change in size. this is what you need to keep in mind. ये आपको ध्यान में रखना है. normal strain मतलब size में change. okay, and how it is defined? the general definition of normal strain is, it is defined as the change in dimension per unit original dimension. normal strain को कैसे define करते हैं? it is defined as the change in a dimension per unit original dimension. the change in dimension, beta, it is never asked in interviews. okay, nobody till now has ever asked what comes first, stress or strain. स्ट्रेस पहले आता है कि स्ट्रेन पहले आता है, ऐसा सवाल कोई नहीं पूछता. बिकॉज बेटा ऐसा नहीं है कि स्ट्रेस आया 10 घंटे बाद जो है स्ट्रेन आया, या स्ट्रेन आया 10 मिनट बाद स्ट्रेस आया. इट डजंट हैपन. स्ट्रेस इज द रेजिस्टेंस टू स्ट्रेन. ओके, तो स्ट्रेन और स्ट्रेस दोनों आसपास साथ में आ रहे हैं, कोई पहले नहीं आ रहा है, कोई बाद में नहीं आ रहा है. ओके, दे आर नॉट गेस्ट, two different guests, so that one will come, then he will introduce the other one and the other one will come. तो ऐसा इंटरव्यू में कोई नहीं पूछता है. people will only fool you by saying this, that this is a very important interview question, and different people will give you different reasons, different logics, different concepts. but stress comes first, strain comes first. that is not like that. okay, stress and strain are just the concepts which we have made in order to understand the strength of material. okay, otherwise beta stress और strain जो है ऐसा कोई physical value नहीं है. okay, they are not physical values. strain concept and stress concept was developed by us in order to understand how the body fails, how the body works, how external loads affect the body. okay, so beta stress comes first, strain comes first. that is a very wrong statement. okay, don't get into that debate because it's not true. okay, thank you so much if you have understood. yes. Yes. Nobody depends upon nobody. Stress depends on strain, strain depends on stress. Beta, this is the definition we have made. Okay. So beta, nobody can exactly tell you. You will never read a statement like this in any foreign author book that stress depends on strain or strain depends on stress. Otherwise, there are some instances where stress is 0 and strain is not 0. Strain is 0 and stress is not 0. This you see in thermal stress, right? This you see in thermal stress. Axial loading may, if I apply load in X, I get strain in Y, but I don't get stress in Y. So how are you going to justify that? How are you going to justify that? So that's why you cannot say that stress depends on strain, strain depends on stress, stress comes first, strain comes first. All this is bullshit. All this is nonsense. Don't get into these concepts. ठीक है, ऐसा कोई concept अपने दिमाग में मत बैठाओ, ये सब बकवास बातें हैं. Okay, stress is different, strain is different. You consider them two different parameters. Okay, one depends on material, another doesn't depend on material. That is the difference. Otherwise, this depends on this depends on this. That is wrong. Okay, all right. Now, normal strain का general definition क्या है? What is the general definition of normal strain? It is defined as change in dimension per unit original dimension. Means, let's say the length is changing. So if you want to calculate strain in the length direction, then it will be change in length per unit length. If the diameter is changing and you want to define strain in diameter direction, then it will be change in diameter per unit original diameter. Per unit original diameter. Okay, thank you so much guys. Thank you so much for all the love and support. Keep showering your love till the end. ठीक है, आखिरी तक डटे रहना है, because whenever I will feel low, I will see you. I will see who is with me. Okay, all right. So beta, in order to define them, we use this very simple example. Let's say we have circular bar which is subjected to tensile load. Initial length is Li, initial diameter Di. If it is a tensile load, length will increase, diameter will decrease. Okay. Now, how do we define longitudinal strain? So, longitudinal strain is the normal strain in the x direction. Okay, in the direction of the load. Okay, load is acting in x direction. So longitudinal strain is epsilon x, and it is given by L final minus L initial by L initial. This is longitudinal strain along the length. Lateral strain will be perpendicular to the length, perpendicular to the load. Okay, so lateral strain क्या हो जाएगा? Epsilon y as well as epsilon z, both will be equal, and in y and z direction you have diameter, so it will be d final minus d initial by d initial. Okay, now you will notice one thing, that lateral strain and longitudinal strain are of opposite sign. Epsilon longitudinal and epsilon lateral have opposite signs. Okay, if one is positive, one is negative, but this is not true for all the materials, but whatever materials we consider, it is true for them. ठीक है, जो material हम consider करते हैं वो true है इसके लिए. Okay, now next one, volumetric strain. So what is volumetric strain? Volumetric strain is defined as change in volume per unit volume, and it is also written like this: epsilon v is almost equal to epsilon x plus epsilon y plus epsilon z, but this is only true if the deformation in x y z are very small. ये जो इक्वेशन है ये तभी ट्रू होती है जब x y z में डिफॉर्मेशन बहुत छोटा होता है. But don't worry, you don't have to see whether deformations are very small. Why? Because throughout the strength of materials, we only assume that deformations are very small. Whatever equations you derive throughout the strength of material, जो भी equation आप derive करते हैं, that is based on the assumption that the deformations are very small. Okay, so beta, whatever strength of materials we study in our syllabus, that is actually strength of materials of small scale deformations. That is strength of materials of small scale deformations. If the deformations are large scale, then these equations will not be valid. Okay. But this is not what you need in exam. Exam में ये सब की जरूरत नहीं है. Interviews में maybe you will need it, but exam में you don't need to worry because all these equations will be valid in exam. Okay, you can use them. You don't have to check whether deformation is small or not. You can directly put epsilon v equals to epsilon x plus epsilon y plus epsilon z. Okay. Next, shear strain. Now, what is shear strain? Understand. Normal strain is the change in size. Shear stress is the change in shape. अब shape में change होने का मतलब क्या है? Let's say we have a plane like this. Okay, let's say we have a body like this. Okay, planar body, planar element. Okay, and I am applying shear stress over this. Okay, मैं क्या कर रहा हूं? Shear stress लगा रहा हूं. Okay, now I can apply shear stress like this. I can apply shear stress like this. Okay, now let me tell you one thing, that according to our sign convention, we consider this to be positive shear and this to be negative shear. अब shear की वजह से होता क्या है? Due to shear, this angle changes. This angle, ये जो angle है, ये change हो जाता है. Right now, what is this angle? Right now, this angle is 90 degree. So this angle is going to change. Now, how this angle is going to change? Let's understand that. So under the shear stress, this angle will change like this. Okay, इसको थोड़ा अलग तरीके से बनाना पड़ेगा. So it is going to change like this. Under positive shear, it will change like this. Okay, so under positive shear, it will change to this. Okay, so you can see that the angle which was 90 degree initially is now changed. How much it is changed? It is changed by 90 degree minus, let's say, gamma. Okay, now it has become 90 degree minus gamma. So by how much it is changed? It is changed by gamma. तो अब इसको define कैसे करेंगे? This will be gamma by 2 and this will be gamma by 2. Now why this and this are equal? Because beta this and this tau are equal na. ये tau equal है, ये tau equal है. So this angle and this angle should be equal. Total angle is gamma. So this will be gamma by 2. This is gamma by 2. So this is again complementary shear strain. ये कौन सा concept होता है? Complementary shear strain. Now this is positive shear strain and this will be negative shear strain. अब negative shear strain कैसे बनाएंगे? Understand. So बेटा negative shear strain will look something like this. Negative shear strain will look something like this. So you can see that the shape of the body, the shape of the element is completely changed, है ना? पूरा shape जो है वो change हो गया है. Why? Because this angle has been changed. Okay? अब इस केस में जो एंगल है वो इंक्रीज हो गया है, राइट? नाउ इन दिस केस द एंगल हैज बीन इंक्रीज्ड पाई बाई 2 प्लस गामा. ओके, तो बेटा हियर दिस इज गामा बाय 2 and this is gamma by 2. Now if the angle is decreasing, it is a positive shear, and if the angle is increasing, it's a negative shear. So beta sometimes they ask this type of question, positive shear or negative shear. This has been in gate civil. Gate civil में gate में आ चुका है ये. Mechanical में भी maybe they will give this. Okay, so this is positive shear, this is negative shear. So what is shear strain? It is defined as change in angle between two mutually perpendicular planes. So you can see that these two mutually perpendicular planes are changed by gamma. So gamma is the shear strain. Okay, so this is the definition of shear strain. Let's move on to next. Very good, lovely people, lovely people. Now I want this attendance to only increase. This should not decrease. Okay, I want this constant love and support. Give me likes, give me shares, give me likes and shares. Thank you so much. Thank you so much. Okay. Now strain tensor. So what is strain tensor? Just like stress tensor, we also have strain tensor, means on three mutually perpendicular planes, we have 9 strain components and you can show them like this. What you need to do, the concept of stress tensor and strain tensor are exactly same. All you need is this. Instead of sigma, you write epsilon, and instead of tau, you write gamma by 2. Now why gamma by 2? Gamma by 2 क्यों करते हैं? Because of this. I have explained this in detail. Okay. So tau and tau, gamma by 2 and gamma by 2. Sigma, epsilon, but tau, gamma by 2. Okay. Now if you write it in matrix format, a 3 by 3 matrix, then you will get this: x, y, z, x, y, z. So this will be epsilon x, gamma xy by 2, gamma xz by 2, gamma yx by 2, epsilon y, gamma yz by 2, gamma zx by 2, gamma zy by 2, epsilon z. Okay, and again this is also a symmetric matrix. ये भी क्या है मेरे भाई? Symmetric matrix means the elements above and below the diagonal will be same. यानी gamma xy will be equal to gamma yx. Why? Because tau xy is equal to tau yx, and due to tau only gamma is getting created, right? Tau है तो gamma है, tau नहीं तो gamma नहीं. So gamma xy and gamma yx will be equal, gamma xz and zx will be equal, and yz and zy will be equal. मेरे भाई सेशन खत्म तो हो जाने दो, उसके बाद पीडीएफ मांग लेना. पहले सेशन खत्म तो हो जाने दो. I have shared the PDF of MD Marathon also. I will share the PDF of this also in my Telegram channel and in tinyurl.com/Apuroop10. Okay, so if you want all these lecture notes, just follow my Telegram channel Apuroop10. Okay, so beta, let me complete this session na. Then you ask for the PDF. Just started, we just started this. Not even 1 hour is completed and people have started to ask me whether you will get the PDF or not. अबे भाई पहले सेशन तो देख लो, उसके बाद पीडीएफ की चिंता कर लेना. पहले पूरा सेशन खत्म तो हो जाने दो. ओके 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 यस. चलो तो बेटा, concept of stress tensor and strain tensor are exactly same, so you don't have to separately study this. इसको अलग से पढ़ने की जरूरत ही नहीं है. Just replace sigma with epsilon, tau with gamma by 2. No other formula you need to remember. If you remember the formula of stress tensor, all that formula can be converted into strain tensor. Just replace this. Okay. Now, types of material. अब strain tensor में इससे ज़्यादा पढ़ने की ज़रूरत नहीं. You don't have to study anything else than this. Okay. Types of material. तो बेटा, there are 2 types of categorization. When we say what are the different types of material, then we can categorize the material into 2 types. Okay, हम 2 तरीके से categorization करते हैं. Whether the material is homogeneous and or non-homogeneous, and whether the material is isotropic, anisotropic and orthotropic. Okay, now homogeneous or non-homogeneous material क्या है बेटा? If all the material properties are same at all the points, सारी मटेरियल प्रॉपर्टीज जो हैं वो हर पॉइंट पे सेम है, देन इट इज अ होमोजेनस मटेरियल. ओके, फॉर एग्जांपल, लेट्स से आई एम कैलकुलेटिंग यंग्स मॉड्यूलस E at 2 different points. Okay, 1 and 2 in x direction. Okay, यहां x में और यहां y में नहीं. Okay, here in x, here also in x, that I am getting same Young's modulus at 1 and 2, Ex and Ex. If I calculate in y, then I will get Ey and Ey. Okay, so this is homogeneous material. Homogeneous मतलब simple language में you have one single material throughout the body. One single material throughout the body. So this is not homogeneous. This is not homogeneous. Okay, so this is a non-homogeneous material. अब non-homogeneous material मतलब What do we mean by non-homogeneous material? Material properties are different at different points. Okay, material properties are different at different points. So let's say we have point number 1 and point number 2. So yahan it will be E1x, yahan it will be E2x. Okay, so you can see this is a non-homogeneous pen. Why? Because this body has different property and this tip, ये टिप अभी जो ब्लैक हो चुका है, initially it was white, so this has different property. So बेटा different property, non homogeneous. अगर ये टिप नहीं होती, सिंगल मटेरियल का बना होता, so I would have called it a homogeneous material. Okay, so in simple language, one single material homogeneous, different material non homogeneous, that's it. Okay, now ये तो हो गया एक पर्टिकुलर टाइप ऑफ कैटेगराइजेशन वेयर वी आर सीइंग एट डिफरेंट पॉइंट्स वेदर द प्रॉपर्टी इज सेम और नॉट. ओके, बट एट डिफरेंट डायरेक्शंस प्रॉपर्टीज आर सेम और नॉट, दैट विल डिपेंड अपॉन वेदर इट इज आइसोट्रॉपिक, ऑर्थोट्रॉपिक और एनाइसोट्रॉपिक. तो अब एक ही पॉइंट लेंगे बट डायरेक्शन अलग अलग लेंगे. दिस टाइम आई विल कंसिडर वन सिंगल पॉइंट ओनली, बट आई विल कंसिडर डिफरेंट डायरेक्शंस. Okay, let me consider all these different directions. So in every direction, if I am getting the same property E, 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 then it is isotropic material. So all the metals, glass, all these are considered as isotropic material. Okay, anisotropic material means, एनआइसोट्रॉपिक मटेरियल का मतलब क्या? एनआइसोट्रॉपिक मटेरियल मींस इन डिफरेंट डायरेक्शन you are getting different values. Okay, so here I am getting E1, E2, E3, E4, E5. So 5 different properties in 5 different directions. So this is what anisotropic material. And in which case do you get this? In case of composite material. Let's say you have infused 2-3 different materials into one single material, so that becomes anisotropic, that may become anisotropic in different directions, different properties. Now there is a third material called orthotropic material. अब orthotropic का मतलब क्या है? Orthogonal means 90 degree to each other. Okay, तो ऑर्थोट्रॉपिक का मतलब क्या है? दैट इन म्यूचुअली परपेंडिकुलर डायरेक्शंस यू हैव डिफरेंट प्रॉपर्टीज. म्यूचुअली परपेंडिकुलर डायरेक्शन में प्रॉपर्टी अलग अलग. सो बेटा व्हाट इज द बेस्ट एग्जांपल फॉर दिस? द बेस्ट एग्जांपल फॉर दिस इज वुड. द मटेरियल्स विच आर मेड इन लेयर्स. प्लाईवुड अगर आप देखोगे, दैट इज मेड इन लेयर्स. So that material is an orthotropic material. ठीक है बेटा, don't get into too much detail. Okay, you just need to understand these different types of material. एकदम डिटेल में घुसने की जरूरत नहीं है, because in our syllabus we only have homogeneous and isotropic material. So you don't have to get into the detail of orthotropic material, and if you want to understand them in detail, then you can watch my complete lecture. Otherwise you don't have to keep everything in mind. सिर्फ इतना जान लो, that is enough. Okay, let me tell you beta, whatever I am explaining here, whatever I am going through here, you only need that much explanation for the exam. एकदम एग्जाम पॉइंट ऑफ व्यू से अगर मैं आपको बोलूं कि क्या समझना चाहिए, क्या ध्यान में रखना चाहिए, so only this much. Is it clear to everyone? I hope this is clear to everyone that you don't need to get into too much detail. ऑर्थोट्रॉपिक क्या है उसके बारे में पूरा दिन लगा के आपको अब इस टाइम पे at this moment you don't have to get into that. Okay, when we were studying strength of material, then if you would have asked me, I would have told you that go read this book and you will understand everything about orthotropic material. But right now don't get into that. Okay, बस इसका एग्जाम्पल जान लो. इसका एग्जाम्पल क्या है मेरे भाई? वुड है. एनाइसोट्रॉपिक मटेरियल का एग्जाम्पल क्या हो सकता है? कंपोजिट मटेरियल. ओके, और इसका एग्जाम्पल क्या हो सकता है बेटा? मेटल्स. ओके, मेटल्स जितने भी हैं they can be considered as isotropic material. Okay, so beta I hope that you only need this, matlab I hope that you have understood this. Okay, Now elastic constants, what is elastic constants? Understand, okay, elastic constants क्या है ये समझ लो. Thank you so much guys, thank you so much भारती, अक्षय, thank you so much, thank you so much. अरे मेरे भाई जोशी जी, आप तो 10वीं में पढ़ रहे हैं, 10वीं के छात्र हैं, 10वीं के छात्र को इन सब की जरूरत नहीं है. हालांकि जेई में भी यू हैव दीज बेसिक कॉन्सेप्ट्स, जेई के लिए भी बेसिक कॉन्सेप्ट्स चाहिए, जेई और नीट के लिए. बट बेटा मैं आपको यही सजेस्ट करूंगा कि आप ये मत देखो. इफ यू वांट यू कैन गो टू आवर अनअकैडमी जेई चैनल एंड यू कैन वॉच दोज लेक्चर्स. ओके, आई विल नॉट वेस्ट योर टाइम. आप अनअकैडमी जेई के चैनल पे जाके वहां के लेक्चर्स देखें. यस यस यस, थैंक यू सो मच गाइस फॉर ऑल द लव एंड सपोर्ट. यस यस, चलो. तो बेटा इलास्टिक कांस्टेंट्स क्या है? व्हाट आर इलास्टिक कांस्टेंट्स? इलास्टिक कांस्टेंट्स आर बेसिकली मटेरियल प्रॉपर्टीज. ओके, they are dependent on material. For different material their values are different. They are the relation between stress and strain. See, all these stresses are related to all these strains, and these stress and strains are related by what? Elastic constants. Okay, now elastic constants will define how much strain will be there. Strain value, how much strain will you get, that depends upon elastic constants. Stress does not depend upon material property, stress does not depend upon elastic constants, strain depends upon elastic constants. Yes, strain depends upon elastic constants. Okay, types of elastic constants. So we have 4 types of elastic constants: modulus of elasticity, modulus of rigidity, bulk modulus, and Poisson's ratio. Okay, now if you find the ratio of normal stress and normal strain, then it is known as Young's modulus or modulus of elasticity. Now what is the unit of this? Gigapascal. Okay, इसको usually हम gigapascal में denote करते हैं. 1 gigapascal is equal to 10 to the power 9 pascal or 10 to the power 3 megapascal, right? Young's modulus of steel, if you want you can remember, is almost 200 gigapascal. याद रखना है तो रखो, otherwise no need. Okay, gate में you don't need to remember these values. Okay, so beta this is Young's modulus. Then modulus of rigidity or shear modulus, G is the ratio of tau and gamma. Again, it is also expressed in gigapascal. Bulk modulus is the ratio of volumetric stress and volumetric strain. Volumetric stress मतलब hydrostatic stress. Okay, hydrostatic stress is sometimes called as volumetric stress also. Okay, हाइड्रोस्टैटिक स्ट्रेस को वॉल्यूमेट्रिक स्ट्रेस भी बोलते हैं. एक बार एग्जाम में आ चुका है ये नाम. ओके, वंस they gave this, find the volumetric strain. A lot of students got confused. What is volumetric stress? Volumetric stress is nothing but hydrostatic stress. So K is the ratio of sigma and volumetric strain. Okay, so if there is volumetric stress, sorry, hydrostatic stress, then sigma by epsilon V is bulk modulus. Okay, now Poisson's ratio. So what is Poisson's ratio? Let's say we have a circular bar. मान लो अपने पास एक circular bar है, ठीक है? This is the length and this is the width. Now I am applying axial tensile load. So length will also change and diameter will also change. Okay. Now Poisson's ratio mu is defined by minus of epsilon lateral by epsilon longitudinal. Now why minus sign? Because lateral and longitudinal strain have opposite sign na. So if you are putting this minus, then minus minus will become plus. तो यहाँ पे it will become minus of delta d by d upon delta L by L. Ultimately it will be positive, because if del L is positive, delta d will be negative. So negative negative becomes positive. Now Poisson's ratio values you need to remember. Okay, so beta Poisson's ratio for cork is 0. Poisson's ratio for rubber is 0.5. Okay, so beta for isotropic materials पॉइजन्स रेशियो इज बिटवीन 0 to 0.5, ठीक है, आइसोट्रॉपिक मटेरियल के लिए. बट फॉर सम मटेरियल Poisson's ratio can also be -1. This you have to keep in mind because theory में एक बार क्वेश्चन आ गया था कि what is the possible value of nu. तो बेटा for isotropic material it is 0 to 0.5. But for some other material other than isotropic, anisotropic material के लिए nu can be -1. Okay, is this clear? So you have to remember them. Young's modulus, shear modulus, bulk modulus, you don't have to remember, but this you have to remember, okay? Because there will be question based on this. For which material mu is 0, for which material mu is 0.5, for which material mu is 0.5. बेटा देखो ये सब फालतू की बातें आप मत करें क्लास में, तो यही अच्छा है, ओके? ये सब फालतू की बातें आप मत करें क्लास में, तो यही अच्छा है. You guys are here to study, so please focus on that. Don't tease anyone, don't harass anyone, okay? This is not good, okay? This is not good. This is unnecessary and unacceptable. So if someone does that in my class, at least my class, then I will block them. So I request you, all of you, please don't harass anyone. किसी को भी harass ना करें, bully ना करें और इस तरीके की घटिया बातें ना करें. अच्छी तरह पढ़ने आए आप लोग पढ़ाई करें. Okay, so please focus on that. Okay, don't make any nuisance. Okay, इस तरीके के nuisance ना करें. Thank you so much for understanding. Thank you so much. So बेटा, these are the elastic constants. Now relation between elastic constant, this is the most important topic, okay? For isotropic material, these relations are only valid for isotropic material. Remember what did I tell you? Throughout strength of material, whatever we study, that is only valid for isotropic material. Sirf isotropic material, ठीक है? Sirf isotropic material. So beta, there are two relations that you need to remember. E equals to 2g 1 plus nu and E equals to 3k 1 minus 2 nu, and these two are very important. Why? Because you will get theory questions from them, you will get numericals from them. ठीक है, आपको theory questions भी मिलेंगे इस पे, numericals भी मिलेंगे. For example, I will give you one value out of E, G, nu, K. I will give you two values, E and G, and I will ask you what is nu, or I will give you E and nu, I will ask you what is K. So these types of numericals you get from this, okay? Now apart from this there are other relations also, but you don't need to remember them. If you remember these two, that is enough. ठीक है, अगर आपको ये दोनों याद है तो आप बाकी सारे खुद से कर लोगे, okay? बाकी सारे आप खुद से कर लोगे, okay? चलो, so बेटा this is very important, okay? Now Hooke's law, this is the most important law. So what is Hooke's law? According to Hooke's law, stress is directly proportional to strain, and if you remove this proportionality sign, then you get this: stress is some elastic constant multiplied by strain. So now from here you understand why elastic constants are important, because they relate stress and strain. Stress और strain के बीच का वो bridge है, that is the bridge between stress and strain, okay? So बेटा strain value will depend upon this. Stress is independent of this. Stress independent है तो उसकी value यहाँ रखोगे और elastic constant की value यहाँ रखोगे तो क्या मिल जाएगा? Strain, okay? Now for simple loading means if there is one sigma, मान लो सिर्फ सिग्मा लग रहा है या सिर्फ टाउ लग रहा है, मतलब सिंपल लोडिंग है, देन Hooke's law is very simple. Sigma is proportional to epsilon, sigma is E into epsilon, okay? Here tau is proportional to gamma, tau is G into gamma, okay? So for single load it is very easy. But what if we have all the stresses and all the strains, okay? So beta, this will be proportional to this. So in this case, if you write the Hooke's law, then you get this: epsilon x is equal to sigma x by E minus nu sigma y by E minus nu sigma z by E. Similarly, epsilon y is equal to sigma y by E minus nu sigma x by E minus nu sigma z by E, and epsilon z is equal to sigma z by E minus nu sigma x by E minus nu sigma y by E, and gamma xy is equal to tau xy by g, gamma xz is equal to tau xz by g, and gamma yz is equal to tau yz by g. So these are the 6 relations. Why 6? Why not 9? Because 3 are not needed na. They are complementary stress and strain, तो उनको अलग से काउंट करने की जरूरत नहीं है. So that's why we have 6 stress strain relations. Okay, so this is known as generalized Hooke's law. Generalized Hooke's law. Okay, now if you see, there are so many elastic constants, but you don't need all of them. All you need is, in case of isotropic material, for triaxial stress, you need 2 constants. For biaxial stress, you need 2 constants. For orthotropic material, for triaxial stress, अब orthotropic है तो EX, EY, EZ, nu X, nu Y, nu Z ऐसे अलग अलग आएगा. So for orthotropic material under triaxial loading, you need 9 elastic constant. Biaxial में only 4. And anisotropic material में, in case of triaxial stress, you need 21, and biaxial stress you need 6. So these are the minimum elastic constant. Minimum कितने E, mu और G पता होने चाहिए, तो minimum इतने E, mu, G पता होने चाहिए. And this is the table which you need to remember. ये आपको रट्टा मारना है. बेटा मैंने आपको बार बार बोला है, if you have any doubt, then beta you can just watch my full course of strength of material. Click on the link given above. जो टॉप पे आपको लिंक दिख रही है tinyurl.com/approve10, click on that. You will open one Excel sheet of SOM. Look at that Excel sheet. You will find all the lectures. तो जो भी डाउट है वहां से आप क्लियर कर सकते हैं. यस, वेरी गुड अजय, वेरी गुड जय, वेरी गुड प्रेम. सो बेटा यू नीड टू मेमोराइज देम. ये टेबल रट्टा मारना है आपको. ओके, ये आपको टेबल रटी होनी चाहिए. ओके, नाउ स्ट्रेस स्ट्रेन कर्व. तो बेटा स्ट्रेस स्ट्रेन कर्व इज द ग्राफ बिटवीन stress and strain which we draw for ductile materials and brittle materials. तो बेटा x एक्सिस पे हम ड्रॉ करते हैं क्या, परसेंटेज स्ट्रेन और सिर्फ स्ट्रेन. where percentage strain is what, percent strain is 100 times of strain. okay, तो x एक्सिस पे परसेंटेज स्ट्रेन, y एक्सिस पे सिग्मा, and this is द स्ट्रेस स्ट्रेन कर्व. ठीक है, स्ट्रेस स्ट्रेन कर्व जो है वो कुछ ऐसा दिखता है. ओके, फॉर डक्टाइल मटीरियल. नाउ व्हाट आर द इंपॉर्टेंट पॉइंट्स? लेट्स से इट स्टार्ट्स फ्रॉम ए, ओ, देन ए, बी, सी, डी, ई, F. Okay, what are the important points? If I write them down, then A is known as what? सबको पता है मेरे भाई. A is what? Proportional limit. B is what? Elastic limit. C is what? Upper yield point. D is what? Lower yield point. E is what? Ultimate point. And F is what? Fracture point. ठीक है, तो बेटा दिस इज द स्ट्रेस स्ट्रेन कर्व फॉर डक्टाइल मटीरियल. ओके, अब इस स्ट्रेस स्ट्रेन कर्व को वी कैन डिवाइड इनटू 4 डिफरेंट रीजन्स. 1 रीजन, 2nd रीजन, 3rd रीजन एंड 4th रीजन. ओके, what is this first region? What is this first region? The first region is elastic region. What is this second region? Plastic region. What is this? Strain hardening. And what is this? नेकिंग, है ना? तो ये 4 डिफरेंट रीजन्स में हम डिवाइड कर सकते हैं, 4 डिफरेंट रीजन में हम डिवाइड कर. वेरी गुड अक्षय, वेरी गुड गाइस, वेरी गुड. बट दिस इज फॉर माइल्ड स्टील. माइल्ड स्टील के लिए, ठीक है. एल्यूमिनियम के लिए इफ यू ड्रॉ द सेम स्ट्रेस स्ट्रेन कर्व तो थोड़ा सा अलग बनता है. एल्यूमिनियम का स्ट्रेस स्ट्रेन कर्व इज डिफरेंट. एल्यूमिनियम में यू गेट स्ट्रेस स्ट्रेन कर्व लाइक दिस. यू डोंट गेट अपर यील्ड और लोअर यील्ड. Then how do we find the upper or lower yield? हम यहाँ yield point कैसे निकालेंगे? So what do we do? From 0.2% strain, 0.2% strain, we draw a straight line like this, which will be parallel to this line. Okay, parallel to this line. और जहां ये इसको क्रॉस करता है, that is defined as yield point. है ना? So this is for a lot of ductile material such as aluminum. ठीक है, ये mild steel का है. This is for aluminum. Okay, yes, yes. Then for brittle material, अब brittle material के लिए तो it is very simple. brittle material में तो कोई याद रखने की जरूरत ही नहीं है. brittle material में stress strain curve is like this. Very simple. There are only 2 points to notice here. Okay, this is point A, point B. Point A is proportional limit. Here also initially stress will be proportional to strain, and point B is the fracture point, or you can call it ultimate point. Okay, so brittle material stress strain curve is very small because they don't elongate that much. ये उतना ज्यादा elongate होते ही नहीं है, तो इसीलिए इनका चालू होते ही खत्म. Okay, so this is for ductile material and this is for brittle material. Okay, now there are certain material properties that you can find using stress strain curve. The first one is the strength. What is the strength? It is the maximum magnitude of stress that the material can sustain without failure. बिना फेल हुए स्ट्रेस कितना झेल सकता है, that is the strength. Now there are 2 types of strength, yield strength and ultimate strength. What is yield strength? Yield strength मतलब क्या? तो मेरे भाई, let's say we have the stress strain curve of ductile material like this. Okay, तो बेटा up to yield point whatever stress it can sustain, that is known as yield strength, and ultimate point पे whatever stress it can sustain, that is known as ultimate strength. Right, now these are the strength in tension. There are strength in compression and there are strength in shear also. Strength in compression and strength in shear also. So for ductile material, you will notice that strength in tension and compression are equal and strength in shear is minimum. But when it comes to brittle material, and this you need to remember, ये आपको याद रखना है मेरे भाई. Okay, why? There will be questions from this in exam. Ductile material is weak in tension, compression or shear, so it is weak in shear. And when it comes to brittle material, strength in compression is maximum, then strength in shear, and minimum one is, sorry यहाँ पे yield नहीं रहेगा, brittle में yielding नहीं होती, तो strength in compression will be maximum, then strength in shear, and least will be strength in tension. तो ये shear में weak है, ductile materials are weak in shear, और ये टेंशन में वीक है, ब्रिटल मटेरियल्स आर वीक इन टेंशन। यस यस, हाँ मेरे भाई, यस, चालू होते ही खत्म। यस आदित्य, इवन इफ यू हैव नॉट रेड स्ट्रेंथ ऑफ मटेरियल एवर, अगर आपने आज तक स्ट्रेंथ ऑफ मटेरियल नहीं भी पढ़ी है, देन ऑल्सो इट विल बी वेरी हेल्पफुल फॉर यू। ओके, देन ऑल्सो इट विल बी वेरी हेल्पफुल फॉर यू। मेरे भाई आदित्य, आप बिल्कुल पढ़ सकते हैं बेटा। ऑल ऑफ यू हु आर लाइव राइट नाउ, प्लीज हिट द लाइक बटन, प्लीज शेयर द लिंक, please show your love and support, like this till the end. Thank you so much for such a lovely response. I never imagined that I will get such a lovely response. Thank you so much, I love you all, thank you so much. Okay, तो मेरे भाई ये याद रखना, you have to remember this. Okay, what did I tell you? मैं जो भी लिख रहा हूं वो रट्टा मारना है मेरे भाई, वो याद रखना है। Okay, so बेटा this is the first property, strength. Then the second property, ductility. How much plastic deformation you are going to get, कितना इसको मैं खींच सकता हूं पकड़ के, कितना मैं इसको कंप्रेस कर सकता हूं, that is ductility, and it is denoted by percentage elongation। या तो आप percentage elongation निकाल लेते हो, मतलब L final minus L original by L original, या percentage reduction in area। अब एरिया कम हो रहा है तो A original minus A final by A original, okay, and it is in percentage, so multiply by 100, okay। So either we calculate this, means how much it can elongate or how much it can compress, कितना खींच सकते हैं या कितना चिपटा सकते हैं, that is ductility, okay। Then resilience, how much energy it can store। हथौड़े से पीटोगे, if you strike the body, when it will deform, it will store some energy, okay। Even if you apply normal load, it will store some energy, okay। How much energy it is storing, that is the modulus of resilience, okay। What is modulus of resilience? Let's say we have this stress strain curve, मान लो ये stress strain curve है, then the area up to yield point, यील्ड पॉइंट तक का एरिया जो है दैट इज नोन एज मॉड्यूलस ऑफ रेजिलियंस, मॉड्यूलस ऑफ रेजिलियंस, ओके। सो मॉड्यूलस ऑफ रेजिलियंस इज व्हाट, इट इज इक्वल टू एरिया अंडर सिग्मा एप्सिलॉन अप टू यील्ड पॉइंट, ओके। So this is equal to SYT square by 2E. इसका फॉर्मूला होता है SYT square up to yield point. What is the stress? SYT. So it comes SYT square by 2E. Okay. Next, toughness. Now toughness is also the ability to store energy, but this will be the ability to store energy up to fracture point. ये क्या रहेगा मेरे भाई, एबिलिटी टू स्टोर एनर्जी अप टू फ्रैक्चर पॉइंट। तो दिस टाइम आई हैव टू कंसिडर द एंटायर एरिया, ओके। दिस विल बी व्हाट, दिस विल बी माय मॉड्यूलस ऑफ टफनेस, ओके। सो दिस एरिया इज मॉड्यूलस ऑफ रेजिलियंस, दिस एरिया इज मॉड्यूलस ऑफ टफनेस। फॉर दिस वी डोंट हैव अ फॉर्मूला, ओके। इसके लिए कोई फॉर्मूला नहीं है, ओके। नेक्स्ट इज ट्रू स्ट्रेस स्ट्रेन। सो व्हाट इज ट्रू स्ट्रेस स्ट्रेन? सो बेटा लेट्स से आई एम अप्लाइंग लोड ऑन द बॉडी, ठीक है, मैं बॉडी के ऊपर लोड लगा रहा हूं, ओके, मैं बॉडी के ऊपर लोड लगा रहा हूं ऐसा। देयर इज सम इनिशियल एरिया, सम फाइनल एरिया, इनिशियल लेंथ एंड फाइनल लेंथ। तो बेटा इफ आई यूज दिस इक्वेशन, original area, original length, then this is engineering stress and engineering strain. But if I use this final area, final length, so this is known as true stress strain, okay। डिटेल में समझना है अगेन बेटा, फुल कोर्स देखो, दिस इज जस्ट अ रिवीजन, so you need to just memorize these equations, ठीक है। आपको बस ये मेमोराइज कर देना है बेटा। शियर फोर्स बेंडिंग मोमेंट डायग्राम आई विल एक्सप्लेन लेटर, सबकी बारी आएगी, उसको बारी बारी से पढ़ना है। इफ यू आर सो मच इन अ हरी देन यू कैन वॉच द रिकॉर्डेड लेक्चर, ठीक है। अगर आपको इतना ज्यादा उत्सुकता है, अगर आप में पेशेंस नहीं है, अगर आप उन लोगों में से हो जिनको ना 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 मेरे को अभी शियर फोर्स बेंडिंग मोमेंट डायग्राम अभी चाहिए, अभी चाहिए, नहीं 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 सर प्लीज अभी पढ़ाओ, तो बेटा यू कैन वॉच द रिकॉर्डेड लेक्चर ऑफ शियर फोर्स एंड बेंडिंग मोमेंट डायग्राम। ओके, सो बेटा दिस इज व्हाट ट्रू स्ट्रेस and true strain. Okay, yes, I need to block these kind of people, but सुधर जाएंगे, ये लोग भी सुधर जाएंगे। Now power law, very important law because we have numericals based on them. So according to power law, sigma equals to epsilon t, sorry, k into epsilon t whole to the power n. अब ये क्या है मेरे भाई? ड्यूरिंग प्लास्टिक डिफॉर्मेशन के टाइम ये जो कर्व बनता है, इट इज द इक्वेशन ऑफ दैट कर्व। ओके, लीनियर के लिए तो वी डोंट नीड रिलेशन, सिग्मा इज ई इंटू एप्सिलॉन, बट ये पैराबोलिक जो कर्व बन रहा है, दिस इज सम पैराबोलिक कर्व, दिस इज द इक्वेशन फॉर दैट। ओके, इट्स जस्ट एन अप्रोक्सीमेट रिलेशन वेयर सिग्मा टी एंड एप्सिलॉन टी आर ट्रू स्ट्रेस स्ट्रेन। व्हाट इज के? दिस इज नोन एज strength coefficient, and what is n? This is known as strain hardening exponent, ठीक है, and the value of n varies from 0 to 1. Okay, now there is a very important point which you need to remember. At ultimate point पे एप्सिलॉन टी इज इक्वल टू एन, ठीक है, ये पॉइंट भी याद रखना है। सो यू नीड टू रिमेंबर दिस एंड दिस। सिग्मा टी इक्वल्स टू के इंटू एप्सिलॉन टी होल टू द पावर एन, एंड एप्सिलॉन टी इज इक्वल टू एन व्हेन एट द अल्टीमेट पॉइंट। अल्टीमेट पॉइंट का जो एप्सिलॉन टी होता है, एप्सिलॉन टी विल वैरी एट एवरी पॉइंट, अल्टीमेट पॉइंट पे जो एप्सिलॉन टी होता है वो किसके बराबर होता है? जो भी n होता है। फॉर एग्जांपल लेट्स से n इज 0.3, तो एट डिफरेंट पॉइंट्स एप्सिलॉन टी विल बी डिफरेंट, बट व्हेन इट विल रीच अल्टीमेट पॉइंट एप्सिलॉन टी विल बिकम 0.3। ओके, सो बेटा दिस यू नीड टू रिमेंबर बिकॉज देयर हैव बीन क्वेश्चंस फ्रॉम दिस टॉपिक्स। इन टॉपिक्स पे, इस टॉपिक पे क्वेश्चन आ चुका है रिसेंटली 2019 में, 2017 में क्वेश्चन आया है इसके ऊपर। तो मेरे भाई this is also very important. So this is the end of the first chapter. फर्स्ट चैप्टर का हमने खात्मा कर लिया है, फर्स्ट चैप्टर का हमने खात्मा कर लिया है। सो आई हैव शोन यू द एंटायर सिलेबस, राइट? मैंने आपको पूरा सिलेबस दिखाया था। आई हैव शोन यू द एंटायर सिलेबस। सो दिस वाज द फर्स्ट, दिस वाज द सिलेबस, राइट? कहां गया? This was the syllabus and I told you introduction to stress, introduction to strain and material properties. These are one chapter, right? अब इसके बाद chapter 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 इसमें there are calculations of stress and strain. So we need to see the formulas and the sign convention for the calculation of stress strain. कैलकुलेशन ऑफ स्ट्रेस स्ट्रेन के लिए क्या फॉर्मूला होता है, क्या साइन कन्वेंशन होता है, किस टाइप के प्रॉब्लम में क्या मेथड यूज करते हैं, फॉर विच प्रॉब्लम विच मेथड डू वी यूज, आई विल क्विकली रिवाइज दैट। ओके, मैं आपको क्विकली गो थ्रू करूंगा कि कौन से टाइप के क्वेश्चंस आते हैं, किस टाइप का आपको फॉर्मूला लगाना रहता है, हाउ दीज टाइप्स ऑफ प्रॉब्लम्स आर सॉल्व्ड, हाउ दीज टाइप्स ऑफ प्रॉब्लम्स आर सॉल्व्ड। सो वन क्विक रिविजन, वन क्विक ग्लांस ऑन ईच टाइप ऑफ प्रॉब्लम, ठीक है? So beta chapter 2 onwards we will see the formula and sign convention required for the calculation of stress and strain. I hope all of you are enjoying, I hope all of you are studying well, I hope आप लोगों को मजा आ रहा है। यस, जय, अक्षय, पुजारी, धनंजय, प्रेम, ग्रबलर, भारती, करण, यस, why other people are not responding? I want to know the name of each and every one. So please give your attendance. Please give your attendance. Please tell me whoever is live. Yes, century, double century. Yes, thank you so much for this double century. But this should have triple century, quadruple century. जितने भी centuries हो सकती हैं possible. Yes, I want that. Yes, yes, yes. Varun, yes. Beta, everyone, please give your attendance. Yes, Gopala Krishna. Yes. Pannilal Kushwaha, yes. Prem, yes, 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 yes. Thank you so much for all the love and support. Yes, Rohit, yes, Akshay, yes, Prabhakar, yes, Naved, Nitin, yes, Deepak, Riju, Ravi, Monu, Varun, Karan, Ankur, Aditya, Saurabh, Deepak, Ravi, Sushrut, Vinay, Bhushan, Sadik, Monu, Rajesh, Ayush, Deepak, MK Yadav. Thank you so much. Thank you so much. Ajay, Aditya. Yes, yes. This is the power of Unacademy Gate MEPIXC. This is the family Unacademy Gate MEPIXC. And I miss all of you in my all sessions. I remember all these names popping up again and again. So I feel like we are connected together. I feel like I have known you for quite some times. Yes, Anna. Yes, Parmeshwar. यस 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 चलते रहना चाहिए बेटा. ये लाइक बटन का जो काउंटर है, दिस शुड कीप ऑन गोइंग. इट शुड रीच 300, 400, even 500, right? Till the lecture ends. The lecture will end at 5 p.m. We have 8 hours marathon session. We will complete all these chapters, right? So chapter 1 completed. Let's quickly go through chapter 1. तो मैंने chapter 1 में आप लोगों को क्या क्या समझाया है? This is the quick revision, and you can see that I am making neat and clean short notes. मैं neat and clean notes बना रहा हूं so that बेटा you can download this PDF and you can save it and you can go through this during your final revision. आप अपने final revision के time में इसको go through कर सकते हो बेटा. Neat and clean writing, neat and clean diagrams, neat and clean values, and I am only writing the things which you will need. आपको जिन चीजों की जरूरत पड़ेगी. Yes, अक्षय, नाम तो याद हो गया है अब. No need of thanking me, beta. No need of thanking me. This is all for my students, my people, my lovely friends, and I will keep on taking these classes until and unless you keep on showing your love and support. Until you keep showing your love and support, I will keep on taking these classes. जब तक आपका प्यार और support है, मैं ये classes लेते रहूंगा. जितनी classes चाहिए, I will take all those classes. Okay. In fact, all of the people in our channel will take those classes. Okay, so let's start chapter 2. Let's start chapter 2. Thank you so much, Varun. Thank you so much. Yes, even I feel connected to all of you, right? This is our connection. This is our connection. Unacademy Gate MEPIXC family. Yes. Chalo. Oh, Arnav, where are you from? EC what? Indore, Bhopal, Allahabad. Which EC? Thank you so much. Thank you so much. So beta, let's start with chapter 2, axially loaded member. Now beta, you might have noticed that in strength of materials, there are different types of loading, and in different types of loading, you study about different types of members. हर एक member में, structure में, हर एक member में अलग type का load लगता है. There are bars, there are beams, there are columns. So beta, in different member, there are different types of loading. So you will see that the name of the chapter is based on the type of member. Shaft के ऊपर एक chapter है, bar के ऊपर एक chapter है, beam के ऊपर chapter है, column के ऊपर chapter है. So there are different chapters based on different members. अरे Arnav, I also live in Indore. Yes beta, Monu, you will get the PDF. You will get the PDF in my Telegram channel, and I will also upload the PDF here. tinyurl.com/Apuroop10. ठीक है, आप tinyurl.com/Apuroop10 में चले जाना, वहां PDF मिलेगी. और you just follow me on Telegram. Okay, my Telegram channel name is Apuroop10. APUROOP10. So just search my Telegram channel and I will upload that PDF in the Telegram channel. Yes, Arnav, I remember last year October November में I came to SGS ITS Indore, right? In order to teach strength of materials and machine design. Yes, yes. Welcome Rahul, welcome. Now you will be a permanent member of this channel, Unacademy Gate MEPIXC. This is a promise because you will never be able to leave our classes. Okay, so beta, hit the like button, share this and subscribe to our channel. Jai Mahakal Monu, Jai Mahakal, Jai Mahakal. You can see Mahakal tattoo on my hand. Jai Mahakal. Yes. Chalo. So let's start beta, axially loaded members. So what is axial loading? Axial loading means there is a load acting along the length, okay? Because usually structural members are slender members. Slender members means one dimension is very large compared to other two dimension, and this dimension which is large will be length. So usually the load is acting along the length. So this load is known as axial load. But beta, when we say axial load, there is a very important assumption there. What is that assumption? We assume that the axial loads are concentrated at the centroid. एक्सियल लोड कहां एक्ट कर रहा है? हम अज्यूम करते हैं कि ये एक्ट कर रहा है सेंट्रॉइड पे. ओके, दिस इज आवर अजम्पशन. ओके, दिस इज आवर अजम्पशन. व्हेन वी से एक्सियल लोड, बाय डिफॉल्ट इट इज centroid. Okay, now there are some assumptions which we make during this chapter, axially loaded members. What are those assumptions? The material of the bar is homogeneous and isotropic. I told you every chapter will have this assumption: isotropic material, homogeneous material. Bar is of constant area. Axial load passes through centroid. See, I told you, we assume that axial load passes through centroid. If the axial load does not pass through centroid, it will apply moment, and in this chapter we don't study moment. Okay, then stresses are within proportional limit. Now why we assume this? Hooke's law, so that we can apply Hooke's law. Okay, now beta, there are two relations that you need to see. First is the equation of stress. So if we are applying load P, and if I consider the cross sectional plane, cross section का plane अगर मैं लूं, then you will notice that on this plane all the forces are equal. At every point the force is equal. So in this case the stress equation we get is very simple: P by A. This is the equation of stress we get. Sigma equals to P by A. And the equation of strain or elongation. So what is the equation of elongation we get? Delta L equals to PL by AE. PL by AE. Okay, but ये equation कब valid रहती है? This equation is valid if P, A and E are constant. But मान लो we have a tapered bar, और tapered bar में P, A में से A constant नहीं होता, then in that case which equation do we use? We use this equation: delta L equals to integration P dx by AE from 0 to L. So if area is not constant, then you will put the equation of area in terms of x, integrate, you get del L. If P is not constant, you get equation of P in terms of x, you put it, integrate, and you get del L. If E is not constant, then you put equation of E in terms of x, integrate, you get del L. So beta, this is the equation of delta L. Okay, so this is the elongation of the bar. अब यहाँ से there are two very important definitions that you need to remember. The first is axial rigidity. अब axial rigidity is what? Axial rigidity is defined by A into E. Why? If A into E is very large, then delta L will be very small, and we will say that the material, the bar is very rigid. And the second is axial stiffness. अब axial stiffness क्या होता है बेटा? Stiffness in general क्या होता है? What is stiffness? Stiffness is load required for unit deformation, means P divided by delta L, और P divided by delta L क्या हो जाएगा? AE by L. So you need to remember these two definitions beta, these two equations: axial rigidity and axial stiffness. Okay, axial rigidity is A into E, axial stiffness is AE by L. A into E, AE by L. Okay, so this is axial rigidity and stiffness. Just like this we have flexural rigidity and stiffness, torsional rigidity and stiffness. आगे मैं बताऊंगा. Okay, आगे I will give you that equation also. Remember, बार बार बोल रहा हूं, whatever I am writing you have to remember that only. बस उसको छोड़ के और कुछ दिमाग में रखने की जरूरत नहीं है. Nothing else you need to keep in mind. Just remember these things. Okay, जो लिख रहा हूं, whatever I am writing, you need to remember this and you need to repeatedly revise this. So don't think that if you have revised Psalm once, it is over. No, repeated revision you need. बार बार. If I take a Psalm marathon session next week, if I take a revision session next week, and if you have time, then watch that revision class also. Whoever is taking revision class or practice class for this 15-20 days, you need to repeatedly do that. बार बार पढ़ोगे, दिमाग में छप जाना चाहिए, इतना छप जाना चाहिए. Whenever you will get a question in exam, in final exam, when you get a question, you don't even have to think about the formula. That formula should be on your fingertips. आपके fingertip में वो formula आ जाना चाहिए, इतना रटा जाना चाहिए, दिमाग में ऐसा बैठ जाना चाहिए. It should be imprinted on your mind that if you see the question, the formula automatically you will write. So when you do that, then you will have a chance to get a very good score in GATE. Okay, so that is what I will suggest all my students. Okay, now how to calculate internal force. So beta, in different cases you will see that you need different internal force in different members. Let's say we have a bar like this. Okay, let's say this is point A, point B, point C and point D. Okay, now you will notice that there are different forces acting at A, B, C, D. So in this case, what do? In this case, we divide this in different parts. हम इसको 3 पार्ट में डिवाइड कर देते हैं, A, B, B, C and C, D. And in every part, the internal force will be different. तो कैसे कैलकुलेट करते हैं मेरे भाई इंटरनल फोर्स? Let's say I want to find internal force between A, B. A और B के बीच में बस एक पॉइंट बना लो, just one point between A and B, and calculate the total force either on the left of this point or on the right side of this point, right? And when you calculate the total force, tension positive, compression negative, so left में there is only one force, 100 kilonewton, so this will be plus 100. Okay, टेंशन को प्लस, कंप्रेशन को माइनस. देन पीबीसी, तो पीबीसी के लिए कंसिडर अगेन 1 पॉइंट. नाउ टोटल फोर्स ऑन द लेफ्ट ऑफ दिस पॉइंट विल बी हाउ मच? इसके लेफ्ट में टोटल फोर्स कितना होगा? 100 पॉजिटिव, 170 नेगेटिव. तो आई विल राइट इट 100 माइनस 170. Right? Or right say if you see, then you will notice 50 positive, 120 negative. So 50 minus 120, both will give you same answer, minus 70, minus 70, right? You can calculate it from right, you can calculate it from left. And force in CD. So if you consider 1 point between C and D, then on the left side 100 plus 120 minus 170, or right side there is only one force, 50. So beta, this is how you calculate internal force. Now once you get internal force, very good. मेरे भाई पूरा रिवीजन होगा, entire syllabus will be revised. Deflection of beams, complex stress strain, shear force bending moment diagram. मेरे भाई अंकुर, I will explain shear force bending moment diagrams using different examples. So don't worry. Okay, अलग अलग example लेके समझाऊंगा तो सब कुछ समझ में आएगा. Okay, don't worry, you will understand everything. You will understand everything. Okay, so beta, PAB, PBC, PCD. Once you get this, you can calculate the stress force upon area, or you can calculate delta L, PL by AE. So beta, these are the internal forces. Other values will be given. Length will be given, area will be given, Young's modulus will be given, but P value you have to calculate like this. Okay. Now, elongation of prismatic bar due to self weight. अब self weight की वजह से elongation of prismatic bar कैसे निकालते हैं? So let's say we have a prismatic bar, constant area bar then the equation of delta L is this. Delta L is gamma L square by 2E or WL by 2AE. Okay. These are the formulas you need to remember. Now in this formula, what is gamma? Gamma is nothing but rho g. Rho is what? Density. So this is known as specific weight or weight per unit volume. Okay. For steel it is 77 kilonewton per meter cube. Okay. Steel के लिए 77 kilonewton per meter cube. Thank you so much Vivek, but beta that is not true. There are lot of teachers who are giving their 100%. In fact, everyone on this channel is giving their 100%. Everyone is putting a lot of efforts. Okay, so you have to watch other classes also, appreciate other teachers also. It is not true that only I am giving my 100%. Everyone, Negi sir, Pallav sir, Alok sir, everyone, Sandeep sir, Vishwajit sir, everyone, Manish sir, everyone who comes live and who takes class on this channel, beta, they are giving their 100%. They are working day and night in order to make these slides. They are working day and night in order to give you quality content. Okay, so appreciate everyone. Yes, so मेरे भाई self weight से delta L का formula is this, gamma L square by 2E or WL by 2AE. So you need to remember this much. Okay, so beta, this is the formula for prismatic bar. Now there is another. Now here W, capital W is what? Capital W is gamma into volume, means total weight. Capital W क्या है मेरे भाई? Total weight. So if specific weight is given, use this formula. If total weight is given, use this formula. Okay, in some question they will give you specific weight, in some question they will give you total weight. Okay, next is elongation of conical bar due to self weight. अब conical bar का elongation कैसे निकालते हैं? तो बेटा it is delta L equals to gamma L square by 6E, or again in terms of W the formula is same, WL by 2A. Okay, again gamma is total weight, gamma is specific weight, W is total weight. But area क्या है? Here the area is constant, so you know A is area. But here what is A? Because the area is different, so here A is the base area. A क्या है मेरे भाई? A is the base area. ठीक है, base area का मतलब क्या? What is base area? Let's say this is D, so this is what? Pi by 4 D square. Is base का area is A. Okay, so this is the formula for conical bar. In conical bar you will notice that area is also not constant, load is also not constant. Okay, now elongation of tapered bar. अब tapered bar के ऊपर direct question, formula question आता है. तो tapered bar में there are two types of tapered bar, circular and rectangular. So in case of circular tapered bar, diameter is changing D1 to D2. So here what is the formula? Delta L is equal to PL upon pi by 4 D1 D2 into E. Now here you notice one thing, that this formula is very similar to PL by AE. If you have a circular bar, then what will be the formula? PL by AE में PL by pi by 4 D square E. So it is very similar to that. Instead of D square की जगह क्या है मेरे भाई? D1 into D2. So only need to keep this in mind. PL by AE formula ही लगाना है. You only have to put PL by AE, but instead of D square, pi by 4 D square, you need to put D1 into D2. So just remember that the entire formula is same, PL by AE. Second is rectangular tapered bar. Now in rectangular tapered bar, the thickness will be constant. Rectangle में thickness and height, two dimensions are there. So thickness is constant, but the height is varying. So for here, what will be the formula? Now this formula will be a little tricky. So understand how you can remember this. PL upon B2 minus B1 upon natural log of B2 by B1 into T into E. Now what is B1 and B2? Different heights. Minimum height, maximum height. Now here how to remember the formula? So again, same concept. PL by AE. Okay. PL by AE. For rectangle, what will be area? Height into thickness. So beta here, instead of single height B, you are putting B2 minus B1 divided by natural log of B2 by B1. That's it. That's it. So beta, you only need to remember this much. If you see, this formula is given differently in different books. अलग अलग किताबों में अलग अलग तरीके से लिखा होता है. इसको ऊपर लेके चले जाएंगे या इसको साइड में लिख देंगे. But बेटा, I want you to memorize this formula in this format only. PL by AE. PL by AE. And in area, here instead of D square, just write D1, D2. Here instead of B, write B2 minus B1 by natural log of B2 by B1. So this is a small trick which will help you to memorize this formula. Okay. And in exam, from these concepts, bars subjected to self weight and tapered bar, you will get only formula based questions. Okay. आपको simple formula based questions आएंगे. If you remember the formula, then you can easily solve. Self weight से there are very few questions. Okay. Especially self weight से prismatic bar का question आता है. Conical bar का आज तक नहीं आया. And for tapered bar, they only give questions from circular tapered bar. They have never given question from rectangular tapered bar. Okay. But beta, it is not necessary that in your case also you will get question from this only. You have to remember everything. Yes, mere bhai, in some cases they will give you the formula. See, understand what is the thought process of people who are making questions for GATE. IIT professors, they don't want to test your memory. IIT professors don't want to test your memory. They want to test your aptitude. They want to see whether you are able to use this formula in different conditions or not. Whether you understand the meaning of this formula or not. Whether you remember the formula, they don't care. So in a lot of cases, you will see that they will give you the equation themselves. They will give you the formula themselves. वो फॉर्मूला दे देंगे. फॉर्मूले से उनको दिक्कत नहीं है. आपको फॉर्मूला याद है कि नहीं? They don't want to test that. इस फॉर्मूला को आप यूज कैसे कर पाओगे? Do you understand this formula? Do you understand the meaning of gamma or W? That they want to understand. Okay. So IIT professors don't test your memory, beta. That's why you will notice that you will never get a question, what is Young's modulus of copper? What is Poisson's ratio of aluminum? You will see these types of questions in government exams, PSU exams, ESE exams. Why? Because in those papers, they don't make the questions, they don't design the questions. They just copy the questions from textbooks, and that too very third class textbooks, Indian author textbooks. I am not saying every Indian author is of poor quality, but a lot of them are, because they don't spend time writing the books. They just copy paste from here and there. So they don't actually study, they don't actually research on their content. So their content is very poor quality. So beta, you will see that they get questions directly from those books. So those questions are very formula memory based questions. What is the Poisson's ratio of aluminum? Now why do I need that? I have Google. So even if I am working in IOCL, HPCL, BPCL, and if I want Poisson's ratio of some material, I will just Google it and I will tell you. Why do I need to remember the Poisson's ratio of every material? Why do I need to remember the Young's modulus of every material? तो बेटा आज की डेट में ऐसा नहीं करते. आज की डेट में आपको गेट के क्वेश्चंस जो मिलेंगे वो फॉर्मूला बेस्ड नहीं होते हैं, सॉरी वो मेमोरी बेस्ड नहीं होते हैं. फॉर्मूले के ऊपर अगर क्वेश्चन आएगा तो बहुत केसेस में आपको फॉर्मूला दिया रहेगा. So they want to check your aptitude. आप सोचते कैसे हो, whether you are able to apply the concept or not. Okay. एनडीए की तैयारी नहीं कराता मेरे भाई, मैं सिर्फ गेट और ईएससी के लिए और मैकेनिकल इंजीनियरिंग स्टूडेंट्स के लिए पढ़ाता हूं. यस 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 यस. चलो, so let's move on. So these are all the formula you need to remember. Now statically indeterminate bars. Understand what is statically indeterminate bar? तो मेरे भाई, let's say we have a bar, okay, and it is fixed at both the ends. इसको मैंने क्या किया, दोनों एंड पे फिक्स कर दिया. Okay, I have fixed this bar at both the ends. Let's say this is A, and let's say I am applying a force at a point B. ठीक है, let's say I am applying a force at a point B. Let's say the force is 10 kilonewton. Okay, now if I draw the free body diagram, then I will get one reaction at A and one reaction at C, and I don't know what are the directions of reaction, so I will assume some directions RC and RA. Okay, after solving, if I am getting positive, direction is right, negative, direction is wrong. So you will see that there are two unknowns and we only have one equilibrium equation. हमारे पास सिर्फ एक equilibrium equation है. So what is the equilibrium equation here? The equilibrium equation here is summation of fx equals to 0. And what will be that equation? Ra equals to 10 kilonewton plus Rc. So you have only one equation and two unknowns. So this is known as statically indeterminate bar. So in this case, you have a second equation known as compatibility equation. Now what do we mean by compatibility? Compatibility equation is the equation of constraint of deformation. How do a bar become statically indeterminate? ये bar statically indeterminate क्यों बना, कैसे बना? Complementary नहीं बेटा, compatibility. Okay, so बेटा, how this bar became statically indeterminate? Because I constrained the deformation of this bar. मैंने इस बार के डिफॉर्मेशन को कंस्ट्रेन कर दिया. अगर मैं सिर्फ एक एंड को फिक्स करता और यहां फोर्स लगाता तो ये फ्रीली एलोंगेट हो जाता, राइट? इफ आई फिक्स वन एंड and if I apply 10 kilonewton, it can freely expand. In that case, it will not be statically indeterminate. But if I am applying 10 kilonewton and if I fix both the ends, so now I have constrained the deformation, so it became statically indeterminate. So if you write the equation of that constraint, then it is known as compatibility equation. So what is the constraint here? The constraint here is delta L of AC is 0, which I can say delta L of AB plus delta L of BC. Now what will be delta L of AB? PL by AE. What is the P in AB? RA. So I can write it like this: RA into L of AB divided by area of AB into E of AB. What is the force in BC? I can write it RA minus 10 or RC. So this will become RC into L of BC upon A of BC into E of BC equals to 0. So this became our second equation known as compatibility equation. So by solving this and this, I get RA and RC. All the other values will be given. Length, area, Young's modulus will be given in the question. So beta, you will calculate RA and RC easily. Okay. So this is one case of statically indeterminate bar. Okay. There are other cases also. What are the other cases? Let's see the other cases. बाकी के cases देखते हैं. So in one case, you might get a question like this. ठीक है. हो सकता है एक ऐसा क्वेश्चन आपको दे दे. ओके, लेट्स से दे गिव यू अ क्वेश्चन लाइक दिस. लेट्स से आपको कुछ ऐसा क्वेश्चन दिया है. Let's say there is a question like this. Okay, this is bar number 1. This is bar number 2. Okay. And in this case, there is a statement written that for rigid beam to be horizontal, find axial force in 1 and 2. ठीक है, एक ऐसा क्वेश्चन दिया है. So beta, if you see, after applying a force W here, you will get one reaction here R1, one reaction here R2. Okay, so these will be the axial forces in bar number 1 and 2. I want R1 and R2. So beta, one equilibrium equation I have, summation of Fy equal to 0. तो वहां से I will get R1 plus R2 equals to W. Okay. But I don't have a second equation. So second equation will be compatibility equation. अब यहाँ compatibility equation क्या हो जाएगी? So read the question carefully and you will understand the compatibility equation. What is compatibility equation? It is the equation of constraint. तो constraint of deformation यहाँ क्या है? We have to keep the rigid beam horizontal. So the deformation in this bar and this bar must be equal. अगर एक ज्यादा डिफॉर्म हो गया, एक कम डिफॉर्म हो गया, then rigid beam will become like this. So here the compatibility equation will be delta L1 equals to delta L2. तो ये हो जाएगा R1 L1 by A1 E1 equals to R2 L2 by A2 E2. So this will be the second equation. Okay, so you can understand that compatibility equation in different cases can be different. अलग अलग केस में अलग अलग हो सकता है. और यहाँ एक चीज ध्यान देने की है, that without this statement you cannot write this compatibility equation. This statement is very important. Okay, find the rigid beam, for rigid beam to be horizontal, rigid beam को horizontal रखना है, that is the constraint. उसी से हमको ये equation मिले. Okay, so compatibility equation will be based on how the deformation is constraint. Deformation constraint कैसे हो रहा है, right? Yes, very good Aditya, very good Ajoy. Yes, so beta, now a third case can also be there. एक third case भी बनता है. अब ये third case कैसा होता है, इसको बहुत ध्यान से देखना, इसको बहुत ध्यान से देखना. This is very important. These questions have been in exam 2 times. This type of question, इस टाइप का क्वेश्चन जो है एग्जाम में 2 बार आ चुका है. ओके, तो ये मेरे भाई इंपॉर्टेंट है. लेट्स से आई एम अप्लाइंग अ फोर्स P. द डिस्टेंस फ्रॉम दिस हिंज, लेट्स से दिस हिंज इज O, तो ये L है, ये A है, ये B है. Okay, this is bar number 1, this is bar number 2. Okay, now in this question I want to find the force in 1 and 2. Okay, तो अब इस केस में if I write the equation of equilibrium, क्या मिलेगा मुझे? This will be the free body diagram. ठीक है, फ्री बॉडी डायग्राम कुछ ऐसा बनेगा. R1, R2, दिस इज P, और यहां हिंज पे भी देयर विल बी अ रिएक्शन, लेट्स से R. नाउ डू आई वांट दिस R? नाउ आई डोंट वांट दिस R. I want R1 and R2. So what I do? I take moment at point O. तो मैं O पे मोमेंट ले लूंगा, तो मुझे मिलेगा R1 इंटू A प्लस R2 इंटू B इक्वल्स टू P इंटू L. ओके, ऐसी कुछ इक्वेशन मिल जाएगी. दिस इज वन इक्वेशन. नाउ आई वांट अनदर इक्वेशन. तो दूसरी इक्वेशन मिलेगी कहां से? कंपैटिबिलिटी से. अब कंपैटिबिलिटी इक्वेशन क्या होगी, दैट यू नीड टू अंडरस्टैंड. तो कंपैटिबिलिटी इक्वेशन विल बी समथिंग लाइक दिस. इनिशियली इट इज लाइक दिस, है ना. इनिशियली ये बार कुछ ऐसा है, बट फाइनली इट विल बिकम समथिंग लाइक दिस. फाइनली जब ये डिफॉर्म होगा तो ये कुछ ऐसा बनेगा. ओके, this will be the deformation of 2, this will be the deformation of 1, this will be delta L2, this will be delta L1. okay, और बेटा ये क्या है A, ये क्या है B. तो what is compatibility equation here? यहां compatibility equation क्या बनती है? Here compatibility equation will become this: delta L1 by A equals to delta L2 by B. This will be your compatibility equation in the second case, ये वाले केस में. okay, तो बेटा there are different types of problems, statically indeterminate problems, and in every case you get a different compatibility equation, so you need to know different cases so that you can solve them. ठीक है, आपको अलग अलग केसेस में अलग अलग तरीके से कंपैटिबिलिटी इक्वेशन बनानी रहती है. यस आदित्य, यस अजय, वेरी गुड वेरी गुड वेरी गुड महिमा. सो बेटा यू कैन अंडरस्टैंड हाउ डिफरेंट केसेस ऑफ स्टैटिकली इंडिटरमिनेट बार्स आर सॉल्व्ड. ओके, अलग अलग केस में क्या क्या कंपैटिबिलिटी इक्वेशन हमको बनानी है. ओके, सो यू अंडरस्टैंड दैट. नाउ थर्मल स्ट्रेस प्रॉब्लम. व्हाट इज थर्मल स्ट्रेस प्रॉब्लम? लेट्स अंडरस्टैंड दैट. सो लेट्स से वी हैव अ बार ऑफ लेंथ L, width W and height H, and we are increasing the temperature by delta T degree centigrade. So if you increase the temperature, the length will increase, the width will increase, and the height will increase by this much. Delta L equals to L alpha delta T. Delta W, delta H can also be written like that. And in this equation, what is alpha? Alpha is coefficient of linear expansion or thermal expansion. Its unit is per degree centigrade. Alpha of steel is 10 to the power minus 1, 12 into 10 to the power minus 6 per degree centigrade. Okay, so its value depends upon material. अलग अलग मटेरियल के लिए there are different values of alpha. okay, now beta in this equation you will notice that the change in length, width, height are due to temperature, so we call them delta L thermal. हम इनको क्या बोलते हैं? del L thermal, del W thermal, del H thermal. Why? Because they are due to change in temperature. Force की वजह से if there is change in length, then I will call it del L mechanical. और अगर टेम्परेचर से आ रहा है देन आई विल कॉल इट del L थर्मल. ओके, अब यहां पे द बॉडी इज फ्री, एंड इफ द बॉडी इज फ्री देयर इज नो स्ट्रेस. अगर फ्री है बॉडी कोई स्ट्रेस नहीं रहेगा. ये चीज आपको याद रखनी है. इफ द बॉडी इज फ्री in all directions, there is no load, hence sigma in every direction will be 0, but there will be strain. यहां पे सिग्मा जो है तीनों डायरेक्शन में 0 रहेगा. ठीक है, सिग्मा तीनों डायरेक्शन में 0 रहेगा. सिग्मा x, सिग्मा y, सिग्मा z all will be 0, but there will be epsilon x, epsilon y and epsilon z. और उनकी वैल्यू क्या होगी बेटा? डेल्टा L by L will be epsilon x. What will it be? Alpha delta t. Delta W by W will be epsilon z, alpha delta w. Delta H by H will be epsilon y, alpha delta t. तो बेटा हर डायरेक्शन में स्ट्रेन आएगा अल्फा डेल्टा टी. तो स्ट्रेस विल बी 0 बट स्ट्रेन विल नॉट बी 0. ओके, सो डू यू अंडरस्टैंड दिस? ये चीज आपको समझ में आ रहा है? if it is free in all direction, if it is free in all direction. But if there are constrained, let's say there is a bar which is constrained in x, free in y and z, but constrained in x. So in this case, if I increase the temperature, अगर मैंने temperature increase किया, then what is going to happen? If I draw the free body diagram, then I will get this. अगर मैंने free body diagram draw किया तो मुझे कुछ ऐसा डायग्राम देखने को मिलेगा. There will be a force in x direction, stress in x direction, and what will be the value of this? Sigma x will be equals to E alpha delta t. Now you will notice there will be no sigma y, no sigma z. There will be only sigma x because it is free in y and z. So y or z में no stress. There will be only stress in x direction. Okay. So this will be the formula. If it is constrained in two direction, अगर ये दो direction में constrained हुआ, then I will get stress in two directions. Okay. Again I am assuming that temperature is increased. अभी भी मैं क्या मान रहा हूं? Delta T is increase. So I will get one stress in x, I will get one stress in y, and guess what? Stress in x and y directions will be equal, and their value will be, now you have to remember this, E alpha delta T upon 1 minus 2 nu, where nu is what? Poisson's ratio. Poisson's ratio. तो मेरे भाई ये फॉर्मूला कब लगेगा? When it will be constrained in two directions, sigma x as well as sigma y. ठीक है, sigma x and sigma y. ठीक है, x और y दोनों डायरेक्शन में constraint है. Okay. Now if it is fixed in all direction and temperature is increased, then you will get stress in all three direction. तब आपको तीनों ही डायरेक्शन में स्ट्रेस मिलेगा क्योंकि ये तीनों डायरेक्शन में फिक्स है. अब मैं तीनों डायरेक्शन में फिक्स दिखा नहीं सकता, तो आई एम नॉट ड्राइंग द फर्स्ट डायग्राम, आई एम ड्राइंग द सेकंड डायग्राम डायरेक्टली. अब इस केस में सिग्मा एक्स वाई जेड ऑल विल बी इक्वल, तीनों इक्वल होंगे, एंड देयर वैल्यू विल बी ई अल्फा डेल्टा टी अपॉन 1 माइनस 2 न्यू. E alpha delta t upon 1 minus 2 nu. ठीक है. So if it is fixed in all three direction, if it is fixed in all three direction, then we will get this sigma x equals to sigma y equals to sigma z E alpha delta t upon 1 minus 2 nu. Okay. So beta, you need to remember these three equations. Sorry, so sorry. This will be 1 minus nu. So sorry, so sorry. I'm really sorry. I'm really sorry. This will be 1 minus nu and this will be 1 minus 2 nu. Okay. So fixed in one direction E alpha delta t, fixed in two direction E alpha delta t upon 1 minus nu, fixed in three direction E alpha delta t upon 1 minus 2 nu. These equations you need to remember. But beta, it is not necessary that you will get only these types of problems. Okay. There is single bar of constant area here. यहाँ पे एक सिंगल बार है constant area का, जो एक डायरेक्शन में फिक्स है, दो डायरेक्शन में फिक्स है, तीन डायरेक्शन में फिक्स है. बट बेटा, देयर कैन बी डिफरेंट टाइप्स ऑफ प्रॉब्लम्स. सो इन डिफरेंट प्रॉब्लम्स what will be the approach. So let's say we have a problem like this. Okay, मान लो ऐसा प्रॉब्लम है and we are increasing the temperature by delta T. What is the problem? The bar is fixed in one direction at one end, but at the other end there is some gap. यहां पे एक छोटा सा गैप है डेल्टा का. अब इस केस में क्या होगा बेटा? इन दिस केस stress will not be developed until the change in length due to temperature is greater than delta. Okay, so understand, ये चीज यहां पे बहुत जरूरी है. Stress will be developed only if del L thermal will be greater than delta. Okay, even if it is less than delta or even if it is equal to delta, stress will not be developed. Stress develop होने के लिए del L thermal जो है delta से ज्यादा होना चाहिए, then only this support will apply a compressive force, otherwise it will not apply compressive force. अब इस केस में how you will find that compressive force? Let's say this is applying compressive force like this. ठीक है, मान लो ये ऐसा compressive force लगा रहा है P, तो मुझे ये P निकालना है. Okay, I want this P. So for calculating P, I will have compatibility equation. तो compatibility equation क्या बनेगी मेरे भाई यहाँ पे? What compatibility equation I will get? Understand. Delta L total will be equals to delta. Total change in length कितना हो सकता है? How much total change in length you can get? Equal to this gap only. Now del L total will be due to temperature as well as due to force. There are both. So I write it del L thermal plus del L mechanical. Right? अब del L thermal क्या होगा? L alpha delta T, and it will be positive. Del L mechanical will be negative because the force is compressive. Minus PL by AE equal to delta. Now in this equation you will notice that there will be only one unknown, P. Length, alpha, area, Young's modulus, delta T, this delta, everything will be given. There will be only one unknown, P. So you will get the value of P. Simple. Once you get P, you can divide it by area and you will get stress. Yes? Yes? Yes, Pranav, whatever I have discussed in deflection of beams, it is enough for civil students also. Okay. In fact, the entire strength of material I have taught, that is also very useful for civil students. Civil students can also refer this. ठीक है, civil students भी ये refer कर सकते हैं. Yes, Vivek, I have corrected my mistake. Thank you so much, beta, for pointing it out. Thank you so much, guys, for all the lovely support you are giving me. Thank you so much for all the love and support. Keep showering your love like this. Keep hitting the likes and keep sharing. Thank you so much. Thank you so much. So, beta, this is one case where you can't apply the direct formula. ये formula यहाँ नहीं चलेगा, यहाँ पे चलेगा compatibility equation. ठीक है. Next, compatibility equation for tapered bar. अब tapered bar है, दोनों end पे fix है. Delta T से temperature बढ़ा रहे हैं. From here I am getting one force. From here I am getting one force, equal and opposite force, unknown. So how you will calculate this force? Again, compatibility equation. This time delta L total 0. But you can't use the formula sigma equals to E alpha del T. Why? Because in that case the bar was prismatic. This is a tapered bar. तो यहाँ direct formula नहीं लगा सकते. तो del L thermal प्लस del L मैकेनिकल. अब del L थर्मल क्या लिखेंगे मेरे भाई? del L thermal will always be L alpha delta T. Why? Because del L thermal doesn't depend upon area. So even if the area is constant or tapered, doesn't matter. del L thermal का formula क्या? L alpha delta T. Thank you so much, Ashish. Thank you so much, guys. Yes. 250 plus likes. Thank you so much. Thank you so much. तो मेरे भाई del L thermal जो है, it doesn't depend upon area. उसके फॉर्मूले में एरिया है ही नहीं. L alpha delta T. So बेटा, even if it is a tapered bar, is my formula of del L thermal going to change? No. So this will be L alpha delta T. Same formula, but del L mechanical formula will change. Why? Tapered bar. And in case of tapered bar, del L mechanical will be what? First of all, it will be negative, compressive, because we are increasing the temperature. If we are decreasing the temperature, then this will be negative. अगर हम decrease करेंगे तो ये negative हो जाएगा और ये positive हो जाएगा. ठीक है? तो बेटा, del L mechanical will be क्या? PL upon, let's say it is circular tapered bar. मान लेते हैं circular tapered bar है, तो ये हो जाएगा PL upon pi by 4 D1 D2 into E. रेक्टेंगुलर टेपर्ड बार में PL अपॉन b2 minus b1 by natural log of b2 by b1 t into e. So whatever it is, you know the formula. So beta just put that formula. Now again in this equation they will give you all the values, only p will be unknown, so you will get the value of p. Yes, very good, very good, very good. So everyone is able to connect all this ना, ये सबको दिमाग में छप रहा है ना कि ये ऐसे करना है, ये ऐसे करना है. We have solved numericals based on this. So many numericals we have solved, है ना. तो बेटा ये सारी यादाश्त आपकी ताजा हो रही होगी. Okay, we are just following what type of questions we get. आपको बस ये देखते जाना है. अभी रिवीजन चल रहा है तो मेरे भाई हर रिवीजन के केस में न्यूमेरिकल हाउ मेनी न्यूमेरिकल यू विल प्रैक्टिस. Yesterday only, day before yesterday only, we completed 150 plus questions of SOM, right? So if you want to practice numericals, you are welcome in my special class. We are solving so many numericals, है ना. तो मेरे भाई न्यूमेरिकल सॉल्व करने के लिए ये पता तो हो. तो मेरे भाई दिस इज द फर्स्ट केस, दिस इज द सेकेंड केस. और क्या केस हो सकता है? वी कैन हैव दिस केस. लेट्स से वी हैव टू बार्स, बार नंबर 1, बार नंबर 2. अगेन टेम्परेचर इंक्रीजिंग. So beta there will be one force from here, one force from here. अब बेटा यहाँ पे this force and this force will be equal. So both these bars will be subjected to same force. Same force है. It's not recorded beta. This is live. Just 2.0. This is live. Either this is live or I have come from future where I have read your comments beforehand. मैंने आपके पहले ही कमेंट्स पढ़ लिए हैं और उसके बाद मैं यहाँ पे क्लास में आके रिकॉर्ड भी कर लिया हूँ और उसके बाद ये रिकॉर्डेड लेक्चर चल रहा है. तो मेरे भाई अगर आपको ऐसा लग रहा है तब और भी अच्छी बात है. इफ आई एम फ्रॉम फ्यूचर देन तो यू मस्ट वॉच दिस, राइट. यस प्रणव, फुल कॉन्सेप्ट रिवीजन होगा मेरे भाई, फुल कॉन्सेप्ट रिवीजन होगा. यस, न्यूमेरिकल के लिए भी एक सीरीज चल रही है राहुल, दैट इज इन स्पेशल क्लास. जस्ट फॉलो दिस लिंक. You will find an Excel sheet, most expected question series की एक लिंक मिल जाएगी. Okay. Now बेटा how to find P here? Again compatibility. Del L total will be 0, which will be del L thermal plus del L mechanical. तो del L thermal क्या हो जाएगा? Del L thermal total will be L alpha delta T of 1 प्लस L अल्फा डेल्टा T ऑफ 2. तो मेरे भाई बस ऐसा लिख देना है, ठीक है. तो दो अलग अलग बार हैं तो डेल एल थर्मल ये हो जाएगा. नाउ डेल एल मैकेनिकल दोनों के लिए कंप्रेसिव होगा, फॉर बोथ इट विल बी कंप्रेसिव. तो मैं नेगेटिव साइन बाहर ले लेता हूं. तो पी एल बाय ए ई ऑफ 1 प्लस पी एल बाय ए ई ऑफ 2 और दोनों का P will remain same. तो बेटा again you have single equation in which there is only one unknown. What is that unknown? P. तो मेरे भाई अगर यहाँ एक तीसरा बार भी लगा देंगे then no issue. You will have to put L alpha delta T of 3, PL by AE of 3, L alpha delta T of 4, PL by AE of 4. तो infinite लगा दो, doesn't matter. There will be one force here, one force here. Only one single force will be unknown, है ना. तो बेटा it doesn't matter. और ऐसा क्वेश्चन आज तक आया नहीं है. Okay, till now there has never been a question like this in GATE because it will become lengthy to solve. But you might get. ठीक है, आप आ सकता है, ऐसा नहीं है कि आया नहीं है तो आएगा नहीं. It's okay बेटा, it's okay. There will be people like this in your life. ठीक है. It's okay. People like this will be in your life who will always distract you, who will always try to distract you from your goal, but you should not be distracted. Okay, you should focus on your goal. आपने घोड़े को देखा होगा, रेस के घोड़े को, when they train the racing horses, they put mask on the face of horse so that they cannot see here, they cannot see here. All they can see is the road straight ahead, है ना. उनको सिर्फ सामने का रोड दिखता है, उनको सिर्फ सामने का लक्ष्य दिखता है. दे ओनली सी देयर फाइनल टारगेट, सो दे जस्ट कीप ऑन गोइंग, सो दे आर नॉट डिस्ट्रैक्टेड. सो यू ऑल्सो हैव टू पुट दोज ब्लाइंडर्स हियर एंड you also need to focus on your goal. Okay, so when you need to do something, focus on that thing, put all your efforts, put all your energy into that thing, and don't get distracted. बाय एक्सटर्नल एलिमेंट्स, ठीक है, अदर एलिमेंट्स से आपको डिस्ट्रैक्ट नहीं होना है, ओके। तो आप इतना ज्यादा डिस्ट्रैक्ट अगर होंगे तो कैसे चलेगा, ओके। आई विल गिव यू अ वेरी 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 इंपॉर्टेंट सजेशन, व्हेनेवर यू आर स्टडीइंग और व्हेनेवर यू आर सॉल्विंग एनी टेस्ट सीरीज, डोंट सिट डाउन इन अ वेरी क्वाइट प्लेस, ओके। बहुत शांत जगह पे और एकदम अनडिस्ट्रैक्टेड जगह पे बैठ के कभी प्रैक्टिस नहीं करनी चाहिए। व्हाई? लेट मी टेल यू, व्हेन यू विल बी राइटिंग द फाइनल गेट एग्जाम, then you will not get that environment, right? When you will be writing gate exam na, what will happen, let me tell you, when you will be writing gate exam, then you will hear every sound coming from outside, okay? There will be some construction work going on, invigilators will be talking to each other, so beta there will be so much noise, there will be so much distraction, and if you are not used to it, then you will get distracted, then you will not be able to concentrate. So in order to get used to it, अगर आपको आदत डालनी है तो हल्ले गुल्ले में बैठ के टेस्ट सीरीज दो। When you are writing the test series ना, you sit down in an environment which will be similar to what you are going to get in gate, okay? बाहर से आवाज आनी चाहिए, खिड़की विड़की खोल दो, ओके? एकदम एसी चला के कमरे वमरे बंद करके नहीं बैठो, खिड़की विड़की खोल दो, मम्मी पापा की बातें सुनो, गाना वाना चालू कर दो, and then you write your exam. You train your mind to concentrate on your gate exam आफ्टर हियरिंग ऑल दिस। ये सब सुनने के बाद भी आप अपने दिमाग को ट्रेन करो कि वो फोकस करना सीखे, ओके? देन you will be able to write your gate exam without any distraction, okay? So this is just a small suggestion for you, ठीक है? चलो मेरे भाई, okay? So this is another case, okay? Now this is another case where we have a bar which is connected to a spring, and now I am increasing the temperature. So beta again I will have a force from here, I will have a force from here, okay? Again this force P is unknown. So what will be our compatibility equation? Same, del L total 0 means del L thermal plus del L mechanical. बस यहां एक चीज का ध्यान देना है, del L thermal when I will be writing, ignore this spring. So del L thermal will be L alpha delta T of this bar, okay? Del L mechanical will be minus, for this bar it will be PL by AE, and for the spring it will be P by K. Stiffness of the spring will be given, spring की stiffness given रहेगी. So you'll get this equation. Now in this equation again there is only one unknown, which is what? P. So by solving this you are going to get the value of P, then calculate the stress. So this is how you are going to find the value of P in this case. So I have shown you different cases of thermal stress, ठीक है? अलग अलग cases, direct formula and then different cases, okay? तो इतना ध्यान में रखो. Now thermal stress in composite bar. अब composite bar क्या होता है, ये किस चिड़िया का नाम है? So let's say we have a bar which is made of two different material, steel and aluminum, okay? And we are increasing the temperature delta T से. Now alpha of aluminum is greater than alpha of steel. Aluminum का alpha steel से ज्यादा है, तो क्या होता है initially what happens? Initially it will elongate, okay? Initially ये elongate होता है कुछ इस तरीके से, तो एल्यूमिनियम थोड़ा ज्यादा elongate हो जाता है और स्टील जो है थोड़ा कम elongate होता है. But final change in length should be same ना, because this is a composite, we have connected them, तो final change in length तो same होना चाहिए. अब फाइनल चेंज इन लेंथ को सेम करने के लिए एक फोर्स आता है स्टील में जो इसको इधर धकेलता है, और एक फोर्स आता है एल्यूमिनियम में जो इसको इधर धकेलता है. तो फाइनली द स्टील will come to this, aluminum will come to this, so this will be your final change in length, ठीक है? ये क्या होगा मेरे भाई? This will be the final change in length. I will call it delta L total. तो मेरे भाई स्टील और एल्यूमिनियम के लिए, दोनों के लिए डेल्टा L total क्या होना चाहिए? सेम होना चाहिए, फाइनली यहां आके रुक जाएंगे। ओके, तो बेटा what will be the compatibility equation here in this case? In this case the compatibility equation is this: delta L total for steel should be equal to delta L total for aluminum. स्टील और एल्यूमिनियम के लिए चेंज इन लेंथ क्या होनी चाहिए मेरे भाई? स्टील एंड एल्यूमिनियम के लिए चेंज इन लेंथ शुड बी इक्वल। वेलकम एवरीवन, वेलकम मोहित, वेलकम वेलकम नीलाक्षी, वेलकम वेलकम वेलकम। क्या है यार ये, व्हाट टाइप ऑफ लैंग्वेज यू गाइज आर यूजिंग? लेट मी जस्ट गेट दिस बडी ब्लॉग्ड। मतलब आप लोग अपने घर में जिस टाइप की लैंग्वेज यूज करते हो वैसी लैंग्वेज आप यूज कर रहे हो यहाँ पे। मोहित, डू यू कॉल दिस, डू यू कॉल योर फादर एंड मदर दिस? डू यू यूज दिस सेम वर्ड्स टू कॉल योर फादर एंड मदर? वेरी गुड बेटा, वेरी गुड। आप अपने घर पे भी ये लफ्ज यूज करते हो, अपने घर पे भी ऐसी बातें करते हो, तो बहुत बढ़िया बात है। नहीं नहीं, कोई दिक्कत नहीं है, कोई दिक्कत नहीं है बेटा। बाकी लोग कुछ रिस्पॉन्ड मत करो, डोंट रिस्पॉन्ड, आई विल गेट दीज पीपल ब्लॉक्ड। ओके, दीज आर द पीपल who use this same kind of word at their home also. Okay, so whatever language you are using here, whatever words you are using here, let me tell you, I will assume that you call your mother and father this. ठीक है, आप अपनी मम्मी पापा को, अपने भाई बहनों को ऐसी ही भाषा यूज करके बुलाते हो, बात करते हो, मैं यही अज्यूम करूंगा। सो बेटा लेट्स इग्नोर देम। सो डेल्टा एल ऑफ स्टील एंड एल्यूमिनियम फाइनली शुड बी इक्वल। अब डेल्टा एल टोटल विल बी व्हाट? डेल एल थर्मल एंड डेल एल मैकेनिकल, है ना? यहां पे भी आपको टेम्परेचर भी मिल रहा है, फोर्स भी मिल रहा है। बट बेटा एक चीज ध्यान दो, व्हेन आई विल इंक्रीज द टेम्परेचर, डेल एल थर्मल फॉर बोथ विल बी पॉजिटिव, but del L mechanical for steel will be positive and for aluminum it will be negative because steel is expanding, aluminum is contracting due to force. तो यहां पे del L thermal जब आप लिखोगे तो ये तो दोनों के लिए पॉजिटिव रहेगा, दिस विल बी पॉजिटिव फॉर बोथ, ओके, फॉर स्टील एज वेल एज एल्यूमिनियम। बट फोर्स की वजह से जो आएगा del L mechanical, that will be positive for steel and negative for aluminum. Now in this equation again there is only one unknown and that will be P. All the other values will be given. So by solving this again you get P and then you calculate the stress. ठीक है, एक बार आपको P मिल गया उसके बाद यही stress निकाल लेना है। Okay, so in all these cases you will see that you can apply compatibility equation and you can find P. Yes, yes, yes. Very good guys, very good. Thank you so much for love and support. Keep showing your love like this. Okay, so this is thermal stress in composite bar. तो मेरे भाई thermal stress पूरा रिवाइज हो गया। अब आते हैं next topic, strain energy due to axial load. So बेटा let's say we have a bar which is subjected to axial load and that axial load is P. Okay, now we need to find the strain energy stored in the bar. So strain energy due to axial load P is given by this equation, U equals to P square L by 2AE, and the strain energy unit is what? इसकी यूनिट क्या होती है बेटा? It is either in न्यूटन मीटर और जूल्स, या तो न्यूटन मीटर यू बोलते हैं या तो जूल्स बोलते हैं, बोथ आर द यूनिट ऑफ एनर्जी ओनली। जूल्स इज न्यूटन मीटर, ठीक है, जूल्स इज न्यूटन मीटर। बेटा इफ यू हैव ऑलरेडी लाइक्ड इट देन इट विल नॉट वर्क, ओके, अगर आप पहले से ही लाइक कर चुके हो तब ये काम नहीं करेगा, ओके। So beta this is the strain energy due to axial load and don't worry, you will get very simple formula based questions from strain energy, P square L by 2A. Okay, now axial impact load. Axial impact load के case में what is the equation? So let's say we have a load W which is dropped from some height h, ठीक है, on a bar of length L, area A, Young's modulus E, ठीक है. इस केस में we need to find the change in length and the stress. Okay, so let's say that if W is gradually applied, अगर W को हम gradually apply करते, if W is gradually applied, then sigma static, I will call it sigma static, will be equal to what? W by A. Applied, gradually applied मतलब कि at every point the body is in equilibrium, will drop the weight, it will suddenly strike it, ठीक है. तो लोड ट्रांसफर विल नॉट बी ग्रेजुअल, दिस विल बी एन इंपैक्ट, ये एक इंपैक्ट होगा. सो इन दिस केस व्हाट विल बी सिग्मा? सिग्मा विल बी इक्वल टू सिग्मा स्टैटिक इनटू इंपैक्ट फैक्टर एंड डेल्टा एल विल बी इक्वल्स टू डेल्टा एल स्टैटिक इनटू इंपैक्ट फैक्टर, ठीक है. अब इंपैक्ट फैक्टर क्या है? Impact factor is a factor by which the stress and change in length increase. Impact factor वो फैक्टर है जिससे आपका सिग्मा और डेल एल बढ़ गया है, 10 गुना हो गया, 20 गुना हो गया, 50 गुना हो गया, 100 गुना हो गया, it became 100 times, 50 times, 10 times. So that 10 times, 50 times, that is impact factor, and its equation is given by this 1 plus root over 1 plus 2h upon del L static. So whenever you have a question from impact load, what you need to do is you first calculate del L static from here, WL by AE. Then you put it here and you find impact factor, and then you multiply impact factor in sigma static, you get sigma, multiply impact factor in del L static, you get del L. Okay. Now for suddenly applied load, अगर लोड सडनली अप्लाइड है, देन इंपैक्ट फैक्टर की वैल्यू होती है 2. तो सिग्मा इक्वल्स टू 2 टाइम्स ऑफ सिग्मा स्टैटिक एंड डेल एल इज इक्वल्स टू 2 टाइम्स ऑफ डेल एल स्टैटिक, ठीक है. तो दिस इज फॉर सडनली अप्लाइड लोड. सो देयर आर 3 टाइप्स ऑफ लोड, ग्रेजुअली अप्लाइड, सडनली अप्लाइड एंड इंपैक्ट. ओके, तो ग्रेजुअली अप्लाइड लोड के लिए W by 8, WL by 2AE. सडनली अप्लाइड लोड के लिए जस्ट मल्टीप्लाई 2, एंड इंपैक्ट लोड के लिए कैलकुलेट द इंपैक्ट फैक्टर एंड देन मल्टीप्लाई इंपैक्ट फैक्टर. ओके, सो दिस इज द इंपैक्ट लोडिंग. ओके, विद दिस वी कंक्लूड चैप्टर नंबर 2. तो बेटा, इफ वी गो थ्रू द सिलेबस, अगर सिलेबस देखें तो हमने क्या क्या कंप्लीट कर लिया है? वी हैव कंप्लीटेड चैप्टर नंबर 1 एंड चैप्टर नंबर 2, और बहुत ही खूबसूरत नोट्स बन रहे हैं आपके. इफ यू नोटिस, दिस नोट्स आर सो ब्यूटीफुल. आई एम नॉट प्रेजिंग माई सेल्फ, अपने मुंह मियां मिट्टू होने वाली बात हो गई. सो चैप्टर 1 इज डन, चैप्टर 2 इज डन, एंड यू विल नोटिस दैट you are getting such beautiful notes, right? Short notes, such beautiful short notes. You can just download them. I will give you this PDF, everyone. I will give you this PDF. I will give the link in the comment itself. मैं इसके comment में link डलवा दूंगा. I will give the link in the comment and I will also upload it in Telegram channel. मैं Telegram channel पे भी upload करवा दूंगा. I will upload it in the Telegram channel also. So बेटा, you will get it, don't worry. आपको ये मिल जाएगा बड़े आराम से. So you can download it and you will see that everything is discussed here. Okay, हर चीज हम लोग डिस्कस कर रहे हैं. Everything is discussed here. Okay, चलो, let's take a break. Okay, on popular demand, let's take a break. Okay, so thank you so much, Grubler, Dhananjay, Aditya, Abu, Prem, thank you so much, Mr. Nadi, thank you so much, थैंक यू सो मच अजय, थैंक यू सो मच चंचल, थैंक यू सो मच प्रभाकर, महिमा, करण, थैंक यू सो मच, थैंक यू सो मच बेटा. So I will be back in let's say 20 minutes. Shall we take a break for 20 minutes? 20 minutes break ले. 15 minutes. Let's take a break for 15 minutes. ठीक है, एक 15 मिनट का ब्रेक लेते हैं so that we can have breakfast. A lot of people haven't had breakfast. ठीक है, 15 minutes break. 15 minutes break and I will be back. 15 मिनट का ब्रेक लेते हैं और उसके बाद I will be back. Okay, I will be back within 15 minutes. What say? 15 मिनट का ब्रेक लेते हैं तो we will start. Right now it is 11:36. So within 15 minutes we will be back. Okay, अभी 11:36 हो रहा है. 15 मिनट में हम लोग वापस आएंगे. 15 मिनट का एक ब्रेक ले लेते हैं and you guys have your breakfast. ठीक है, you guys have your breakfast. Let's take a 15 minutes break. Okay, let's take a 15 minutes break. And I'm back. I'm back. Let me just set up the mic. Okay. So I hope all of you had the breakfast and I hope all of you are ready for continuing this class. Yes. Yes, Ankur. Yes, Prem. Yes, Harshit. Yes, Vinay. Yes. Yes, we are back. Yes. I hope सबने breakfast कर लिया होगा. All of you are ready. All of you are filled with the energy. Start करें. Yes, Vivek. Yes, Ajoy. Everyone is back. Please keep hitting the like button and please keep sharing. ठीक है, शेयर करना मत भूलना मेरे भाई. आपका एक शेयर जो है कहीं किसी जरूरतमंद इंसान तक ये लेक्चर पहुंचा देगा. ओके, योर वन शेयर might help someone in need of this lecture. Okay, so right now it's a very crucial time. A lot of people are searching for these types of revision sessions, practice sessions, so we need to reach to them because this is a free content beta and everyone has the right for free quality education. हमारे देश में क्वालिटी एजुकेशन और वो भी फ्री में बहुत मुश्किल से मिलता है. तो मेरे भाई हर एक स्टूडेंट को हक होना चाहिए ताकि उसके पास फ्री में क्वालिटी एजुकेशन जाए. सो इफ यू फाइंड दिस वीडियो of a good quality, if you find this class to be of proper quality, adequate quality, then don't forget to share this in all your groups, telegram groups, whatsapp groups, जहां जहां पे भी शेयर कर सकते हो. if you bring this, if you take this to at least one student in need, that will be a great help, that will be a great deal. ठीक है, अगर आपकी वजह से किसी एक जरूरतमंद स्टूडेंट तक भी पहुंच गया ना तो बहुत बड़ी बात होगी. सो थैंक यू सो मच, कीप शेयरिंग, कीप लाइकिंग. थैंक यू सो मच, थैंक यू सो मच. मेरे भाई एमपी में ठंड उतनी नहीं है और अगर है भी तो इस रूम में उतनी नहीं है बिकॉज देयर इज सो मच हीट ड्यू टू दिस स्मार्ट बोर्ड, so much heat due to these computers, these laptops, that I am not feeling any cold. Okay, so let's start chapter number 3, torsion in circular shaft. Now although it's an important chapter, but beta if conceptual point of view से देखा जाए then it's a very small chapter. Okay, you will not get too many equations, you will not get too many different varieties of questions. It's a very simple and very small, एकदम छोटा नन्ना मुन्ना सा chapter है. So we'll quickly complete it. Okay, so let's start. उत्तराखंड में भी आ चुका हूं दोस्त मैं. इनफैक्ट लास्ट मंथ, नॉट लास्ट मंथ, दिस मंथ फर्स्ट वीक आई वाज इन हिमाचल, मनाली, and it was like 0 degree centigrade there. So beta, I love cold weather, I love winter. Yes, बहुत ज्यादा हीट ट्रांसफर हो रहा है. ओके, तो चलो मेरे भाई टॉर्शन इन सर्कुलर शाफ्ट स्टार्ट करते हैं. लेट्स स्टार्ट. भगवान का नाम लेके, एक लाइक बटन दबा के, एक शेयर मार के, लेट्स बिगिन. ओके, so what is torsion? Torsion is nothing but twisting moment. So let's say if this is my shaft, then beta twisting moment is this moment, right? Moment acting about the normal axis of the cross section. Cross section के normal axis के about moment is the twisting moment. Now in case of torsion we only consider circular shafts because in non-circular shafts the equations are very different and that is not in our syllabus. So in our syllabus we only have circular shafts and that too we derive the equation based on some assumptions. What are those assumptions? The assumptions are material of the shaft is homogeneous and isotropic. Then stresses are within proportional limit, and the biggest assumption, the most important assumption is all the transverse sections remain plane and undistorted after twisting. Means when I will be twisting this, then this cross section will not distort, it will remain plane like this. Okay, and in other words you can say that if we have a circular section like this, अगर ये मेरा circular section है and if I have this one diameter, let's say this is one diameter of this circular section, then after twisting it will remain straight. ट्विस्टिंग के बाद ये स्ट्रेट ही रहेगा, ये डिस्टॉर्ट नहीं होगा. इफ इट गेट्स डिस्टॉर्टेड देन इट विल नॉट रिमेन स्ट्रेट, राइट? बट अकॉर्डिंग टू आवर अजम्पशन इट शुड रिमेन स्ट्रेट. अब ये स्ट्रेट कब रहेगा? ये स्ट्रेट कब? थैंक यू सो मच मैकेनिकल निप, थैंक यू सो मच बेटा, थैंक यू सो मच फॉर सच अप्रिसिएशन. I love this when you are writing these things, these words of appreciation means a lot to me. Okay, तो अब मेरे भाई यहाँ पे ध्यान से देखो. Okay, if you assume that the diameter after twisting will remain straight, what are you assuming? You are assuming that from here to here the strain is linear and the stress is linear. Okay, so due to this assumption we get the shear stress and shear strain due to torsion linear. टॉप से बॉटम तक shear stress और strain कैसे वैरी करता है मेरे भाई? लीनियरली वैरी करता है. Why? Because of this assumption. इस assumption की वजह से we get the linear stress and strain distribution. Yes, welcome back Rahul, welcome back. So beta, these are the assumptions that we make in torsional, finding the torsional equation. Now what is the torsional equation? The torsion equation is given by T by J equals to tau by R equals to G theta by L. So this is the torsional equation where T is what? T is the torque. J is what? J is polar moment of inertia. J क्या होता है मेरे भाई? Polar moment of inertia होता है. Tau is the shear stress at radial distance r. Theta is what? Theta is angle of twist. What do we mean by angle of twist? जैसे ये है तो ये कितने एंगल से ट्विस्ट हुआ? दिस इज द एंगल ऑफ ट्विस्ट. ठीक है, दिस इज द एंगल ऑफ ट्विस्ट थीटा. तो T by J इक्वल्स टू टाउ बाय R इक्वल्स टू G थीटा बाय L. ओके, अब इस इक्वेशन में वी हैव टू कैलकुलेट टू थिंग्स. बेसिकली we calculate the stress tau and we calculate the angle of twist theta. क्या हो गया मेरे भाई? क्या हो गया मेरे भाई? सारे बच्चे वापस क्यों नहीं आए हैं? Call everyone, call everyone. Why I have less attendance now? Initially when we started there were at least 100 people. Now why there are 70 people? You need to share, you need to share, you need to call everyone. सबको बुलाओ, वापस से इसको ट्रिपल डिजिट में लेके जाओ, सबको बुलाओ वापस. ओके, so beta, usually we calculate two things. We calculate tau, we calculate theta. Okay, so in order to calculate tau we use this equation T by J equals to tau by R. In order to calculate theta we use this equation T by J equals to G theta by L. Okay, अब अगर मैं maximum shear stress निकालूं, if I calculate maximum shear stress in circular shaft, this is the circular shaft. Okay, अब मेरे भाई शाफ्ट जो है वो सॉलिड सर्कुलर भी हो सकती है, हॉलो सर्कुलर भी हो सकती है. ओके, सो बेटा यू विल नोटिस दैट द shear stress will vary linearly. shear stress कैसे वैरी करेगा? shear stress will vary linearly like this. Okay, and where will you get tau maximum? You will get tau maximum at the surface. ठीक है, tau maximum कहां मिलेगा आपको? tau maximum आपको मिलेगा सरफेस पे. ठीक है, अब यहां टाउ मैक्स की इक्वेशन क्या होगी? टाउ मैक्स विल बी इक्वल्स टू 16t बाय पाई डी क्यूब. और यहां टाउ मैक्स की इक्वेशन क्या होगी? टाउ मैक्स विल बी इक्वल्स टू 16t बाय पाई डी आउटर क्यूब 1 minus k to the power 4, where k is what? What is K? K is what? K is the ratio of inner diameter and outer diameter. K क्या होता है मेरे भाई? इनर और आउटर डायमीटर का रेशियो. So this is solid circular shaft, this is hollow circular shaft, and this is how the shear stress varies from top to bottom. ये सरफेस पे मैक्सिमम होता है. ओके, इट इज मैक्सिमम एट द सरफेस. इज इट क्लियर? इज इट क्लियर? इज इट क्लियर? यस बेटा, आई विल टेक एवरी मैराथन सेशन. ठीक है, मैं सारे मैराथन सेशन लूंगा मेरे भाई, सारे मैराथन सेशन लूंगा. डोंट वरी, ओनली 5 more likes and then we will hit the triple century mark. Okay, now beta, we also have to calculate the angle of twist. So how do we calculate the angle of twist? The angle of twist is given by theta equals to TL by GJ. Theta equals to TL by GJ. Okay, now beta, let's say you have a stepped shaft. अब stepped shaft में क्या करने का? मान लो आपके पास stepped shaft है. Okay, stepped shaft में क्या करने का? Let's say, sorry, let's say you have stepped shaft like this. This is A, B, C, D. Okay, और कुछ ऐसा टॉर्क लग रहा है. ओके, एंड यू नीड टू फाइंड थीटा ए. आपको मैं बोलता हूं थीटा ए निकालो. तो थीटा ए विल बी व्हाट? थीटा ए डी. ए से लेके डी तक का थीटा निकालना पड़ेगा, बिकॉज डी इज फिक्स्ड, ए इज फ्री. तो दिस विल बी थीटा ए बी प्लस बी सी and plus CD. So this is how you calculate theta A. Usually they will ask you to calculate theta A only. If they ask you to calculate theta B, अगर आपको theta B निकालने बोला, then you calculate theta BD. Theta C निकालने बोला, then you calculate theta CD. Now you must be wondering, theta B निकालने बोला तो theta AB क्यों नहीं निकाल सकते? Why theta BD only? Because बेटा, this second end must be fixed. ये D क्या होना चाहिए? D must be fixed. आपको एक फिक्स्ड पॉइंट के अबाउट इस पॉइंट का एंगल ऑफ ट्विस्ट निकालना है. मेरे भाई, लेट्स से I am running and someone else is also running. If I am running, someone else is also running, then will you measure my speed with respect to that running man, or will you measure my speed with respect to some static body? अगर आपको मेरी स्पीड निकालनी है, मैं भी भाग रहा हूं, एक और भी भाग रहा है, तो मेरी स्पीड उसके रिस्पेक्ट में थोड़ी निकालोगे. मेरी स्पीड निकालोगे कोई रुका हुआ है उसके रिस्पेक्ट में ना. that guy who is static, that guy will tell me what is my speed, right? So if I am also running, that person is also running, it will give the absolute velocity. Just like here, if you want theta b, then don't calculate theta AB, because A is also twisting, B is also twisting. If you want theta B, then calculate theta BD, because D is static. तो स्टैटिक के रिस्पेक्ट में ये कितना ट्विस्ट हो रहा है वो निकालेंगे. दोनों अगर घूम रहे हैं तो फिर आप नहीं निकाल सकते, राइट? सो इफ आई वांट थीटा सी, देन आई विल नॉट मेजर थीटा बीसी, आई विल मेजर थीटा सी डी. वाई? थीटा बीसी मेजर किया तो बी इज ऑल्सो ट्विस्टिंग, सी इज ऑल्सो ट्विस्टिंग. But if I measure theta CD, then D is static, so I will get the angle of twist of C. Okay, so is this clear? Is this clear? Yes, D, second point should be fixed. Okay, so this is how you calculate theta. Now, polar section modulus. This is a very important theory point. Okay, what is polar section modulus? It is the measure of the strength of the shaft. Now, when I say strength of the shaft, तो स्ट्रेंथ ऑफ द शाफ्ट का मतलब क्या? व्हाट डू वी मीन बाय स्ट्रेंथ ऑफ शाफ्ट? स्ट्रेंथ ऑफ शाफ्ट मींस हाउ मच टॉर्क आई कैन अप्लाई ऑन दिस शाफ्ट. इस शाफ्ट को कितना पकड़ के ट्विस्ट कर सकता हूं. 100 न्यूटन मीटर, 200 न्यूटन मीटर, 300 न्यूटन मीटर, दैट विल बी द स्ट्रेंथ ऑफ शाफ्ट. ओके, and it depends upon polar section modulus, and polar section modulus depends upon the cross section shape and size of cross section. Okay, now polar section modulus is denoted by ZP, and ZP is given by J upon R maximum. ठीक है, ZP क्या होता है? J upon R maximum. Okay, now if you know Zp, then T allowable will be tau allowable into Zp. अगर आपको Zp पता है तो आप बता सकते हो कितना T अलाउ किया जा सकता है, if you know tau allowable and Zp. Okay, now Zp for solid shaft will be pi by 16 d cube and Zp for hollow shaft will be pi by 16 d outer cube 1 minus k to the power 4. Okay, so polar section modulus of solid shaft, polar section modulus of hollow shaft. Okay, this is the equation. Okay, next is torsional rigidity. अब torsional rigidity क्या होती है? Torsional rigidity is the measure of resistance to deformation. Now deformation is what? Theta. तो जितना ज्यादा rigidity उतना कम theta. More rigidity, less theta. And torsional rigidity is given by G into J. Now you can connect this with axial rigidity. Axial rigidity is EA. Torsional rigidity is GJ. Okay. Similarly, torsional stiffness. So what is stiffness? Load per unit deformation. So torsional stiffness क्या हो जाएगी? What is the load here? The load here is the torque T. And what is the deformation here? Theta. So T by theta also GJ by L will be the torsional stiffness. Okay. So you can compare it with axial stiffness. Axial stiffness is EA by L. Torsional stiffness is GJ by L. ठीक है? So you can connect them. Axial rigidity, torsional rigidity, flexural rigidity. Axial stiffness, torsional stiffness, flexural stiffness. Okay. Next is internal torque. Now understand how we can find internal torque. So let's say we have stepped shaft subjected to different torque. A, B, C, D. अलग अलग point पे torque लग रहा है. Okay. Now I told you how to find internal force. Remember, मैंने internal force निकालना सिखाया था. How do we find internal force in AB? We consider a point, left का total force या right का total force, right? अब बेटा internal force निकालते time we consider tension positive, compression negative. तो internal torque निकालते time positive किसको लेंगे, negative किसको लेंगे? तो यहां पे fix कर लेते हैं. Okay, let's fix this so that we will not be confused. ठीक है? तो कोई एक fix कर लेते हैं. Let's consider this to be positive and this to be negative. उल्टा भी मान सकते हो, उल्टा भी मान सकते हो. It is up to you. Okay. तो बेटा, if I am calculating torque in AB, between AB at this point, left say 100, there is only one torque. According to our sign convention, it is positive. So 100 Newton meter. Now, if I want internal torque in BC, एक point लिया BC में. Now left say there are two torques, 100 and 240. 100 will be positive, 240 will be left say negative. तो ये हो जाएगा 100 minus 240. Or you can also calculate it from right. But right say 360 will be what? Right say 360 will be negative and right say 220 will be positive. So this will be 220 minus 360. So it will be equal to how much? Minus 140. Minus 140 Newton meter. Then CD में, तो CD में consider one point. Left say 3 torques but right say single torque 220 और right से ये वाला torque क्या करना है मेरे भाई? Positive लेना है. तो बेटा it will be how much? 220 Newton meter. So do you understand how to find the internal torque? Yes, Ajoy. Yes, Vivek. Yes. 100 not out. Yes, Rahul, 100 not out. Thank you so much, guys. Thank you so much. 100 not out. We will be not out until 5 o'clock. This is a test match. Okay, this is not a one day match. This is not a T20. This is a test match. 5 o'clock tak batting karni hai. So beta 100 minus 140, 220. Okay. So this is how you calculate the internal torque. Okay. Now, statically indeterminate shaft. So what do we mean by statically indeterminate shaft? Let's say we have a shaft which is fixed at both the ends. ठीक है, दोनों एंड पे ऐसा मैंने फिक्स कर दिया, एंड देन आई एम अप्लाइंग अ टॉर्क समवेयर हियर. यहां कहीं पे मैं एक ऐसा टॉर्क लगा देता हूं. लेट्स से दिस टॉर्क इज टी. This point is A, this point is B, this point is C. Okay. Now, if I draw the free body diagram, then what I am going to get? I will get two reactions here, but I don't know what will be the direction of torque. So, I will assume some direction. मैं कुछ भी एक direction assume कर लेता हूं. Let me assume TA like this and TC like this. If my answer is positive, assumption is right. Answer is negative, assumption is wrong. Now my objective is finding TA and TC, and this is a very popular type of question. ऐसे question बहुत आते हैं exam में. Okay, so how do we find TA and TC? Understand? In order to find TA and TC, I will apply equilibrium equation. तो equilibrium equation क्या हो जाएगी? What will be the equilibrium equation? Net moment must be zero. What are these? These are twisting moments. Net moment must be zero means TA must be T plus TC. So this is one equation. ठीक है, ये एक equation हो गई. This is one equation, but I need another equation. So we have one equilibrium equation and two unknowns. So this is statically indeterminate. Now beta, the other equation will be compatibility equation. So many E, compatibility equation. Okay, so what is compatibility equation? Again and again we come up with this compatibility equation. बार बार ये देखने को मिलता है, right? So beta, what is compatibility equation? Understand. Compatibility equation is the equation of constraint to deformation. डिफॉर्मेशन को कंस्ट्रेन किया, इसीलिए तो ये स्टैटिकली इंडिटरमिनेट बन गया. इफ वी अलाउ डिफॉर्मेशन, इफ दिस एंड इज नॉट फिक्स्ड, इट विल नॉट बी स्टैटिकली इंडिटरमिनेट. इट विल रोटेट and it will not be statically indeterminate, but I have fixed both the ends, so I have constrained the twisting. That's why it became statically indeterminate. So beta, what will be your compatibility equation? Twisting between A and C. A से लेके C तक की twisting 0. Because A is also fixed, C is also fixed. Can I write it theta AB plus theta BC? Yes, I can write them. Now what will be theta AB? A से B के बीच में टॉर्क कितना? TA. So it will become TA into L of AB divided by G of AB into J of AB. Then B से C के बीच में टॉर्क कितना? लेफ्ट से TA माइनस T, राइट से TC. यू कैन राइट एनीथिंग बिकॉज TA माइनस T इज TC. तो आई कैन राइट TA माइनस T, आई कैन ऑल्सो राइट TC. So now I have got a second equation. So by solving equation number 1 and 2, I will get the value of TA and TC. You can do that. You can do that, Mahima. You can consider any direction of TA and TC. Okay. Ultimately, if you are getting positive answer, means your assumption is right. If you are getting negative answer, means your direction is wrong. So beta, it doesn't matter how you consider TA and TC. Whether you are considering them in same direction, opposite direction, doesn't matter. It is up to you. जो लेना है ले लो. Okay. So beta, this is how we solve statically indeterminate shaft. Now there is another type of statically indeterminate shaft which is known as composite shaft. This is also statically indeterminate. Okay. Now what is composite? Composite बोला मतलब different material. Okay. So beta, we have a shaft which is made of, let's say, steel and aluminum. अब हर बार यही दो क्यों लेता हूं? Because usually in exams also you get these materials only, steel, aluminum, copper. They will give you questions based on these three materials only. तो मान लो स्टील और एल्यूमिनियम की शाफ्ट है, ठीक है? तो मेरे भाई, let's say we are applying a torque T. Okay, we have fixed steel and aluminum and now we are applying torque T. Out of these torque T, some torque will be resisted by aluminum and some torque will be resisted by steel. कुछ टॉर्क जो है वो एल्यूमिनियम रेजिस्ट करेगा, कुछ टॉर्क जो है स्टील रेजिस्ट करेगा. Now in order to find how much torque is resisted by steel and aluminum, I need two equations. First equation will be very simple. Torque in steel plus torque in aluminum is equal to T, right? Equilibrium. But the second equation, that will be again compatibility equation. And what will be the compatibility equation? Theta of steel will be equals to theta of aluminum. Why? Because this is a composite shaft. So beta, if I twist this, whatever is the angle of twist of steel, it will be same for aluminum. Because दोनों में अलग अलग twisting नहीं हो सकती, क्योंकि दोनों को बांध दिया है. So beta, they are not free from each other. They are connected to each other. So if I twist, their angle of twist will be same. तो बेटा आप थीटा सी, थीटा एस और थीटा ए एल में वैल्यू रख दो. So this will become TS into LS by G of S into J of S equals to T of A into L of A by G of A into J of A. अब बेटा यहाँ length will be same. So this length will be cancelled, but other values will be different. Other values will be given, only unknown will be TS and TA. So by solving this equation and this equation, you will get the value of TS and TA. Simple. So this is statically indeterminate shaft, another type of statically indeterminate shaft. ठीक है? तो एक तो statically indeterminate shaft ये है और एक ये है. So I hope this is clear to you. I hope this is clear to you. Now, strain energy due to torsion. So बेटा strain energy due to axial load क्या था? P square L by 2 AE. So same relation will be here also. Instead of P, you have T, and instead of AE, you have GJ. So T square L by 2GJ. This will be the equation of strain energy. T square L by 2GJ. Equation of strain energy is very simple. If for axial load it is P square L by 2 AE, for torsion T square L by 2 GJ, for bending M square L by 2 EI. Very simple. Okay. So beta, this is strain energy. That's it. Torsion में you only have to see this much. Torsion में इससे ज़्यादा कुछ देखने की ज़रूरत ही नहीं है. This torsion equation, okay. Then polar moment of inertia of solid shaft pi by 32 d to the power 4. Polar moment of inertia of hollow shaft pi by 32 d outer to the power 4 minus d inner to the power 4. ठीक है? तो बेटा ये then maximum shear stress का formula, then angle of twist का formula, then polar section modulus, torsional rigidity, torsional stiffness, then internal torque calculation you need to understand, then statically indeterminate shafts, and then strain energy due to torsion. That's it. इसके अलावा no बेटा, it is not strain energy per unit volume. Strain energy per unit volume is Newton meter per meter cube. This is Newton meter or joules. It is not strain energy per unit volume. That is different. Okay. This is not strain energy per unit volume. It is strain energy. Okay. That's a good question, Animesh. That's a good question. Yes. Very good. Very good. Very good. Excellent, beta. Excellent. Excellent. So, beta, if you have not still hit the like button, do it right now, because we are moving on to the next chapter, and this is a favorite chapter of all my students, because all my students really enjoy this class, shear force and bending moment diagrams. Okay, so if you have not still hit the like button, I expect you to hit the like button now and I expect you to share this link with all your groups now. अब टाइम आ चुका है मेरे भाई कि लाइक कर दो और शेयर तो एक से ज्यादा ही कर दो तो मजा आ जाए, ठीक है। तो अब प्रस्थान करते हैं उस घड़ी की ओर जिस घड़ी का बहुत बेसब्री से कई बच्चे इंतजार करते हैं, shear force and bending moment. I don't know why, but a lot of students really like this chapter, shear force and bending moment diagram. Okay, although practically if you see that shear force and bending moment diagram is not important for mechanical students, right? Mechanical engineers. Okay, being a mechanical engineer, you will rarely need shear force and bending moment diagram. Okay, we don't need diagram, we only need values. In order to calculate the stresses, we only need values, we don't need the entire diagram. Civil engineers, they need the entire diagram. But beta, that is in our syllabus, so we can't say that if we are not using it, we are not going to study it. We have to study it. Okay? So let's see shear force and bending moment. Now beta, shear force and bending moment diagram is drawn for beams. What is a beam? Beam is a structural member which is used to support transverse load. What do we mean by transverse load? The load acting perpendicular to the axis. Load acting in the direction of the axis is an axial load. जैसे अगर लोड ऐसा लग रहा है, if the load is acting like this, then this is an axial load. ठीक है, ये क्या है मेरे भाई? Axial load. Okay. और ये सब क्या है? All of these are transverse load. This is a transverse load. Okay, this is a transverse load. This is a transverse load because all of them are acting perpendicular to the axis. This is acting along the axis. So axial load, transverse load. Axial load, transverse load. Okay. Now, types of beams. Please cover every type of question. Yes, beta Rahul. This complete marathon class will be only for shear force and bending moment diagram. I will take 6 to 8 hours only to complete shear force and bending moment diagram. मेरे भाई थोड़ा सोच के तो बोल लो. If you want every case of shear force and bending moment diagram, then you just go to my complete class of SFD BMD ना. Then why you are here? अगर आपको सारे केसेस चाहिए तो बेटा आप जाओ और पूरा shear force and bending moment diagram पढ़ लो. I have covered it in 3 chapters. मैंने 3 लेक्चर्स, मैंने 3 अलग अलग लेक्चर लिए हैं एसएफडी बीएमडी पे, 2 स्पेशल क्लासेस भी लिए हैं एसएफडी बीएमडी पे. आई हैव टेकन मैराथन क्लासेस ऑफ एसएफडी एंड बीएमडी सेपरेटली, सो वॉच देम ना. दिस इज नॉट अ मैराथन क्लास ऑफ एसएफडी बीएमडी बेटा, दिस इज मैराथन क्लास ऑफ कंप्लीट रिविजन ऑफ सॉम एंड यू डोंट नीड एसएफडी बीएमडी ऑफ एवरी केस. ठीक है, इफ यू आर बेसिक्स आर क्लियर देन यू कैन ड्रॉ एसएफडी बीएमडी ऑफ एनी केस. ठीक है, तो मेरे भाई एसएफडी बीएमडी जो है ये अपना वो नहीं है. नो इट्स ओके, आई एम नॉट स्कोल्डिंग यू. ठीक है, मैं आपको स्कोल्ड नहीं कर रहा हूं, मैं आपको सोल्ड नहीं कर रहा हूं. ये एक और आ गया है असामाजिक तत्व. ठीक है, यस. Statically determinate. Now types of beams, so we can divide the beams into 2 categories: statically determinate beams and statically indeterminate beams. ठीक है, now what is statically indeterminate and determinate beams? If the number of unknowns are equal to the equilibrium equations, जितने unknown आ रहे हैं उतने equation हैं, then you can find out all these unknown reactions. That is statically determinate beam. If the number of unknowns are greater and equations are less, then it is an indeterminate beam. So we have these 2 types of beams. Okay, statically determinate beam में cantilever simply supported overhang, indeterminate beam में propped cantilever continuous and fixed beam. Okay, now one by one we will see all types of beams. So cantilever beam, one end fixed, other end free. What will be the reactions? There will be a horizontal reaction, a vertical reaction and a couple. 3 reactions, 3 unknowns, 3 equilibrium equation. This is statically determinate. This is statically determinate. Okay, simply supported, one hinge, one roller. So hinge पे 1 horizontal reaction, 1 vertical reaction. Roller पे only 1 vertical reaction. So 3 unknowns, 3 equilibrium equation, statically determinate. Overhang में the support is just like simply support, 1 hinge, 1 roller, but they are not at the end. They are away from the end. Now it can have one overhang, it can have both overhang. एक end overhang हो सकता है, दोनों end overhang हो सकता है, but the reactions will be 3 only. So this is also statically determinate. Okay. Now indeterminate beams are propped cantilever. One end fixed. So 3 reactions here. One end is roller. One reaction. Total 4 reactions. 4 reactions means 3 equilibrium equation, 4 reaction. Indeterminate. Continuous beam. One unknown. Sorry, 2 unknowns like this. One unknown like this. One unknown like this. Total 4 unknowns. 3 equilibrium equation. Statically indeterminate beam. Fixed beam. 3 unknowns like this. 3 unknowns like this. Total 6 unknowns. 3 equilibrium equation, again statically indeterminate. Okay. So in every beam you can see type of support is different, reactions are different. Okay. Now beam with internal hinge. This is a special type of beam. What is beam with internal hinge? Understand, we have 2 different beams which are connected together by means of a pin joint. हमने पिन जॉइंट के थ्रू 2 डिफरेंट बीम्स को कनेक्ट किया हुआ है. सो दिस इज इंटरनल हिंज. ओके, दिस इज नथिंग बट अ पिन जॉइंट. इंटरनल हिंज इज नथिंग बट अ पिन जॉइंट. So we have connected 2 beams with a pin joint. So if you have connected 2 beams with a pin joint, then when you remove the pin joint, you are going to get 2 reactions, right? Let's say the 2 reactions are like this. ठीक है? Sorry. मान लो 2 reactions कुछ इस तरीके से लग रहे हैं. Okay? Let's say this is Rx and this is Ry. Okay? Now, if Rx and Ry are acting here like this, then here they will be equal and opposite, like this, like this. Okay. वैसे थोड़ा मैंने उल्टा बनाया, ऐसा बनाना चाहिए था तो ज्यादा बेटर होता. Although you can draw them in whatever way you want, but ये ज्यादा सही है. तो now you can see that Rx we don't need to consider because this is shear force and bending moment. So axial force we don't need to consider. तो मैं Rx को अगर consider नहीं करता, so this will become like a simply supported beam and this will become like a cantilever beam. ठीक है, ये एक cantilever beam बन जाएगा और ये एक simply supported beam बन जाएगा, है कि नहीं? So बेटा this is what beam with internal hinge. Beam with internal hinge. Thank you so much Prinshu. Thank you so much for such lovely words of appreciation, beta. Thank you so much. It means a lot to me. Thank you so much. Thank you so much. So, beta, this is beam with internal hinge. Okay. Now, distributed loads. What do we mean by distributed loads? If the load is not concentrated at a point, load एक point पे concentrated नहीं है, distribute हो रहा है one point to another point, and in order to show the load, we draw diagrams like this. ठीक है? Now this is a general load. Okay, मैंने एक particular load नहीं लिया है. I have considered some general load. Okay. Now the height of this load is known as load intensity. ये जो height होता है, इस diagram का जो height होता है, this is known as load intensity W. This is known as load intensity, which is what? Load per unit length, kilonewton per meter, Newton per meter. Okay, let's say L is the length of this. Okay, now if you want to calculate the total load, अगर आपको total load चाहिए तो total load is equal to area under the loading diagram. जो लोडिंग का डायग्राम बनता है, इट कैन बी अ रेक्टेंगल, इट कैन बी अ ट्राइंगल, इट कैन बी अ ट्रेपेजियम, व्हाटएवर डायग्राम यू आर गेटिंग. अगर इफ यू कैलकुलेट द एरिया अंडर दैट डायग्राम, you get the total load. Let's say it is capital W. Now let's say you want to calculate the moment. तो moment निकालने के लिए what do? We replace this total load, we replace this distributed load with a point load which will be acting at the centroid. ठीक है, हम क्या करते हैं, इस टोटल लोड को एक पॉइंट लोड से रिप्लेस कर देते हैं जो कहां पे एक्ट कर रहा होगा मेरे भाई, सेंट्रॉइड ऑफ दिस एरिया. सेंट्रॉइड ऑफ दिस एरिया मान लो ये है, तो सेंट्रॉइड पे इसको एक्ट करा देते हैं. ओके, सेंट्रॉइड पे इसको एक्ट करा देते हैं. ओके, so beta, if I want total load, calculate the area. If I want to take the moment, find the centroid of the area. Okay, so let's say we have a uniformly distributed load. Ab uniformly distributed load means the load intensity is constant. Okay, let's say the load intensity is W. So what will be the total load? Total load capital W will be equal to this area, rectangle, W into L. And where will you get this? ये आएगा कहां पे? It will be acting at the center, right? ये कहां एक्ट करेगा? सेंटर पे, because rectangle का centroid will be at the center. तो ये सेंटर पे आ जाएगा. Yes, thank you so much प्रवलिका. Thank you so much. Thank you so much. So beta, this is uniformly distributed load. Now let's say we have a uniformly varying load. Okay, so let's say this is capital W, this is 0. So you can see that load intensity is varying linearly from 0 to W. This is length L. तो total load capital W कितना हो जाएगा? This area is the area of triangle, तो half into W into L. And it will be acting at the centroid, but the centroid will not be at the center. इस बार centroid जो है वो center पे नहीं आएगा. कहां आएगा मेरे भाई? इस बार जो centroid आएगा वो ये बड़े वाले end से, from the bigger end it will be L/3 and the smaller end it will be 2L/3. Okay, so this is uniformly varying load of one type. There is another type, एक और टाइप है, like this. Okay, so if you have a uniformly varying load like this, then what you need to do? Understand. Let's say we have a uniformly varying load which is varying from 10 kilonewton per meter to 30 kilonewton per meter. Okay, the length is, let's say, 6 meter. Okay, now I want to calculate the total load. So what I am going to do here is I am going to divide this into two different area, one rectangle, one triangle. Okay, so I will divide it into two area, one rectangle, one triangle. W1 rectangle के लिए it will be 10 into 6 means 60. W2 ट्रायंगल के लिए इट विल बी हाफ इनटू, अब ये कितना हो जाएगा मेरे भाई? दिस विल बिकम 20 ना, तो हाफ इंटू 20 इंटू 6, सो दिस विल अगेन बिकम 60. तो टोटल लोड W विल बी W1 प्लस W2 मीन्स 120 kilonewton. Yes, now I need moment. So beta, if I consider W directly, do I know where the centroid will be? No, but I know the centroid of rectangle and triangle separately. So beta, I will consider the moment of W1 and W2 separately. So W1 means due to UDL, it will be at the center, and W2 means due to triangle, it will be here. Okay, this is a W1, this is a W2. ठीक है, तो मेरे भाई W1 और W2 अब मुझे मिल गया. तो ये यहां से लग रहा है कितने डिस्टेंस पे? L/2, और ये यहां से कितने डिस्टेंस पे लग रहा है? L/3, right? So beta, this is how you will calculate the moment. You will calculate the moment of W1 and W2 separately, because if I consider W1 and W2 together, if I consider it directly W, then I will not be able to know where to put W. W को कहाँ रखूं नहीं पता, W1 को कहां रखूं, W2 को कहां रखूं ये पता है, W को कहां रखूं ये नहीं पता है, तो मैंने कुछ ऐसा कर लिया, ओके, अपनी मुश्किलों को आसान कर लिया, राइट? यस, वेरी गुड, वेरी गुड, वेरी गुड आदित्य, वेरी गुड प्रेम, वेरी गुड, एक्सीलेंट रिस्पॉन्स बेटा, एक्सीलेंट रिस्पॉन्स। Thank you so much, Mechanical Lip. Thank you so much, beta. Thank you so much. It means really, it means a lot. It feels great. Thank you so much. So, beta, this is how you are going to solve the problem of UDL and UVL. Okay. अब आते हैं मेन मुद्दे पे, shear force. So, what is shear force? Basically, what is shear force? When you apply transverse forces on the beam, okay, let's say I am applying transverse forces on the beam, then on every plane there will be some internal force, and this internal force will be parallel to the cross section. So this parallel force to the cross section, this parallel internal force to the cross section is known as the shear force. If you know the formula of centroid of trapezium beta Shubham, then you can use that. अगर नहीं पता है तो उसके लिए मैंने बताया था पिछला वाला. Okay, so understand that if you calculate the internal force on any plane, it will be parallel to the plane. That's why it is known as shear force. It is known as shear force. Okay. अब बेटा इसको मैं लेफ्ट से भी निकाल सकता हूं, राइट से भी निकाल सकता हूं. फ्रॉम लेफ्ट एंड राइट आई विल गेट द सेम वैल्यू बट opposite like this. Okay, this is known as shear force. Now when I calculate the shear force, then I have to add all the forces from the left or from the right. मेरे को सारे forces add करने पड़ते हैं, ठीक है? या तो left के सारे forces add कर दो या तो right के सारे forces add कर दो. For example, let's say this is 10, this is 5 and this is 15. Okay, तो 10 plus 5, 15 plus 15, 30. अब मान लो दिस इज 12 एंड दिस इज 18, ठीक है? फॉर एग्जाम्पल आई एम सेइंग, ओके, तो ये कितना हो गया बेटा 12, ये कितना हो गया बेटा 10, ओके, तो यहां पे shear force ऐसा आएगा, ओके, हियर द shear force will be how much 2, राइट? 12 अपवर्ड तो 10 plus 2 12 डाउनवर्ड, ओके. अब यहां पे देखो कितना आएगा 5 15 18, ओके, तो 15 plus 5 20 डाउनवर्ड 18 अपवर्ड, so this will be 2 upward, right? So this is the shear force, this is the shear force, okay. 2 2 left से right से you are going to get the same value, okay, but here if it is downward, here it will be upward, so you can calculate it. But in order to calculate shear force, we need to know which force to be considered positive, which force to be considered negative. So we have this sign convention, okay. What is the sign convention? From left, if I calculate the shear force, then this one will be considered as positive and this one will be considered as negative. But right से इसका opposite will be positive, opposite will be negative. Okay, तो अगर मैं यहां से calculate कर रहा हूं left से, 12 will be positive, 10 will be negative, तो 12 minus 10 2. But if I am considering from right, then this will become positive, 15 plus 5 20, this will be negative, minus 18 again 2, okay. So this is the shear force. Similarly, there is bending moment. Now what is bending moment? Bending moment is the internal moment at any section. How do we calculate it? Just like shear force. So in case of shear force, we were adding all the forces. Here we will be adding all the moments. यहां सारे मोमेंट्स को ऐड कर देंगे. अब यहां पे भी आई विल गेट बेंडिंग मोमेंट फ्रॉम लेफ्ट एंड राइट इक्वल एंड ऑपोजिट. नाउ विच वन टू कंसिडर पॉजिटिव, विच वन टू कंसिडर नेगेटिव? अगेन द सेम प्रॉब्लम. सो हियर ऑल्सो वी हैव सम साइन कन्वेंशन. तो बेटा लेफ्ट से इफ आई एम कैलकुलेटिंग, देन आई विल कंसिडर दिस वन टू बी पॉजिटिव, ओके, and this one to be negative. Right say I will consider this one to be positive and this one to be negative, okay. Now if the beam is bending like this, then this is known as sagging moment, and if the beam is bending like this, then this is known as hogging moment. So you need to remember this, ठीक है, आपको ये पता होना चाहिए sagging मतलब क्या होता है, hogging मतलब क्या होता है. Okay, you need to know what is sagging and what is hogging. Okay, so this is what sign convention of bending moment. Okay, so shear force definition, bending moment definition. Now there is a very important relation between load, shear force and bending moment. We have two relation, one between the load and shear force and one between the shear force and bending moment. Understand that relation very well. Okay, so the first relation that you need to remember is between the load and the shear force. So the slope of shear force diagram ds by dx is equal to load intensity. This is one relation which you need to remember. Slope of shear force diagram is equal to load intensity and slope of bending moment diagram is equal to shear force. Slope of bending moment diagram is equal to shear force. So these are the two relations which you need to remember, one between load and shear force, one between shear force and bending moment. Now this relation can also be written like this. इस रिलेशन को मैं ऐसा भी लिख सकता हूं, mb माइनस ma is equal to area of shear force diagram between A and B. Okay, the second relation, if you integrate this, then you get this. Now this is a very important relation which we use. This can be used to find bending moment from shear force diagram. अगर आपके पास shear force diagram है, if you have shear force diagram and if you want to calculate bending moment, then you can use this relation. Okay, this is a very important relation and we use this quite a lot of times. हम बहुत सारे questions में इस concept को use कर सकते हैं. Okay, now we have three examples. Let's say we have a beam and I am considering 2 points A and B. मान लो मैं 2 points consider कर रहा हूं A और B. In the first case, you will notice that the load intensity is 0. In the second case, the load intensity is constant. And in the third case, the load intensity is proportional to X. अब इससे shear force diagram कैसे बनता है? If load is 0, then integrate this, you get shear force. So shear force will be constant. If load is constant, integrate this and you get shear force. So shear force will be proportional to X. And if load is X, integrate this, you get shear force X square. Now X square means parabola. If the load is increasing, the slope of parabola will be increasing like this. Okay, so this will be X square. Now if you integrate it again, you get bending moment. तो बेटा कांस्टेंट को इंटीग्रेट करने पे you get bending moment constant, sorry, लीनियर को इंटीग्रेट करने पे you get bending moment पैराबोलिक को इंटीग्रेट करने पे you get bending moment cubic. Now beta, if the load increasing, then parabola curve will be slope will be increasing. If shear force is increasing, then parabola bending moment will be increasing, slope will be increasing. Ab increasing slope, decreasing slope, it is very difficult sometimes. Okay, people really get confused. Okay, so let's say you want to find how to draw increasing slope or decreasing slope. ठीक है, अब नीचे से ऊपर जा रहे हो, you want to draw the increasing slope. ठीक है, नीचे से ऊपर जाना है, इंक्रीजिंग स्लोप बनाना है. ठीक है, तो बेटा 0 डिग्री 90 डिग्री इंक्रीजिंग स्लोप मतलब 0 to 90 ना, join these two lines and you get increasing slope. okay, अब ऊपर से नीचे आना है, इंक्रीजिंग स्लोप ऊपर से नीचे, अगेन 0 डिग्री 90 डिग्री, join these two small lines, you get increasing slope. So this is what? This is increasing slope. Okay, now we need to draw decreasing slope. अब decreasing slope के लिए क्या करना पड़ेगा बेटा? बहुत आसान. ओके, decreasing slope means 90 to 0. तो नीचे से ऊपर जा रहे हो, this will be 90, this will be 0 degree, right? तो बेटा join these two points and you get decreasing slope. ऊपर से नीचे आ रहे हो, again 90, 0. join these two points, again you are getting decreasing slope. So this is how you draw increasing and decreasing slope. This is a very simple trick which you can use whenever you get confused. What will be the increasing slope? What will be the decreasing slope? ठीक है? और बेटा, let me tell you, a lot of times people get confused and that's where you are going to make mistake. You will get two options. In one case, the parabola will be increasing slope. In one case, decreasing slope. And you will be confused which one will be the answer. So wahan you have to use this trick. Okay? Thank you so much. Thank you so much. Thank you so much. Yes. मेरे भाई minus w plus w doesn't matter because that is dependent on sign convention. So don't worry about the sign. Just look at the magnitude. Okay? Yes. So beta, this is how you draw increasing slope and decreasing slope. बेटा मेरे को repeat करने की जरूरत नहीं है. You just rewind it and it will be repeated ना. This is an online class. Rewind it if you want to see one more time. Okay? So increasing slope, decreasing slope का ये एकदम simple concept याद रखना. Okay? Now beta, sudden change in shear force. So when you get sudden change in shear force, let's say we have point loads. तो point loads के case में, whenever there will be a point load, there will be a sudden change in shear force. ठीक है? जहां जहां point load आ रहे हैं, यहां point load आ रहा है, 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 तो बेटा वहां वहां you will see sudden change in shear force. This vertical lines. Similarly, sudden change in bending moment. तो जहां जहां couple आ रहा है, here there is a couple, here there is a couple, तो वहां वहां you will see sudden change in bending moment. Okay, so this is known as sudden change in shear force and sudden change in bending moment, which happens due to point load and couple. Is it clear? Yes. Now, point of maximum bending moment. Where will I get the maximum bending moment? This is a very important question because in a lot of question you will be calculating the maximum bending moment. ठीक है? कैसे टाइप के क्वेश्चन आते हैं एग्जाम में? What type of question you get? They will give you a beam, some loading, and they will ask you find the location of maximum bending moment or find the maximum bending moment. So in order to find the maximum bending moment, first you need to find the location of maximum bending moment. And how you are going to find the location? You need to know these 2 points. You need to know these 2 criteria. In order for the bending moment to be maximum at any point, किसी भी point पे bending moment के maximum होने के लिए either this criteria has to be fulfilled or this criteria has to be fulfilled. ये 2 criteria होते हैं. First criteria, there is a sign of shear force diagram. Change in sign of shear force diagram. Okay, let's say you have this type of loading condition. ठीक है? Let's say you have this type of shear force diagram. This is my shear force diagram. ठीक है? ये क्या है मेरा shear force diagram? Then you can see that at this point shear force is changing sign. So when you draw the bending moment diagram, then the bending moment will be maximum at this point. So this is what first criteria. ठीक है? ये पहला criteria है. और there must be a couple. या तो फिर couple होना चाहिए. अब couple का केस कौन सा होता है बेटा? कैंटिलीवर बीम. तो कैंटिलीवर बीम लेट्स से इज सब्जेक्टेड टू अ लोड लाइक दिस. तो यहां पे यू विल नोटिस दैट shear force diagram will be something like this, है ना? So shear force is not changing sign, but still bending moment will be maximum. कहां पे? Where there is a couple. अब maximum क्यों आया? क्योंकि यहां पे couple है ना at the fixed end. So do you understand? Either there will be change in sign of shear force diagram or there should be a couple. या तो shear force का sign change होना चाहिए या तो फिर couple होना चाहिए. There you get maximum bending moment. Okay. Next, point of contraflexure. Now this is another very important point. Point of contraflexure. So what is point of contraflexure? Understand. Let's say we have a beam. Okay. Let's say we have a beam like this. Okay, and it is subjected to a couple like this. If you draw the bending moment diagram of this beam, then you will get a bending moment diagram like this. Okay, you might have seen this. Sudden change. Here sudden change. Okay. So you will notice that this is a positive bending moment, this is a negative bending moment. Okay. And at this point, the bending moment is changing sign. So this is the point of contraflexure. ये क्या है? This is the point of contraflexure. Okay. A point of contraflexure पे होता क्या है? What happens exactly? So at point of contraflexure, the nature of bending changes. So from here to here, there is positive bending. So there will be sagging. And from here to here, there is negative bending. There will be hogging like this. So you can see the beam is sagging from this point to this point, hogging from this point to this point. So that's why this point is known as point of contraflexure. Okay. So this is a very important point. Civil engineering में इसका बहुत use होता है. We don't have that use, but still academically we have to study point of contraflexure. Okay. So these are all the basic concepts you need for drawing shear force and bending moment diagram. Now what I am going to do is I am going to consider certain examples in order to show you how to draw shear force and bending moment diagram. So let's consider this example for cantilever beam. ठीक है. अब यहाँ पहले मैं shear force diagram draw करूंगा. Let's first draw the shear force diagram. I will draw the shear force diagram in green and I will draw the bending moment diagram in red. Okay. तो बेटा सबसे पहले मैं shear force diagram draw करता हूँ. Okay. So in order to draw shear force diagram, I will first draw the datum line. Now what do we mean by datum line? On this line, shear force is 0. Now we start from left. Okay. Let's say this point is A, this point is B, this point is C, this point is D. These are the important points. Okay. Now if I start from left, at point A, is there any point load? No, there is no point load. From A to B, there is only UDL. So at point A, shear force will be 0. At point B, what will be the shear force? We are drawing the diagram from left. Left say downward force negative. 1.5 into 2 minus 3. So at point B, the shear force will be minus 3. And from A to B, the shear force will be linear straight line, right? Because it is UDL. Then from B to C, is there any load? No. And if there is no load, shear force will be constant. Now at point C, there is a point load acting downward. So downward force negative. So minus 3, minus 4, minus 7. So it will suddenly change from minus 3 to minus 7. Okay. Sudden change due to point load. This is a UDL, so no sudden change. Sudden change due to point load. Now from C to D, it will remain constant. Then at point D, there must be a reaction, na? एक reaction आएगा, upward reaction. So it will go up to what? 0. It should start from 0, it should end at 0. ठीक है? 0 से start होना चाहिए, 0 पे end होना चाहिए. So this is the shear force diagram. What is this? This is the shear force diagram. So you can see that there are 2 point loads, one at C, one at D. So there are 2 sudden changes, one at C, one at D. Okay. So this is shear force diagram. This is shear force diagram. Welcome Lucy. Now let's draw the bending moment diagram. अब bending moment diagram बनाते हैं इसी beam का. So beta, in order to draw bending moment diagram, again I will draw the datum line. What do we mean by datum line? Datum line means on this line, bending moment will be 0. Now I will start from left at point A. A, B, C, D. At point A, bending moment will be 0. At point B, bending moment will be what? 1.2 into 2, 3. ठीक है, 1.2 into 2, 1.5 into 2, 3. And the load will be acting here at the center. So 1.5 into 2, 3. 3 into this distance, 1. Minus 3. So minus 3 kilonewton meter. 0 to minus 3 kilonewton meter. Now beta, this is a UDL. So the bending moment diagram will be parabolic. Bending moment diagram कैसा बनेगा? Parabolic. Or shear force is increasing or decreasing. It is going on negative side, but don't look at the sign. Look at the magnitude. Shear force is increasing 0 to 3. So slope of bending moment diagram will be increasing 0, 90. So it will be something like this. Okay. It will be something like this. Okay. Now at point C, what will be the bending moment? 1.5 into 2, 3. From here to here, what will be the distance? 2. So 3 into 2, 6. Minus 6. So here, minus 6. Now beta, from here to here, there is no load. So it will be a straight line. Now, at point D, what will be the bending moment? 1.2 into 2, 3. 1.5 into 2, 3. Multiplied by 3, 9. Plus 4, minus 13. Calculation part, I don't have to teach. That is mathematics. Now from here to here, it will be a straight line. Now you can notice that the slope of this line and this line are different. Why? Because shear force here and here are different. Now here shear force is minus 3, here minus 7. So here slope is less, here slope is more. Okay. Now in the end, it will become 0. So this is what diagram. Now notice one thing, the bending moment is maximum at the fixed end. Shear force sign is not changing, but bending moment is maximum at the fixed end. Why? Because there is a couple की वजह से bending moment is maximum. Is it clear? Is it clear? Is it clear? Couple ऐसा लगेगा, यहाँ पे couple जो रहेगा, it will be like this. ऐसा ही लगेगा. Okay. So do you understand how bending moment diagram is drawn from this beam, for this beam? Yes. Now simply supported beam. अब simply supported beam है. Reactions I have calculated because I don't want you to understand how to calculate reaction. That is ना mechanics ना, उतना तो आता ही होगा, right? उतना तो आता ही होगा, right? Welcome MK Yadav, live in Patna. Thank you. Okay. चलो बेटा, अब लेट्स ड्रॉ द shear force diagram for this beam. तो इस बीम के लिए shear force diagram ड्रॉ करना है. अगेन आई विल ड्रॉ द डेटम लाइन फर्स्ट. पहले मैं डेटम लाइन ड्रॉ कर लेता हूं. आई विल ड्रॉ द डेटम लाइन फर्स्ट. ये थोड़ा टेढ़ा हो गया है क्या? चलो कोई बात नहीं, एडजस्ट कर लेंगे. सो बेटा दिस इज, अच्छा shear force diagram है तो ग्रीन में बनाना पड़ेगा ना. इट इज shear force diagram, so I have to draw it in green. Now This is the datum line. So 0, 0. At point A, there will be a sudden change in shear force due to this force. So up to plus 10 because it is upward, and from left upward force is positive. So up to plus 10. Then at point B, अब ये हो गया B, ये हो गया C, ये हो गया D, ये हो गया E. Now at point B, what will be the shear force? 10 minus 12. 10 upward minus 12 downward. So 10 minus 12 minus, 2. So it will go up to minus 2. This is minus 2. Then from B to D, there is no force. This is a couple. Couple doesn't matter in shear force diagram. So B से D तक, it will remain constant. Then at point D, there is a downward force, minus 4. So minus 2, minus 4, minus 6. Then from here to here, it will remain again constant. Then minus 6 plus 6, it will become 0. So this is what shear force diagram, and you might have noticed that it is changing sign. It is changing sign. Where it is changing sign? It is changing sign here at this point, right? Now beta, let me call this point F point. So I need to find the location of this F point. अब मुझे इस F point का location चाहिए. How I can find the location? Let me call this distance x. मैं इस distance को x ले लेता हूं. Then what will be this distance? This distance will be 3 minus x. Okay. So I can apply similar triangle. या तो मैं similar triangle लगा देता हूं. Okay. x by 10 equal to 3 minus x by 2. Or what I can do is shear force at F must be 0. Shear force at F क्या होना चाहिए? 0. So how I can find the shear force at F? 10 minus 4x. 10 minus 4x. 10 minus 4x equals to 0. So x will become equals to how much? 2.5 meter. So this will be the point at which bending moment will be maximum, right? अब ये जो point है, इस point पे bending moment क्या हो जाएगा? Maximum हो जाएगा, right? So now when I will be drawing the bending moment, I will calculate the bending moment at F, because at that point bending moment can be maximum. It will be maximum, not necessary. It can be maximum because there is a couple also. So bending moment can be maximum here also. यहां भी मैक्सिमम हो सकता है, यहां भी मैक्सिमम हो सकता है. यहां साइन चेंज हो रहा है और यहां कपल है. बोथ आर देयर. सो हियर इट कैन बी मैक्सिमम और हियर इट कैन बी मैक्सिमम. दैट वी विल नो व्हेन वी विल कैलकुलेट. वो तो कैलकुलेट करने के बाद पता चलेगा. ओके. नाउ लेट्स ड्रॉ द बेंडिंग मोमेंट डायग्राम फॉर द सेम बीम. सो बेटा, इन ऑर्डर टू ड्रॉ द बेंडिंग मोमेंट डायग्राम, आई विल ड्रॉ द डेटम लाइन. ठीक है, डेटम लाइन ड्रॉ कर ली. Now beta, calculation of bending moment has to be done beforehand. पहले ही bending moment calculate कर लो, तुरंत तुरंत निकलता नहीं है. Okay. Now I need to find the bending moment at these points. What are these points? A point, यहाँ पे कहीं पे F point भी है. This is B point, this is C point, this is D point, and this is E point. A point पे bending moment will be 0. F point पे bending moment क्या होगा? वेरी इजी. F पॉइंट से A पॉइंट तक का एरिया ऑफ शियर फोर्स डायग्राम निकाल लो, है कि नहीं? F से A तक का एरिया ऑफ शियर फोर्स डायग्राम निकाल लो. व्हाट विल बी दिस एरिया? हाफ इंटू बेस इंटू हाइट. तो हाफ इंटू 2.5 इंटू 10, 5 इंटू 2.5. सो दिस विल गिव यू व्हाट? 5 इंटू 2.5. लेट मी ब्रिंग माई कैलकुलेटर. 5 into 7.5, 37.5. yes, 37.5. तो F point पे bending moment will be 37.5. Now from A to F, It will be a parabola, increasing slope or decreasing slope. Shear force is decreasing, so slope will be decreasing like this. At point B, what will be the bending moment? So यहाँ से डायरेक्ट कैलकुलेट कर लो. 10 into 3 30, 4 into 3 into 1.5, 30 minus 12 into 1.5, 12 है ना. It will be 12. 10 into 3 30 minus 12 into 1.5, तो 30 minus 12 into 1.5 12. So I am getting this 12. ठीक है. Now क्या 12.5 होगा? Okay. Now from here to here again we will have parabola, but this time shear force is increasing, so slope will be increasing like this. ये increasing slope हो गया. ठीक है. So बेटा here 37.5 and here it is 12. 12 कैसे आया? Left से 10 into 3 30 minus 4 into 3 12 into 1.5. तो 30 minus 12 into 1.5 12. Okay. Then at point C, अब C point पे there is a couple. तो कपल के केस में what you need to do is पहले बिना कपल के बेंडिंग मोमेंट निकाल लो. तो if I don't consider the couple, bending moment will be what? 10 into 5. 10 into 5 minus UDL का लोड कितना? 12. और डिस्टेंस यहां सेंटर से यहां तक का डिस्टेंस 2 plus 1.5 3.5 8. आई एम गेटिंग 8. तो यहां पे एक वैल्यू क्या आ रही है बेटा? 8. एंड फ्रॉम हियर टू हियर आई एम गोइंग टू गेट अ स्ट्रेट लाइन. ओके. अब यहां पे देयर इज अ बेंडिंग मोमेंट 10. ठीक है. तो बेटा इट विल बी एडेड. 37.5 नहीं होगा, 12.5 होगा. एक सेकेंड, सॉरी, आई हैव मेड सम मिस्टेक आई थिंक. एक सेकेंड. हाफ इंटू बेस इंटू हाइट, राइट? तो हाफ इंटू 0.5 इंटू 10 इंटू 2.5. Oh, sorry, 12.5. Yes, 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 yes. Sorry, sorry. This will be 12.5. 0. This will be 12.5. Yes. And this will be 12. Sorry, sorry, my calculation mistake. So sorry for that. Okay. और यहां पे वैल्यू आ रही है विदाउट कंसिडरिंग द कपल. आई एम गेटिंग 8. नाउ आफ्टर कंसिडरिंग द कपल व्हाट आई विल गेट? This is 10 positive moment. Left say this is positive moment. So 8 plus 10, it will suddenly jump up to 18. ये कहां तक jump कर देगा? 18. Then at point D, what will be the bending moment? अब D पे निकालने के लिए पूरा left से आने की जरूरत नहीं है. You don't have to consider from left. You just calculate it from right. तो right से 6 into 2, 12. And it will be positive. Okay. 12 and it will be positive. Okay, like this 12, and then at point T it will become 0 like this. Okay, so this is the complete bending moment diagram. Now where you are getting maximum bending moment? You are getting maximum bending moment here. Why? Because there is a couple. So beta bending moment can be maximum here, bending moment can also be maximum here. Bending moment यहाँ भी हो सकता है मैक्सिमम और यहां भी हो सकता है. ओके, सो दिस इज द कंप्लीट बेंडिंग मोमेंट डायग्राम. ओके, सो आई होप इट इज अंडरस्टूड. अब ओवरहैंग के लिए, ओवरहैंग के लिए, ओवरहैंग के लिए आई होप यू विल बी एबल टू सॉल्व. ठीक है, मेरे को लगता है ओवरहैंग का आप लोग बना लोगे, बट लेट्स डू दिस. ठीक है, ये भी कर लेते हैं फटाफट से, ये भी कर लेते हैं. सो लेट्स से दिस इज द शियर फोर्स डायग्राम. ओके, 0 0 फटाफट चलेंगे. सो बेटा 27 अपवर्ड, 27 अपवर्ड, सॉरी 27 ऊपर, देन 27 minus 40 minus 13. 27 minus 40 minus 13. This is 27 and this will be minus 13 है ना. 27 upward minus 40 नीचे, तो 27 minus 13, sorry minus 40 minus 13 and it will be like this. Then it will be constant, sorry, like this. Then minus 13 plus 19, so plus 6. Then it will again be constant. Then plus 6 minus 6, it will become 0. Okay, so this is shear force diagram. This is what shear force diagram which is changing sign here, है ना. यहाँ कहीं पे साइन चेंज हो रहा है. अब इसका बेंडिंग मोमेंट निकालना है तो फर्स्ट यू नीड टू फाइंड दिस डिस्टेंस. पहले आपको ये x निकालना पड़ेगा. तो ये x आप लोग कैलकुलेट कर लोगे. आई होप यू गाइस विल बी एबल टू कैलकुलेट दिस x. तो आई विल क्विकली ड्रॉ हाउ दिस बेंडिंग मोमेंट डायग्राम विल लुक. यू कैन फाइंड द वैल्यूज योरसेल्फ. ठीक है, वैल्यूज आप लोग खुद निकाल लोगे, ये मुझे पता है. ओके, तो यहां कहीं बेंडिंग मोमेंट विल बी मैक्सिमम. तो आपको कुछ ऐसा डायग्राम मिलने वाला है. ओके, आपको कुछ ऐसा डायग्राम मिलने वाला है. बेंडिंग मोमेंट का डायग्राम विल बी समथिंग लाइक दिस. You will notice one thing, that bending moment will change sign somewhere. Bending moment जो है यहाँ पे sign change करेगा. So this is point of contraflexure. अब bending moment यहाँ sign क्यों change कर रहा है? Logically understand it. Here shear force is changing sign how many times? 2 times. Shear force जो है 2 बार sign change कर रहा है. And if shear force changes sign 2 times, bending moment will change sign 1 time. If shear force is changing sign 3 times, bending moment will change sign 2 times. If shear force is changing sign 4 times, bending moment will change sign 3 times. Okay, so beta this is what bending moment diagram will look like. You can find the values yourself. आप values तो खुद ही निकाल लोगे. Okay, so this is the complete shear force and bending moment diagram. So beta this is the end of chapter 4. Are you able to connect with me? Who is with me? Who is with me? Is your complete shear force and bending moment revised? बेटा you don't have to get into very much detail of shear force bending moment कि सब केस का देख रहे हैं, बहुत complicated cases का draw कर रहे हैं. You don't have to do that, because if you see बेटा you will get very simple questions from shear force and bending moment diagram in exam. एग्जाम में आपको shear force और bending moment diagram के बहुत ही simple questions आने वाले हैं. So beta if you know the basic concepts of SFD BMD, you will be able to solve the problem yourself. ठीक है, and we have solved so many problems of SFD BMD. If you notice हमने इतने questions solve किए SFD BMD के कि उसकी हद नहीं है. Okay, so beta you don't get very complicated questions from SFD BMD. Yes, very good Aditya, Vivek, very good Karan, Shashank, Prashant, Dhananjay. Yes. PYQ sufficient है. PYQs will be enough. Just look at this basic concepts and solve PYQs. That will be enough. So shall we take another break or do you want to move on? Do you want to have lunch? किसी को lunch लेना है? Do you want another break or shall we move forward? एक और break लें. Shall we take a break of 15 minutes? Yes or no? For break, just type yes. For no break, just type no. और पढ़ना है. चलो. So let's do one thing. Let's complete this chapter and then we will take a break. ठीक है? एक और chapter कर लेते हैं और उसके बाद एक break लेते हैं. Okay? Let's do one more chapter. Bending के बात करते हैं. Yes. Bending की बात करते हैं. Okay, so let's start with bending stresses in beams. So once you calculate the bending moment, then you calculate the bending stress. अब bending stress calculate करने के लिए we assume that the beam is under pure bending. What do we mean by pure bending? If the beam is subjected to equal bending moment at every section. अगर बीम के हर सेक्शन पे बेंडिंग मोमेंट इक्वल है, then it is known as pure bending. So what do we mean by pure bending? Pure bending means the bending moment from one point to another point is equal. हर एक सेक्शन पे बेंडिंग मोमेंट सेम आ रहा है, like this. Okay, so this is known as pure bending. Now pure bending के लिए shear force must be zero. For pure bending, dm by dx must be zero, means shear force must be zero. यानी कि कोई ट्रांसवर्स फोर्स नहीं होना चाहिए. If there is a transverse force, then shear force will not be zero, means bending moment will not be constant. Okay, now there are some other assumptions which we need to make in order to derive the equation of bending, and this equation which we will be using for finding the bending stress is known as Euler-Bernoulli's beam theory. Now beta, what is this beam theory? What are the assumptions that you need to understand, because you get 1 mark questions from these assumptions. तो Euler-Bernoulli beam theory के assumptions बहुत important है बेटा. You get questions from these assumptions. Okay, so understand these assumptions. The first assumption is the material of the beam is homogeneous and isotropic. Second assumption, Young's modulus in tension and compression are same. Third assumption, stresses are within proportional limit. Fourth assumption, beam is under pure bending. Now these assumptions are very easy to understand. The fifth assumption is very important. All the transverse sections remain plane after bending. ये बहुत important है. Okay, so understand the meaning of this. All the transverse sections remain plane after bending. So let's say we have a cross section like this. Okay, after applying the bending moment, let's say the cross section bends like this. Now I am assuming that even after bending it will remain straight only. Bending होने के बाद भी ये straight ही रहेगा. So if it is remaining straight after bending, it means that from top to bottom the deformation, the strain will be linear, means the stress will be linear. तो ये जो fifth assumption है, all the transverse section remain plane after bending. Initially it was like this, now it is bent like this. After bending also I am assuming it is straight. So it means that from top to bottom the strain will be linear, means the stress will be linear. Okay, so this is a very important assumption. Next is beam is initially straight and it bends into circular arc. ठीक है, तो beam initially straight थी और अब ये bend होने के बाद क्या बन गई? Circular arc. Okay, and the last assumption, cross section of the beam is symmetric about the plane of loading. Now understand, cross section of the beam, every cross section that we consider should be symmetric about the plane of loading. This is plane of loading. ये क्या है मेरे भाई? This is plane of loading. जो लोड लग रहा होता है वो इस प्लेन पे लग रहा होता है, like this. Okay, like this. Okay, so the loads are in this plane only, bending is happening in this plane only. Okay, तो ये जो प्लेन रहेगा ये अपना y एक्सिस रहेगा, राइट. क्रॉस सेक्शन के लिए साइड से देखो, दिस इज माय क्रॉस सेक्शन, राइट. साइड से देखने पे दिस इज माय क्रॉस सेक्शन. ओके, दिस इज माय क्रॉस सेक्शन. तो इस क्रॉस सेक्शन के लिए दिस विल बी विच एक्सिस? दिस विल बी द y एक्सिस. So about y axis the cross section should be symmetric. You can see all the cross sections we consider are symmetric. You will never find a cross section like this. आपको ऐसा cross section कभी नहीं मिलेगा. Have you ever seen a triangle like this in your chapter? कभी ऐसा triangle मिला है? नहीं मिलेगा. यहाँ centroid will be somewhere here, so it will not be symmetric about this axis. Okay, तो ऐसा कभी भी ट्रायंगल आपको देखने को नहीं मिलेगा. इफ यू सी द ट्रायंगल इट विल ऑलवेज बी लाइक दिस, आइसोसेल्स ट्रायंगल. दिस इज नोन एज आइसोसेल्स ट्रायंगल. ओके, रेक्टेंगल, सर्कुलर सेक्शन, आई सेक्शन, ऑल दीज सेक्शंस आर सिमेट्रिक अबाउट दिस प्लेन ऑफ लोडिंग y एक्सिस. ओके, अब बेटा बेस्ड ऑन दिस वी डिराइव द इक्वेशन ऑफ बेंडिंग. ओके, Now in the equation of bending, two very important concepts, neutral layer and neutral axis. What is neutral layer? When you bend the beam, then every layer bends, every layer deforms, but there is one layer which does not deform. ठीक है, मतलब मान लो ये लेयर जो है इनिशियली 100 mm था लेंथ, अब बेंडिंग के बाद टॉप लेयर बिकेम 90 mm, बॉटम लेयर बिकेम 110 mm, बट बीच में 90 से 110 आने तक बीच में वन लेयर विल बी 100, initial 100, final 100, means there is no change in length in this. So this layer is known as what? Neutral layer. ये जो layer है ये मेरी क्या है? Neutral layer. Why neutral layer? On this layer there is no stress, there is no strain. ना कोई deformation हुआ, ना कोई resistance आया, so no stress, no strain. So is it clear? On the top there is compressive stress. At the bottom there is tensile stress, but on this layer there is no stress. Okay, so is it clear? Who is with me? Beta, please keep liking and sharing. It is very important. Till the end all of you must remain there. तभी मेरी एनर्जी ऐसी रहेगी मेरे भाई, वरना धीरे धीरे मैं ऐसा सुस्त हो जाऊंगा और धीरे धीरे मैं गिर जाऊंगा. ठीक है, तो मेरे को गिरने से बचा लेना मेरे भाई. So beta, this is neutral layer. Now what is neutral axis? If this is neutral layer, what is neutral axis? So beta, if I cut this beam using the neutral layer से अगर मैं काट दूं, then the cross section will be cut on this line. This line is known as neutral axis. तो अगर मैं क्रॉस सेक्शन को न्यूट्रल लेयर से काटूं तो जिस लाइन पे ये कट होगा, द लाइन एट विच इट इज गोइंग टू कट, दैट इज द न्यूट्रल एक्सिस. ओके, नाउ न्यूट्रल एक्सिस ऑलवेज पासेस थ्रू द सेंट्रॉइड. न्यूट्रल एक्सिस हमारा हमेशा सेंट्रॉइड से पास होता है if these two conditions are fulfilled. First, material is homogeneous and there is no plastic deformation. Now this is our basic assumption na, that material is homogeneous and there is no plastic deformation. So that's why in every problem we get neutral axis on centroid only. Otherwise if you consider plastic deformation, then your neutral axis might shift. If you consider non-homogeneous material, then your neutral axis might shift. Okay, so beta, these are the two basic assumptions due to which in every problem, हर problem में आप देखोगे neutral axis हमेशा centroid पे ही आता है. Okay, so beta, based on this we derive the equation of bending. तो बेटा equation of bending क्या होती है? What is the equation of bending? Sigma by y equals to m by I equals to E by R. This is the equation of bending. अब इस equation में sigma is bending stress, y is the bending the distance of the layer where you are calculating bending stress from neutral axis. ठीक है, y क्या है? Vertical distance फ्रॉम न्यूट्रल एक्सिस. ठीक है, तो जिस भी पॉइंट पे बेंडिंग स्ट्रेस निकाल रहे हो, द पॉइंट वेयर यू आर कैलकुलेटिंग बेंडिंग स्ट्रेस, व्हाट इज द वर्टिकल डिस्टेंस ऑफ दैट पॉइंट फ्रॉम न्यूट्रल एक्सिस. ओके, m is bending moment, I is moment of inertia about neutral axis, cross section का moment of inertia about neutral axis, E is Young's modulus and R is what? R is known as radius of curvature. अब ध्यान से देखो radius of curvature क्या होता है. So बेटा let's say मेरी बीम बेंड होने के बाद ऐसी हो गई, सॉरी मेरी बीम बेंड होने के बाद ऐसी हो गई, बेंड हो गई, ऐसी हो गई. ओके, सो बेटा दिस इज व्हाट? दिस इज अ सर्कुलर आर्क. आई अज्यूम दैट दिस इज अ सर्कुलर आर्क. तो इस सर्कुलर आर्क का कोई ना कोई सेंटर होगा, इस सर्कुलर आर्क का कोई ना कोई सेंटर होगा. सो दिस विल बी द रेडियस. सो दिस इज द रेडियस ऑफ कर्वेचर. ठीक है, दिस इज द सेंटर ऑफ दिस आर्क, तो ये रेडियस ऑफ कर्वेचर. ओके, बीम जितनी बेंड होगी रेडियस ऑफ कर्वेचर उतना कम आएगा. ओके, द मोर द बीम इज बेंड, द लेस विल बी द रेडियस ऑफ कर्वेचर. द लेस द बीम विल बेंड, the more will be the radius of curvature. तो radius of curvature ज्यादा मतलब bending कम, radius of curvature कम मतलब bending ज्यादा. Okay, so this is radius of curvature. Now beta, if you see this equation, sigma will be directly proportional to y, means your bending stress will vary linearly. Now you will find two types of cross sections. In one case you will see that the centroid will be at the center. एक केस में आप देखोगे centroid जो है वो center पे रहेगा, और एक केस में आप देखोगे centroid will not be at the center. If the centroid is at the center, then the bending stress from top to bottom will look like this. अगर bending stress आप top से bottom तक देखो, it will look like this. Now do you notice one thing? What do you notice? Maximum stress at top and maximum stress at bottom will be same. Let's say this is maximum stress in tension, maximum stress in compression. So as this point is at the center, अगर ये center पे है, तो this and this will be numerically equal. So sigma maximum in tension and sigma maximum in compression will be equal. But here y is not at the center. So maximum stress at top and bottom will also not be equal. यहां पे अगर आप देखोगे sigma maximum in tension will not be equal to sigma maximum in compression. तो इस केस में if I ask you to calculate sigma maximum in tension and compression, then you have to calculate two different values. उस केस में फिर आपको दो अलग अलग वैल्यू निकालनी पड़ जाएंगी. Okay, one for tension, one for compression. Okay, so this is unsymmetrical loading, this is unsymmetrical loading. Okay, so symmetrical cross section, unsymmetrical cross section. ठीक है, usually you only get symmetrical cross section. Unsymmetrical cross section में they will only give you triangle, they will not give you T section, or they will not give you some other unsymmetrical section. They will only give you rectangle, circle, maximum triangle. Okay, so don't worry about it. Even I section you don't get. Okay, now section modulus, which is denoted by Z. तो section modulus क्या है? Just like polar section modulus, section modulus is also the measure of the strength of beam, how much the beam can resist the bending moment. So beta, section modulus Z is given by I by Y maximum. Okay, and this will decide what will be M allowable. So here M allowable is equal to sigma allowable into Z. How much bending moment can be allowed, that depends upon how much stress can be allowed and what is Z. Ab how much stress can be allowed, that depends upon the material. So how much Z can be there, that will decide M allowable. Okay, तो sigma allowable तो material की वजह से fix हो जाता है, तो अगर मुझे M बढ़ाना है तो Z बढ़ा करना. Now for same area, Z of I section is greater than Z of rectangular section, which is greater than Z of circular section. तो सबसे ज्यादा Z किसका होता है? I section का. That's why in case of bending, I sections are always preferred because उनका Z सबसे ज्यादा है, and if Z is maximum, M allowable will be maximum for the same material. Material वही है, तो अगर Z ज्यादा, M ज्यादा. सब स्टील के बने, स्टील का I section, स्टील का rectangle, स्टील का circle. So sigma allowable is same, but Z of I will be maximum, so M of I will be maximum. Okay, now you have to remember the equation of I for different members. Okay, so here in this table I will give you Y maximum, I and Z, but you only focus on I. Y maximum to you all know, Z you don't need to remember. I by Y maximum will give you Z. So let's say we have a rectangular section of width B, height H. So Y maximum will be H by 2, I will be BH cube by 12 and Z will be BH square by 6. For circle, let's say this is D by 2, this is D by 2. So Y maximum D by 2, I will be pi by 64 D to the power 4 and Z will be pi by 32 D cube. Okay. Usually you will get these two cross sections only. Maximum cases you will get these two cross sections only. Okay. Next is hollow circle of inner diameter di and outer diameter do. What will be Y maximum? Do by 2. What will be I? Pi by 64 d outer to the power 4 minus d inner to the power 4. Or I can write it like this also. If I take d outer to the power 4 common, then it will become 1 minus k to the power 4, where k is what? K क्या है? D inner by D outer. Okay. Then Z will become I by Y max. तो ये हो जाएगा pi by 32 D outer cube 1 minus k to the power 4. Now we have a hollow circle where thickness is very less than diameter. Okay, this is also a hollow circle, but this is a hollow circle with negligible thickness. तो इसके लिए y maximum होता है d by 2. It should be d by 2 plus t, but t is very less, neglected. And I का फॉर्मूला होता है pi d cube t by 8. तो z will become pi d square t by 4. Okay. So you need to remember this because you use this in a lot of cases. बहुत सारे cases में ये use होता है. Okay. Then triangle. So for triangle, neutral axis will be at h by 3 from base. तो बेटा यहाँ पे y maximum will be 2h by 3. I will be bh cube by 36 and Z will be BH square by 24. I section usually is not there. ठीक है, usually I section के ऊपर questions आते नहीं है, but if there is a question, then you can use this equation to find the moment of inertia. Okay, let's say this is I, this is B. ठीक है, अब मेरे भाई ये थिकनेस हम लोग मान लेते हैं T1 और ये थिकनेस हम लोग मान लेते हैं T2. Y maximum will be h by 2. I will be equal to what? Capital BH cube by 12 minus small BH cube by 12. Now capital B and capital H तो पता है. Small b will be equal to what? Capital B minus T2. And small h will be a what? Capital H minus 2T1. ठीक है, कैपिटल H माइनस दिस. ओके, तो बड़े वाले रेक्टेंगल में से ये स्पेस ये स्पेस जो है ये घटा दूंगा, देन आई विल गेट दिस. ओके, मोमेंट ऑफ इनर्शिया ऑफ I. Y Z का फॉर्मूला यू डोंट नीड, you only remember I का formula. Okay, so this is bending stresses in beams. Now flexural rigidity का formula, तो flexural rigidity is given by E into I and flexural stiffness is given by EI by L. Just like axial rigidity and axial stiffness, axial rigidity is EA, axial stiffness EA by L, torsional rigidity GJ, torsional stiffness GJ by L, flexural rigidity EI, flexural stiffness EI by L. Okay. Now combined axial load and bending. Understand. Let's say we have axial load, but this time axial load is not passing through the centroid. The centroid is here and axial load is at some distance from this centroid. Let's say this distance is E. So what will happen? Due to this load there will be a moment. So beta, you will get two stresses, one due to force P and one due to moment PE. So if I want to calculate maximum tensile stress and maximum compressive stress, understand what will happen. I will have to add the stress due to P and due to PE. अब P की वजह से the stress will be what? Tensile. P by A, P by A. If the load is acting compressive, this will be minus P by A, minus P by A. So it doesn't matter whether you are calculating tensile stress or compressive stress, axial stress will remain same because axial load will be either tensile or compressive. तो या तो tensile है तो दोनों के लिए tensile, compressive है तो दोनों के लिए compressive. Okay. But when you are calculating tensile stress, then the stress due to bending moment will be my maximum minus my maximum by I, and stress compression wala, sorry, this will be plus and compression wala minus. तो बेटा बेंडिंग स्ट्रेस विल बी टेंशन टेंसाइल एंड कंप्रेसिव. तो अगर टेंसाइल स्ट्रेस निकाल रहे हो तो दिस विल बी पॉजिटिव, कंप्रेसिव निकाल रहे हो तो दिस विल बी नेगेटिव, वेयर m विल बी इक्वल टू व्हाट? P into E. So beta, this all you need to do. You need to just add the stresses due to axial load and due to bending. Okay. Axial load का stress will be either tensile for both or compressive for both. But bending stress, if you are calculating tensile stress, it will be positive, compressive stress, it will be negative. So this is combined axial load plus bending. Okay. Beam of uniform strength. Now this is a very important topic. Beam of uniform strength का मतलब क्या होता है? If the bending moment at bending stress at every section is same, then it is known as beam of uniform strength. Okay. और beam of uniform strength का जो cross section है वो vary करता है. Now if you want to understand this in detail, you can watch my full lecture. Otherwise usually gate में they only ask this point. ये point बस पूछते हैं. What is beam of uniform strength? So beam of uniform strength is a beam which is subjected to equal bending stress at every section. That's it. That's all you need to remember. Okay. So this is the entire bending stress in beams. What you need to remember? You need to remember the assumptions of Euler-Bernoulli's beam equation, beam theory. You need to remember the pure bending. Pure bending क्या होता है? Euler-Bernoulli's beam theory. Then the assumptions of Euler-Bernoulli beam theory. Neutral layer, neutral axis. Then beam equation. Then this variation. Then section modulus. Then the formula of I. Then flexural rigidity, flexural stiffness. Combined axial load plus bending. And beam of uniform strength. That's all you need to remember in bending. Okay. So beta, this is the end of bending stress in beams. The next chapter is shear stress in beams. और shear stress in beams start करने के पहले we will take a break, a small break. Shall we take a 20 minutes break? It is 1:40 right now. We will be back at 2 p.m. and I expect all of you to take your lunch. तो आप सब लोग लंच कर लें 2 बजे तक. फिर 2 बजे से we will start the next session till 5 o'clock and we will end all the other chapters. So what do you guys say? 2 बजे से चालू करेंगे और फिर सीधे 5 बजे ब्रेक लेंगे, right? Yes. 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 Okay. Okay. So we will be back at 2 p.m. We will be back at 2 p.m. You have 20 minutes break. Take the lunch. आराम से लंच खाओ, उसके बाद चालू करते हैं. But don't go anywhere. You need to be with me till 5 p.m. 5 p.m. को the lecture will end. So you need to be with me till 5 p.m. and you need to hit the like button right now. If you have not liked it, you need to share this with as many people as you can. तो सबको share करना मत भूलना. Yes. Thank you so much, lovely people. Very Kuti, Nitin, Parmeshwar, Aditya, Ankur. Thank you so much, Grubler, Rahul. Thank you so much, guys. Ajay, Karan, thank you so much. Thank you so much. Thank you so much, guys. Thank you so much. Lovely, lovely, lovely. Thank you so much. Thank you so much. Thank you so much, Parmeshwar. Thank you so much. मजा मजा मजा. Yes. तो मेरे भाई आगे भी मजे आते रहेंगे. आई विल सिंग अ सॉन्ग एट द एंड. ठीक है, एंड करेंगे तो गाने के साथ करेंगे. ओके, गाए भी दूंगा, नाच भी दूंगा. यस 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 Venkatesh at the last. Chalo, so let's take a break. 2 p.m. We will meet at 2 p.m. Okay, thank you so much. And I'm back. Let me just put my mic back. Yes, so we are live again. Welcome everyone, welcome back, Ankur, welcome back, Vinay, Jyotika, Karan, Aditya, welcome back, Dhananjay. Yes, we are live again and we will complete the strength of material now. So this is chapter number 6, shear stresses in beams. We have already completed 5 chapters. We have already completed big chapters and now we are going to complete the rest of the 6 chapters. 5 chapters already gone, we only have 6 chapters. Shear stress in beams, deflection in beams, complex stress, complex strain, pressure vessel and then columns. Yes, Akshay, Prabhakar, Jay. Yes, Karan. Yes, Nitin. Yes, Varun. Yes, everyone is back now. Everyone is back. Yes. Call other friends also. Share this and call other friends. Yes. Okay. So let's start. So we will start with shear stress in beams now. Now beta, let me tell you, shear stress in beams is not that important for mechanical engineering students. You will not get a lot of questions from shear stresses in beams in PYQs. आपको PYQs में देखने को मिला होगा from shear stress of beams you get very simple questions, right? But still we have to cover everything, we can't leave anything, okay? So let's see what is shear stress in beams. So beta, let's say a beam is subjected to transverse forces. So on any section you get shear force as well as bending moment. So we have already seen how to find bending stress in beams. Now we will see how to find shear stress in beams. So first of all, we need to find a section where shear force will be maximum. So on this section, shear force will be maximum. Okay. Now if you simply calculate the shear stress using force upon area, then it will give you average shear stress, okay? But the shear stress is not constant from top to bottom, it varies. So beta, shear stress will not be simply force upon area, that will just be average shear stress. Actual shear stress is given by a different equation. So let's say we have a rectangular section and we need to find shear stress on this plane. Let's say this is XX. So somewhere on this plane I want to find shear stress, okay? So shear stress on this plane will be equal to S into AY bar divided by I into B. This will give you the actual shear stress, okay? This will give you the actual shear stress and you will see that this shear stress will not be constant. From top to bottom, the shear stress will vary. Now in this equation, S is the shear force, I is the moment of inertia about neutral axis. What is AY bar? So AY bar is the first moment of area. AY bar is actually the first moment of area above or below XX about neutral axis. So let's say we are calculating the shear stress on this layer XX. इस layer पे किसी point पे I am calculating tau. Then I will consider the area either above XX or below XX. Let's say I am calculating this area. So beta, A will be this area and what will be Y bar? Y bar will be the distance from centroid of this area and neutral axis. Neutral axis से इस area के centroid तक का distance will be Y bar. So AY bar क्या हो जाएगा? First moment of area. Now what is B? B is the width of layer XX. You are calculating shear stress at XX, so B will be the width of layer XX. Now here the width of every layer will be same, but if you have a circle or a triangle, then width of every layer will be different. So XX will be the width of the layer XX. Thank you so much, Kamil. Thank you so much. Thank you so much. Thank you so much. So beta, this is the equation of shear stress. Now you will notice that this AY bar will not be same from top to bottom, right? So from top to bottom, the shear stress will not be constant, it will vary. So now we have to see how the shear stress varies in different section. So let's say we have a rectangular section. मान लो हमारे पास एक rectangular section है, okay? So how the variation of shear stress will look like in this case? So in this case, the shear stress at from top to bottom will vary something like this. Now understand, this variation is parabolic. Shear stress variation is parabolic. It is not linear, it is parabolic. ये जो equation होती है, this is parabolic. Okay, and here shear stress will be maximum at the neutral axis. This is the neutral axis. So shear stress will be maximum at neutral axis. Now there is a relation between maximum shear stress and average shear stress, and you need to remember that. It will be helpful in theory questions as well as in numericals. Numericals, whenever you are solving, then also you will need this relation. So tau maximum for rectangular section is 3/2 times of tau average, means 1.5 times of tau average. This is for rectangular section. Then for circular section, again it will look same, lagbhag, almost it will be same, but in this case the relation between tau max and tau average will be different, okay? So here also the variation will be parabolic. Here also tau maximum will be at the neutral axis, and here the relation will be tau maximum will be 4/3 times of tau average. You need to memorize all these relations, okay? आपको ये relations जो है याद रखने हैं. You need to memorize these relations. Yes, beta, this will be enough. Now, triangular section. So for triangular section, neutral axis will be h/3 from the bottom. Now here there will be a small change. Here tau will not be maximum at the neutral axis. Here tau will be maximum again at the center. यहाँ पे tau जो है वो neutral axis पे maximum नहीं होगा. Tau will be maximum at the center. At neutral axis, tau is slightly less, okay, and tau is maximum at the center. Now here you have two relations. आपको यहाँ दो relation याद रखने पड़ेंगे. Tau maximum will be 3/2 times of tau average, and neutral axis पे it will be 4/3 times of tau average. But it is easy to remember. How? One relation is of rectangle, one relation is of circle. तो एक rectangle का relation रख दो, एक circle का relation रख दो, बस. So that is the trick to remember this. So this is for triangular section. Next one is a diamond section. अब diamond section क्या है? Diamond section is nothing but a square which is rotated by 45 degree, okay? Let's say total height is h. So this will be h/2. This will be h/2. Now here the variation of shear stress is a little different. यहाँ थोड़ा सा tricky होता है. The shear stress variation will be something like this. इट विल बी लाइक अ बो, ठीक है, ऐसे बो के शेप का बनता है. दिस इज टाउ एट न्यूट्रल एक्सिस, बट इट विल नॉट बी टाउ मैक्सिमम. टाउ मैक्सिमम विल बी डिफरेंट. ओके, नाउ this will be 3h by 8, this will be h by 8, this will be h by 8, this will be 3h by 8. So this is the variation of shear stress in diamond section. Now here tau maximum is 9 by 8 times of tau average, and neutral axis पे it is equal to tau average. So this is the shear stress in case of diamond section. Now diamond sections are not that important for mechanical engineering students, but it is important for civil engineering students. But who knows, maybe you will get a question from this. So I am telling you this. If you can remember this, then better remember this. ठीक है, अगर याद कर सकते हो तो ये याद कर लेना, otherwise it is not that important for us. ठीक है, yes, अरे हाँ मेरे भाई, it is important, it is enough. Okay, चलो, next one is I section. Now I section के लिए you don't have a relation between tau max and tau average, but you need to see the variation of tau max, the variation of shear stress. Okay, तो यहां पे shear stress will vary something like this. You will see a sudden jump in shear stress at the junction of web and flange. जहां web और flange connect होते हैं वहां पे आप देखोगे there is a sudden jump of shear stress, the sudden change in shear stress. Why? Because there is a sudden change in width, है ना, width जो है वो suddenly change होता है, and if the width is suddenly changing then the shear stress will also be suddenly changing. ठीक है, तो यहां पे जो shear stress होता है that is the shear stress in the flange, and here there is shear stress in the web. तो बेटा this is the flange and this is the web, है ना, ये flange है और ये web है. तो web की width कम है तो shear stress ज्यादा, flange की width ज्यादा तो shear stress कम. Okay, so बेटा this is the shear stress of web and flange at this junction. Okay, now let's say this is the width of flange and this is the width of web. So there is a relation between these two shear stresses and these two widths. क्या relation है बेटा? Tau is inversely proportional to B. So here tau of web by tau of flange is equal to B of flange by B of web. This is the relation between tau of web and flange at this junction. जो junction है जहां web और flange एक दूसरे से मिल रहे हैं. Hello विशाल. At that junction, this is the relation between the two shear stresses. Okay, so this is for I section. अब T section के लिए भी you will get a similar variation, but here the diagram will not be symmetric because the cross section is not symmetric. So this is the variation of shear stress in T section. Okay, so beta these are the diagrams you need to keep in mind. ये diagrams और ये tau max और tau average का relation आपको ध्यान में रखना है. The questions will be based on this only. Okay, now shear flow. What is shear flow? Shear flow is the shear force per unit length and its equation is very similar to tau SA y bar divided by I. तो बेटा यहाँ पे you will notice that there is no B, width नहीं है, otherwise the relation is same. Okay, and its unit is Newton per meter या न्यूटन पर mm. Okay, not Newton per mm square. It is not stress, it is shear force. Okay, now in case of I section, how the shear force will look? तो shear force जो है, shear flow जो है वो कुछ ऐसा होता है. Let's say I am applying a shear force like this. Okay, तो shear flow looks something like this. This is the flow of shear. Continuous flow होना चाहिए ऐसा, continuous flow. Okay, if you are starting from these ends, तो ऐसा continuous flow बनना चाहिए. Okay, now the concept of shear center, very important because this is newly added in GATE 2021 syllabus. So what is the concept of shear center? And let me tell you that it is written in your syllabus that you only have shear center concept. So you don't have numericals of shear center. Shear center के depth में नहीं घुसना है. You only need to know the concept of shear center. So understand the concept of shear center. Okay. In case of I section, you will notice that if you take moment about this point, centroid, then the moment of all these forces will be balanced, right? But let's say you have a channel section. मान लो आपके पास एक channel section है. Let's say you have a channel section. Okay. And let's say this is the centroid. Now usually what do? We apply the force on the centroid. ठीक है. अब अगर मैं centroid पे force लगाऊं, then what will happen? See, shear flow in this case will be something like this. Okay. Due to the applied force, the shear flow will be something like this. Now, if you take moment about this centroid, then understand what is going to happen. Here, it is a symmetric section. Centroid ke about the cross section is symmetric. So, if I take moment about centroid, then the moment due to all these forces becomes 0 because it's a symmetric section. But this is an unsymmetric section. So, if I take moment about centroid, then it will not become 0. Why? Moment of this force will become 0, but moment of this shear flow will not become 0. So, due to this, what happens? This is the applied shear. ये applied shear है. I am applying a force like this. This is applied shear. Resisting shear will be opposite, right? So, that resisting shear will apply opposite moment and it will try to rotate this C section like this. It will try to twist this C section. This C section will be twisted. So do you understand what is happening? If I am applying the force on centroid, then this C section is getting twisted. So I can't apply the force on the centroid. I have to apply the force somewhere else. I have to apply the force at a point so that the net moment will become 0. That point where you apply the force to keep the net moment 0 is known as shear center. So shear center क्या है? Shear center is a point at which if I am applying the force, the net moment will become 0 and there will be no twisting. If my force is acting somewhere else, then there will be a net moment which will create twisting. So you can see in these two diagrams, here I am applying the force on centroid, so it is getting twisted. Now you must be thinking कि shear flow is applying anti-clockwise moment, how it is getting twisted clockwise. So beta again, repeat my words. This is applied shear. Resisting shear will be opposite and it will twist due to the resisting shear. जो resist कर रहा है उसकी वजह से twist होगा. So it will twist opposite. Okay. So beta you can see in this diagram it is getting twisted. But if I apply a force at this point, then it will not twist. So what is this point? ये पॉइंट कौन सा पॉइंट है? व्हाट इज दिस पॉइंट? दिस पॉइंट इज द शियर सेंटर. तो बेटा मैं शियर सेंटर को O से डिनोट करूंगा और सेंट्रॉइड को C से डिनोट करूंगा. ओके, आई विल डिनोट माय सेंट्रॉइड विथ C and I will denote my shear center with O. Now you only need to know this concept. आपको सिर्फ ये concept पता होना चाहिए कि shear center exactly होता क्या है. And then you need to know the location of shear center for some sections. कुछ section के location आपको पता होने चाहिए. Okay. Now understand. If there are sections with double axis of symmetry. Double axis of symmetry मतलब this particular section is symmetric about y-axis. It is also symmetric about x-axis. This one is also symmetric about y-axis. It is also symmetric about x-axis. Okay. So they have two axes of symmetry. So in this case, the centroid and shear center will be at the same point. ठीक है, centroid और shear center एक ही point पे होंगे at the intersection of these two axes. Okay, so if I apply a force passing through this point, अगर मैं ऐसा एक force लगाता हूं, then there will be no twisting like this. See here, if I am applying a force, there will be no twisting. Why? Equal and opposite moments, symmetric section, no twisting. Okay, so this is the shear center, the axis, the intersection of x and y axis. Okay, but if it has one axis of symmetry, अगर ये एक ही single axis of symmetry है इसकी, then the shear center will not be at the centroid. Shear center centroid पे नहीं रहेगा, but shear center centroid पे नहीं रहेगा, but it will be on this axis of symmetry. Shear center centroid पे नहीं रहेगा, लेकिन axis of symmetry पे रहेगा. Okay, understand? Here, centroid will be somewhere here. Okay, centroid will be somewhere here. एक सेकेंड यार, ये गलत कर दिया. This is not the axis of symmetry. This is the axis of symmetry. So centroid is somewhere here, but shear center will not be at the centroid. But shear center will lie on the axis of symmetry. तो यहाँ पे, यहाँ कहीं पे आता है shear center. Okay, this will be the shear center. So if I apply a force here passing through the shear center, again no twisting. तो यहां पे सेंट्रॉइड पे नहीं आएगा, but it will be lying on the axis of symmetry only. Okay, सेंट्रॉइड पे नहीं होगा, but it will be lying on the axis of symmetry. Okay, यहां पे भी सेंट्रॉइड will be here and shear center will be somewhere here. Okay, so if I apply a force here, then there will be no twisting. Okay, the moment about C will become 0. Okay, the moment about C will become 0. Next, this one. अब यहां पे भी this is the axis of symmetry. So shear center will not be on the centroid. Centroid will be somewhere here. So shear center will not be on the centroid, but it will be on the axis of symmetry. So if you are applying a force on the axis of symmetry, then the net moment will become 0. Now when you are equating the net moment, understand, moment of the force will be anti-clockwise. Don't look at this moment anti-clockwise. This moment you have to take clockwise, because you have to take the moment of resistive shear force. जब आप इसका मोमेंट लोगे तो उल्टा लेना, क्योंकि आपको रेजिस्टिंग shear force का मोमेंट लेना है, रेजिस्टिंग shear force का मोमेंट लेना है, ठीक है. सो बेटा दिस इज the shear center. Okay, O is the shear center, C is the centroid. Okay, so I hope this is clear to everyone. So you only need to know this. आपको बस इतना देखना है कि where do we get the shear center for different sections. अलग अलग sections में shear center आपको कहाँ कहाँ मिल रहा है, बस आपको इतना पता होना चाहिए. And you need to know the concept of shear center. Exactly what is shear center, that's it. You don't have to get into detail, you don't have to know how to find this distance and all. Okay, so beta, if someone is telling you the derivation of finding this distance, formula of finding this distance, beta neglect it, because you will never need it. Exam में उसके ऊपर कभी question नहीं आएगा. Okay, so this is all in shear stresses in beams. Let's move on to the next chapter, deflection of beams. Again our favorite chapter, one of our favorite chapter, deflection of beams. ये भी बहुत मजेदार chapter होता है, right? ये भी बहुत मजेदार chapter होता है, deflection of beams. अब डिफ्लेक्शन ऑफ बीम्स वैसे तो बहुत बड़ा चैप्टर है. ओके, डिफ्लेक्शन ऑफ बीम्स इज अ वेरी बिग चैप्टर. यू हैव सो मेनी मेथड्स, you have so many equations, but beta you don't have to worry, because from mechanical point of view deflection of beams is not that hard. मैकेनिकल इंजीनियरिंग स्टूडेंट्स को डिफ्लेक्शन ऑफ बीम्स से काफी सिंपल क्वेश्चन आते हैं. इनफैक्ट यू विल सी दैट फ्रॉम मैकेनिकल इंजीनियरिंग एग्जाम्स यू विल गेट वेरी सिंपल क्वेश्चंस. मैकेनिकल इंजीनियरिंग के एग्जाम्स में, गेट में, ईएस में, for mechanical engineering students there are very simple questions from deflection of beams, so don't worry too much about deflection of beams. Okay, if you look at the questions from civil then you will fear, because there are some very good questions, but from mechanical you will get very simple, very formula based questions. Okay, so beta all you need to do is just memorize the formula. If you are a mechanical engineer, then for gate from deflection of beams just memorize the formula, that's it. Okay, so what is slope and deflection? Let's say we are applying a force like this. Okay, so the beam bends. Under the force the beam bends like this. Okay, now this curve that we get after bending, bending के बाद ये जो curve मिलता है, this is known as elastic curve. Okay, whatever curve we get after bending, okay, final shape is known as elastic curve. Now let's say I am drawing a tangent at point A. मान लो मैंने A point पे elastic curve पे ऐसा tangent खींचा. Then this angle that this tangent is making is known as slope at A. I can denote it by dy by dx, or I can denote it by theta. And let's say this point is C. This vertical deviation is known as deflection. So this is slope, this is deflection. Now in different beams under different loading conditions, we need to find maximum slope and maximum deflection. And the calculation of maximum deflection, for calculation of maximum slope and deflection, we have various methods, out of which I have explained you 3 different methods. Double integration and Macaulay's are 2 different methods, but their concept is similar to one single method if I count them: moment area and strain energy. So I have explained these methods in detail. If you want to understand each and every method, then you can just watch my full course of strength of materials. Okay, but you don't have to do that, because beta 99% times you will get very simple questions, direct formula based questions, so you don't need to worry about these methods. So I will just quickly revise these methods and then I will get into the formula, because ultimately you have to remember the formula. आपको formula रटना है. ये methods जो हैं आपको पता होने चाहिए. You need to know the basics of these methods, but you don't have to get into detail कि एकदम तबाही type के questions बना रहे हो. No, you don't have to practice very difficult questions. If you are a mechanical engineer, practice very simple questions. Okay, so beta double integration method में what is the basis of this method? d square y by dx square is equal to m by ei. This is the basis of double integration method. Okay, ये double integration method का basis है. If you integrate this once, then you get this dy by dx equals to integration m by ei plus c1, constant of integration, and if you integrate it twice, then you get y equals to m by ei plus c1x plus c2. What is this? Dy by dx. This dy by dx is the equation of slope. And what is this y? This y is the equation of deflection. So in double integration method, we find the equation of bending moment in terms of x. We put it here. When we integrate it once, we get the equation of slope. When we integrate it twice, we get the equation of deflection. But when we integrate it, we get these constants of integration c1 and c2. And how to find the c1 and c2? By putting the boundary conditions. c1 और c2 हमको कैसे मिलता है? बाउंड्री कंडीशन लगा के मिलता है. अब बाउंड्री कंडीशंस क्या होती हैं बेटा? बाउंड्री कंडीशंस हमको क्या मिलती हैं? इन केस ऑफ लेट्स से वी हैव अ बाउंड्री कंडीशन कहां से मिलती है? So let's say you have a roller support. मान लो आपके पास या तो कोई रोलर सपोर्ट है या तो हिंज सपोर्ट है. Okay, you either have a hinge support or a roller support. Okay, so in this case, if you look at the deflection of beam, then the beam will not be able to deflect at this point, but it will be able to rotate about this point because it is hinged or roller supported. तो यहां पे deflection 0 होगा, but there will be some rotation. So if this point is A, then here YA will be 0. Slope will not be 0, but YA will be 0. Okay, so this is what? This is the boundary condition for hinge or roller support. But if you say you have a fixed support, तो fixed support पे the beam cannot deflect and it can also not rotate. Fixed support कर दिया हो तो rotate भी नहीं कर सकता. So you will notice that the deflection will be like this. So if this is point A, then here theta will also be 0, y will also be 0. So this will be the boundary condition for fixed support. तो या hinge या roller है तो वहां पर y 0 होगा, fixed support है तो वहां theta और y दोनों 0 होंगे. So these will be the boundary conditions. So by using these boundary conditions, you can find out what will be the slope and deflection. Okay. Now, moment area method. So moment area method is based on two theorems. What is the first theorem? Let's say we have a simply supported beam subjected to a point load. Okay. If you draw the elastic curve will be something like this. And if you draw the bending moment diagram, अगर आप bending moment diagram draw करो, bending moment diagram will be something like this. इधर उधर नहीं होता है क्या? हाथ से ड्रॉ कर लेते हैं. So the bending moment diagram will be something like this. Okay. Now let's say we have 2 points A and B. So according to this first theorem, theta A minus theta B. Theta A means slope at A minus theta B means slope at B will be equal to area of the bending moment diagram between AB, means this area of bending moment diagram between AB divided by EI. Area of bending moment diagram between AB divided by EI. So this is a very useful theorem if you want to calculate the slope at any point. You need to just know the slope at some other point. किसी एक point का slope पता है तो दूसरे point का slope निकाल सकते हैं. तो किस point का slope पता रहता है? If it's a cantilever beam, then you know the slope at the fixed end will be 0, है ना? And if it is a simply supported beam, then the slope where the deflection will be maximum will be 0. So you know the point where slope is 0. So you will consider B point as that point, and then you can find the slope at point A. B point का slope मेरा 0 है तो theta A मिल जाएगा. So this is the first theorem. The second theorem is a little tricky. अब second theorem क्या बोलता है? Let's say this is the elastic curve. ठीक है, मान लो ये elastic curve है and this is the bending moment diagram. Okay, now this part is a little tricky, so understand it. Let's say I am drawing a tangent at some point. Okay, मान लो मैंने एक point पे tangent draw किया. Okay, let's say I am drawing tangent at point B and I am finding the distance of A from this tangent. Okay, vertical deviation of A from this tangent. Let me call this TAB. Deviation of A, vertical deviation of A from tangent at B. This is called TAB. Vertical deviation of A from tangent at B. This is called TAB. So according to second theorem, TAB will be equal to first moment of area between AB. First moment of area, okay, not only area, first moment of area. अब फर्स्ट मोमेंट कैसे निकालेंगे बेटा? लेट्स से दिस इज माय एरिया, तो इसका फर्स्ट मोमेंट मींस एरिया इनटू सेंट्रॉइड से डिस्टेंस. वेयर विल बी द सेंट्रॉइड? द सेंट्रॉइड इज लेट्स से समवेयर हियर. सो बेटा डिस्टेंस कहां से, मोमेंट कहां पे ले रहे हैं? सो द मोमेंट आई एम टेकिंग एट पॉइंट ए. जिसका डेविएशन निकाल रहे हो उसका मोमेंट. आई एम फाइंडिंग द डेविएशन ऑफ ए, सो आई विल टेक द मोमेंट एट ए. Okay, so beta first moment of area of this divided by EI. This is the second theorem. Okay, so beta using these two theorems we can find slope and deflection, but you will not need it. Good afternoon Shubham. You will not need it because ultimately we have to use the direct formula. Okay, so you need to know the basics, but आपको इतना ज्यादा घुस के इस पे PhD करने की जरूरत नहीं है. Okay, next is strain energy method. So in order to use strain energy method we need to first find the strain energy. So how to find the strain energy? So let's say we have a cantilever beam. Let's say this is a section. At this section the bending moment is, let's say, minus Wx in terms of x. So the equation of strain energy is given by this integration m square dx by 2ei from 0 to L. Just put the value of m, just put the equation of m in terms of x, integrate, and you are going to find the equation of u. आपको u की equation मिल जाएगी. ठीक है मेरे भाई अक्षय, this is a quick revision. So if you want to get into the details of SOM, please go and see my complete strength of material classes. यार बार बार एक ही चीज काहे के लिए पूछ रहे हो भाई? यू आर नॉट इवन सीइंग द लेक्चर फ्रॉम द फर्स्ट. ये वाला लेक्चर भी आप शुरू से नहीं देख रहे हो, अदरवाइज आपको अभी तक पता चल जाता, बिकॉज आई हैव टोल्ड 2-3 टाइम्स. ओके, सो बेटा अगर ये लेक्चर भी पूरा नहीं देखोगे मतलब आपने आज तक सॉम नहीं पढ़ा, ये लेक्चर भी शुरू से नहीं देख रहे हो, बीच से घुस के देख रहे हो, उसके बाद भी यू वांट टू से दैट आफ्टर कंप्लीटिंग दिस यू विल बी एबल टू सॉल्व प्रॉब्लम्स. मतलब क्या जादूगर हो अगर, तो फिर तो कर लोगे, अदरवाइज तो बेटा नहीं कर पाओगे ना. मतलब ये लेक्चर भी शुरू से नहीं देखोगे, पूरा लेक्चर आपने देखा नहीं, ये लेक्चर भी यहाँ बीच से घुस के आप देखोगे आखिरी के 1-2 घंटा, तो कहां से कुछ समझ में आएगा. ओके, सो बेटा दिस इज इक्वेशन ऑफ स्ट्रेन एनर्जी for bending. Okay, so beta you need to find the equation of m, you need to put it here and then you will get the value of u. Now let's say you have a problem like this where there are two different loads, one at A, one at B. Then what you will do? Then you will consider two sections. Okay, you will find equation of bending moment for AB and BC separately. आपको AB की equation मिल जाएगी, BC की मिल जाएगी. Then u will be equals to u of AB plus u of BC. आप AB के लिए अलग निकाल लो, BC के लिए अलग निकाल लो, दोनों को ऐड कर दो, so you will get the equation of u, right? So this is how you find the strain energy. Now once you find the strain energy, मेरे भाई अगर एक बार आपने सॉल्व कर लिया है, then this revision course will be very useful. Okay, if you have completed strength of material, then to no issue beta, then you can watch this from the very beginning. But from the very beginning it will be a very good revision class. Okay, if you are revising your concepts, अगर आपको concepts, आपको सारे concepts पता हैं, बस revise करना है, then it will be a very good class. Okay, yes, thank you so much Shubham, thank you so much Akshay. Just revise this. This is a very good conceptual revision and then you solve the PYQs. That's all you need to do. Okay, so beta this is how you find strain energy. Now once you get strain energy, then you can use Castigliano's theorem. अब Castigliano's theorem क्या बोलता है? Understand, according to Castigliano's theorem, let's say we have a body like this, okay, which is subjected to different loads at different points. Let's say it is subjected to PA, it is subjected to PB, it is subjected to a couple MC, and these are different points. Let's say this is point A, point B, point C. Now let's say U is the total strain energy. Total strain energy बोलने का मतलब it is the strain energy due to PA, PB and MC. सबकी वजह से मैंने स्ट्रेन एनर्जी निकाल लिया. इट इज द स्ट्रेन एनर्जी ड्यू टू पीए, पीबी, एमसी. ओके, सबकी वजह से स्ट्रेन एनर्जी निकाल लिया. नाउ अकॉर्डिंग टू कास्टिग्लियानोस थ्योरम, इफ यू फाइंड डेल्टा यू बाय डेल्टा पीए means partial derivative of u with respect to PA. If you find partial derivative of u with respect to PA, then you will get deflection of A in the direction of PA. PA is horizontal, so you will get horizontal deflection. If you find partial derivative of u with respect to PB, then you will get deflection of B in the direction of PB. Now PB is vertical, so you are going to get vertical deflection. So if you differentiate with respect to force, you are going to get deflection in the direction of force. But if you differentiate with respect to couple, moment के respect में differentiate करेंगे, then you are going to get a slope at that point. So this is what? This is Castigliano's theorem, which we can use in order to find the slope and deflection at any point. If there is a force, differentiate with respect to force and you are going to get deflection. If there is a moment, differentiate with respect to moment and you are going to get the couple. Okay, sorry, you are going to get the slope. Okay, so beta, this is how we use Castigliano's theorem to find slope and deflection. Okay, now These are the three methods of finding slope and deflection, but you will not need it because ultimately you need to remember the formula. Which formula you need to remember? So I have made a list of formula that you need to remember. So let's say you have a cantilever beam subjected to point load at the free end. So the theta maximum is WL square by 2 EI, Y maximum is WL cube by 3 EI. Theta and Y both will be maximum at the free end only. Okay. Cantilever beam subjected to UDL, theta maximum WL cube by 6 EI, Y maximum WL to the power 4 by 8 EI. Cantilever beam subjected to UVL, theta maximum WL cube by 24 EI, Y maximum WL to the power 4 by 30 EI. Cantilever beam subjected to couple, theta maximum ML by EI, Y maximum ML square by 2 EI. Simply supported beam subjected to point load, theta maximum WL square by 16 EI, Y maximum WL cube by 48 EI. Simply supported beam subjected to UDL, theta maximum WL cube by 24 EI, Y maximum 5 WL to the power 4 by 384 EI. So you need to remember theta maximum and Y maximum in these 6 loading conditions only. बस ये 6 loading condition का theta maximum and Y maximum आप रट लो, इतना बहुत है. If you are a mechanical engineering student, then for gate you only need this much. इसके अलावा कुछ याद करने की जरूरत नहीं पड़ने वाली है. That is a promise. Good afternoon, Rohini. Welcome everyone. Welcome. Yes, beta, this video will not be deleted. It will remain there. Okay, we never delete any of our videos. Whenever we take any lecture, it will remain there. So beta, it will always be there for you. You can always watch this. Okay, the recorded lecture you can always watch. Okay. So beta, those of you who have joined us lately, please hit the like button and don't forget to share. Okay. So beta, these are the formulas that you need to remember. Now just take the printout of this page and just stick it on your wall, and every once in a while you just look at it. You will remember it. ठीक है, ये याद हो जाता है, बहुत आसान है. इसको ऐसे टेबल के फॉर्म में याद करो, बहुत आसानी से याद हो जाता है. Okay. Now once you remember this, then there are some other theorems, some other methods, some other concepts that you need to know in order to use them. Okay? Because in exam you might get direct this type of question or something different than this. So in that case you have to use some other type of logic apart from the formula. Formula also you need to apply, but apart from that you have to apply some other logic. Okay, so what other logic, what other theorem, that we will see. So first of all, principle of superposition. What is principle of superposition? Let's say you have a cantilever beam subjected to point load W and couple M. Now I know the formula for W, I know the formula for M, but I don't know the formula for W plus M. So what I am going to do? I am going to separate them. In one case, I will consider only W. In one case, I will consider only M, and I will assume that total deflection will be the sum of this deflection plus this deflection. Okay. So beta, slope and deflection. Let's say I am calculating theta A. This is A, theta A. So it will be, in this condition, it will be WL square by 2 EI. In this condition, it is ML by EI. So I am just adding both of them. I will get total theta A, YA, WL cube by 3 EI, ML square by 2 EI. So I am just adding both of them and I will get the total YA. Okay. तो हम क्या कर रहे हैं बेटा? हम दोनों लोड्स को अलग अलग कंसिडर कर रहे हैं. Now understand, here in both cases the beam is deflected downwards, so they are added. If I am applying M opposite, then due to W it will go downward, due to M it will go upward. So if I am considering one positive, other one will become negative. Which one will be positive, which one will be negative, that doesn't matter, but one will be positive, one will be negative. एक positive होगा, एक negative होगा. Yes. ठीक है, चलो. So this is principle of superposition. Okay. Now another very important concept. ठीक है, ये बहुत important concept है बेटा, क्योंकि इसके ऊपर काफी questions आ सकते हैं. Okay. So let's say you have a beam. This is point A. This is point B. This is point C. The load is acting at B. I want to calculate the slope and deflection at A. इस केस में क्या करें? What to do in this case? So understand what to do in this case. Okay. First of all, you will consider the beam from B to C. Okay. पहले तो आप क्या करो, B से C तक की बीम कंसिडर करो. Okay. First you consider the beam from B to C. Forget about AB. Okay. So from here you will find theta B. इसको मैं L ले लेता हूं मेरे भाई. ठीक है. So from here you will find theta B. You will find YB. Okay. So you got theta B, you got YB. Now from these two I will calculate theta A and YA. How? If you notice, bending moment from A to B is 0. There is no bending from A to B. So from A to B, elastic curve will remain straight. A से लेके B तक elastic curve जो रहेगा वो straight रहेगा, because the beam will not bend. तो इस केस में in order to find theta, what you are going to do? A से B तक if it's a straight line, then theta will be same. So theta A will be equals to theta B. And what will be YA? YA will be equals to YB plus theta B into AB. So these are the formulas of finding theta and Y. ठीक है? So beta, if you remember this, then you can easily solve these types of problem. Now instead of point load, if I apply UDL from B to C, concept will remain same. If I apply a couple at B, concept will remain same. If I apply UVL from B to C, concept will remain same. First you forget AB, you just consider BC. Okay, you just consider BC and you calculate the slope and deflection at point B. Then you consider these formulas in order to find slope and deflection at A. Okay. Next, let's say this time the load is acting at the free end only. मान लो लोड फ्री एंड पे ही लग रहा है, बट आई वॉन्ट स्लोप एंड डिफ्लेक्शन एट पॉइंट बी. मान लो मुझे बी पे स्लोप और डिफ्लेक्शन निकालना है. लेट्स से बी पॉइंट इज द सेंटर पॉइंट. ठीक है, मान लो मुझे स्लोप एंड डिफ्लेक्शन बी पॉइंट का निकालना है. बी पॉइंट इज लेट्स से द सेंटर पॉइंट. So here the load was acting here B and you needed slope and deflection here. This time load is acting here, you need slope and deflection at B. उल्टा हो रहा है. So what you can do in this case, you forget about AB. आप A से B तक की बीम को भूल जाओ. What you do is you just transfer the force from A to B. So if you transfer the force from A to B, you will get a force W and you will get a moment WL by 2. Now once you get this, then you can find theta B and YB. अब आपको theta B निकालना है, आपको YB निकालना है. So just apply the formula and you will easily get theta B and YB. There will be theta B and YB due to W. There will be theta B and YB due to WL by 2. So you will easily get it. So this is how you can solve this type of problem. Okay. So I hope this is clear to everyone. Now next is Maxwell's reciprocal theorem. So understand Maxwell's reciprocal theorem, beta. Maxwell's reciprocal theorem can also be used in some cases. Okay, there can be direct questions from Maxwell's reciprocal theorem. Okay, so let's say we have a point A and a point B on the beam. मान लो हमारे पास दो पॉइंट्स हैं A और B. In one question, I am applying load at A and I am calculating deflection at B. And in another question, on the same beam, I am applying load at B and I am calculating deflection at A. Do you understand? The beam is same. Beam वही है. एक केस में लोड ए पे लग रहा है, डिफ्लेक्शन बी पे निकाल रहे हैं. एक केस पे लोड बी पे लग रहा है, डिफ्लेक्शन ए पे निकाल रहे हैं. सो बेटा देयर आर डायरेक्ट कनेक्शंस बिटवीन दीज टू. WA into YA will be equals to WB into YB. What is the connection? WA into YA will be equals to WB into YB. Okay. So there might be direct questions based on this. इसके ऊपर direct question आ सकता है. Although you will never need it in other problems. बाकी के किसी problem में इसको लगाने की जरूरत नहीं पड़ेगी. बट डायरेक्ट क्वेश्चन आ सकता है ना. ए पे लोड दे दिया, बी का डिफ्लेक्शन दे दिया, फिर बी पे लोड दे के बोलेगा ए का डिफ्लेक्शन निकालो. ओके, यस यस, वेरी गुड वेरी गुड वेरी गुड. सो बेटा दिस इज अनदर थ्योरम दैट यू नीड टू स्टडी. ओके, तो बेटा ये कुछ केसेस हैं दैट यू नीड टू अंडरस्टैंड in order to be able to use the formula. Next is a very important topic because from this topic you have questions in GATE 2020. GATE 2020 में ही एक क्वेश्चन आया था from statically indeterminate beam. From statically indeterminate beam. मेरे भाई वेदांत, अगर आपको नहीं समझ में आ रहा है तो इसका मतलब आपने स्ट्रेंथ ऑफ मटेरियल आज से पहले नहीं पढ़ी है. So go and watch the complete strength of material lecture. Then you will understand. Okay, so beta, let's say we have statically indeterminate beam. What do we mean by statically indeterminate beam? Where the reactions are greater than equilibrium equations. So you can't find the reactions by applying equilibrium equation. Okay, in determinate beams we can find the reactions by equilibrium equations, but in indeterminate beams we can't find reactions by equilibrium equations. In order to find reactions we need compatibility equation, right? Compatibility equation means equation of deformation, constraint of deformation, right? So let's say there are different types of statically indeterminate beams. We are going to see each case. So let's say we have a propped cantilever beam subjected to UDL. Propped cantilever मतलब clear है? There is a cantilever with additional roller support. अब मैं करने क्या वाला हूं? Let's say I want to find reaction at A. Okay, let's say the question is, question में बोल रहा है find reaction at A. ठीक है, अब A पे reaction निकालना है. क्या करेंगे? First of all we will remove the support at A. सबसे पहला काम तो मैं क्या करूंगा, मैं A का support हटा दूंगा. So if I remove the support at A, then I will get some reaction at A. If I remove the support at A, I will get some reaction at A. Let me call it RA. Okay. Now we need the value of RA. So we need compatibility equation. अब compatibility equation क्या होगा? What will be the compatibility equation? What will be the compatibility equation? So beta, in order to use compatibility equation, we need to understand what is the constraint to deformation. ठीक है? So here point A is supported by roller, means I have constrained the deformation of point A completely. A cannot be deformed, so YA will be equal to 0. This will be your compatibility equation. Now YA will be due to the W load and due to this RA. तो बेटा क्या हो जाएगा? W की वजह से it will be WL to the power 4 बाय 8EI, R की वजह से इट विल बी RAL क्यूब बाय 3EI. तो फ्रॉम हियर आई विल गेट द वैल्यू ऑफ RA. अब यहां एक चीज ध्यान देना, आई एम कंसिडरिंग दिस टू बी पॉजिटिव, दिस टू बी नेगेटिव. व्हाई? बिकॉज ड्यू टू W it will be downward and due to RA deflection will be upward. So either consider this to be positive and this to be negative, or this negative, this positive. You can do anything. आप या तो इसको पॉजिटिव ले लो या इसको नेगेटिव, या इसको नेगेटिव इसको पॉजिटिव, एक ही चीज है. ओके, सो यू गेट वैल्यू ऑफ RA. So do you understand how to solve statically indeterminate beam? Just apply compatibility equation. What is compatibility equation? It is the equation of constraint of deformation. The deformation is constrained in some way, so we are just writing the equation of that. Okay. Second case is this. We have a cantilever beam which is supported by a spring of stiffness K. This time also I need to find force in spring. मेरे को क्या निकालना है? Let's say they are asking us to find force in spring. Okay. Now what I am going to do? Same concept. पूरा concept same. I will remove this spring. I will remove this spring. Okay. Last time there was a roller support. I removed the roller support. This time there is a spring. I will remove the spring. Okay. So this is the force W. Now if I remove the spring, then I will get a force due to spring. This will be the spring force, right? Let me call it R. This is the force in spring, R. Now beta, this time what will be the compatibility equation? इस बार compatibility equation क्या होगी? What is the constraint? YA is 0? No, this time YA will not be 0. Why? Because there is not a rigid support, there is a flexible support, spring. So if I apply force at A, it will not free to be deformed. ये free नहीं रहेगा deform करने के लिए, but there will be deformation, but that deformation will be constrained. What will be the constraint? Now it can only deform as much as the spring will be compressed. ये उतना ही डिफॉर्म हो सकता है जितना स्प्रिंग कंप्रेस हो सकता है. मींस y of A will be equals to y of spring. This is the constraint. जितना स्प्रिंग कंप्रेस होगा ये उतना ही डिफॉर्म होगा, उससे ज्यादा नहीं हो सकता. Now y of A will be equal to how much? Due to W it will be WL cube by 3EI. Due to R it will be RL cube by 3EI, and due to R, spring deflection will be R by K, where K is the stiffness of spring. This will be your compatibility equation. By solving this, you are going to get the value of R. अब यहाँ पे भी एक चीज समझो बेटा, यहाँ पे भी you can see that due to W it is downward, due to this R it is upward, spring deflection is downward. So I have considered downward deflections to be positive, so upward deflection automatically became negative. So do you understand how to put the sign, where to take positive, where to take negative? Negative positive कैसे लेना है ये clear हो गया. Negative positive कैसे लेना है? If I am considering downward positive, upward negative, downward negative to upward positive. So whenever you are writing compatibility equation, in case of beams, just look at the direction of deflection. Which one is going down, which one is going up. That's it. Okay. Next case is this one. We have two cantilever beams which are supported by, which are connected by a roller. दोनों एक roller से connected है. Now in this case, what you do? Very simple. You have to disconnect both of them. आपको क्या करना है? कनेक्शन रिमूव कर देना है, दोनों का कनेक्शन रिमूव कर देना है. मींस you have to just remove this support. this roller. So beta understand, they are connected by roller, okay, they are connected by roller. So if I remove the roller, then which reaction am I going to get? इस roller की वजह से, let's say this is also W, तो इस roller की वजह से what will be the reaction? The reaction will be only in y direction. Let's say here that reaction is like this. So here it will be equal and opposite like this. Now you might be thinking, sir ऐसा क्यों? अरे बेटा, first of all logically you understand ना, this will apply downward force on this and this will apply upward force on this. ये इसके ऊपर downward लगाएगा, ये इसके ऊपर upward लगाएगा. Now let's say you can't apply the logic, then what you do? You assume anything na. Here you assume R downward, then here it will become upward. So you have to just take R equal and opposite. Okay. Now I need to find the value of R. मेरे को ये R निकालना है. Okay. I need to find this value of R. Okay. Calculating R is my objective. So how you can find the value of R? Understand. Here you need to apply the compatibility equation. What will be the compatibility equation here? If you see the deformation of these beams, अगर मैं इनके elastic curve बनाऊं, then it will be something like this. You can easily see that the slope at C is not necessarily equal, but the deflection will be equal. C पे स्लोप जरूरी नहीं है इक्वल होना, बट डिफ्लेक्शन विल बी इक्वल. तो बेटा आपकी कंपैटिबिलिटी इक्वेशन क्या हो जाएगी? YB विल बी इक्वल्स टू YC, बट थीटा बी मे और मे नॉट बी इक्वल टू 0. थीटा बी मे और मे नॉट बी इक्वल टू 0. ऐसा जरूरी नहीं है कि इक्वल होगा, ऐसा ये भी जरूरी नहीं है कि इक्वल नहीं होगा, बट उसकी तो जरूरत ही नहीं पड़ेगी. You have to apply compatibility equation and your compatibility equation will be this: YB equal to YC. After applying compatibility equation, you can easily find the value of R. So this is statically indeterminate beam case. Okay, so I have shown you different cases of statically indeterminate beam, right? Beam supported by roller, beam supported by spring, two beams connected by roller. So that's the end of deflection of beams. How many of you have revised the concept of deflection of beam? Deflection of beams के concept सारे तरोताजा हो गए कि नहीं? Yes or no? Yes or no? Yes. अरे हाँ ना बोल बेटा. Yes, the slope in one case will be positive and in one case it will be negative. Because in one case it is anti-clockwise, in one case it is clockwise. तो एक थीटा पॉजिटिव होगा, एक थीटा नेगेटिव होगा, बट उनका मैग्नीट्यूड इक्वल भी हो सकता है, डिफरेंट भी हो सकता है. यस 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 यस, सो मेनी यस. यस, वेरी गुड वेरी गुड वेरी गुड. आदित्य, राहुल, वेरी गुड. वेंकटेश, वरुण, नितिन, गोविंदा, शुभम, प्रभाकर, वेरी गुड. करण, वेरी गुड. धनंजय, मजा आ गया. वेरी गुड. अंकुर, यस यस यस, मजा आ गया. वेरी गुड. नावेद, आदित्य. अरे मेरे भाई, एक्सी के सिलेबस में कुछ भी एक्स्ट्रा नहीं है क्या? एक्सी का सिलेबस एक्सी के सिलेबस में कुछ भी एक्स्ट्रा नहीं है. जो भी आप यहां पढ़ रहे हो वही सब एक्सी के सिलेबस में भी है. ओके, वेरी गुड. कृष्णा, वेरी गुड. Now, how many chapters left? How many chapters left? MD का रिवीजन चल रहा है क्या? हाँ मेरे भाई, MD का रिवीजन will start from Monday 7:30 PM. MD रिवीजन will start from Monday 7:30 PM. Okay. चुपचाप पढ़ने की जरूरत नहीं है, चुपचाप पढ़ने की जरूरत नहीं है. See, XC syllabus and ME syllabus for strength of material is same. You don't need to do anything extra. Whatever you study in mechanical, it will be same for XC also. Okay. In fact, the questions, level of questions are also almost same. For strength of material, level of question are almost same. ठीक है. एफएम में एक्स्ट्रा होगा मेरे भाई, सॉम में नहीं है ना, एफएम में है तो जरूरी होगा सॉम में है। मैं बता रहा हूं, विश्वास नहीं है तो फिर खुद चेक कर लो। पहले पूछोगे फिर बताऊंगा तो विश्वास भी नहीं करना है, फिर लॉजिक ऐसे देना है कि अगर एफएम के लिए डिफरेंट है तो सॉम के लिए तो डिफरेंट होना ही चाहिए। दिस इज द लॉजिक, है कि नहीं? दिस इज द लॉजिक कि अगर एफएम के लिए डिफरेंट है मतलब सॉम के लिए तो डिफरेंट होना ही चाहिए, थर्मो के लिए भी होना ही चाहिए, इसके लिए भी होना ही चाहिए, उसके लिए भी होना ही चाहिए, राइट? ये आपका लॉजिक है। अरे मेरे भाई नहीं है, सॉम का सिलेबस एफएम के एक्सी के लिए, मैकेनिकल के लिए सेम ही है, ठीक है? यस, तो पूरा विश्वास है तो फिर बस मेरे भाई इतना पढ़ के चले जाओ। सॉम के पीवाईक्यूज अगर आप मैकेनिकल के बना लोगे तो एक्सी के भी बन जाएंगे। इफ यू आर एबल टू सॉल्व पीवाईक्यूज ऑफ सॉम फ्रॉम मैकेनिकल, you will be easily able to solve PYQs of SOM from XC. Okay, that is my guarantee. That is my guarantee. Yes, संपूर्ण विश्वास के साथ सब लोग मेरे साथ हैं? यस, मन में है विश्वास, पूरा है विश्वास। हाँ, एक्सी में एक दो चीजें कम हो सकती है, ज्यादा नहीं है मेरे भाई। ओके, बट आपको टेंशन लेने की जरूरत नहीं है। जस्ट कंप्लीट योर सिलेबस ऑफ एमई and your syllabus of XE will be automatically completed. No issue, no worries beta, no worries. Okay, chalo chalo, so beta only 3 chapters nahi 4 chapters left: complex stress, complex strain, pressure vessel and columns. Pressure vessel and columns are like this. Complex stress और complex strain में थोड़ा बहुत टाइम लगना है, otherwise pressure vessel and columns are like this. So maybe we might even be able to complete it before 5 PM. हो सकता है 5 बजे से पहले ही complete हो जाए. Okay, so shall we start? Shall we start? Shall we start complex stress? Yes, चलो 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 चलो। तो बेटा complex stress में you only need to remember the formulas, that's all. Formulas and Mohr circle. How to draw Mohr circle, that you need to know. Okay, तो complex stress है क्या बेटा? In the first chapter we have seen complex stress means that there are 9 stress components on 3 different planes, है कि नहीं? 9 stress components on 3 different planes, but you don't have to consider the 9 stress components. Why? Because in our syllabus we only deal with biaxial stress or plane stress. तो plane stress या biaxial stress में we consider that there are only stresses in a single plane. All the other stresses are zero. इस प्लेन में जितने stresses हैं उतने ही बचे हैं, बाकी सारे stresses को क्या हो गया? They became zero. So we can draw them in the form of a rectangle. हम उनको rectangle के फॉर्म में ड्रॉ कर सकते हैं, like this: sigma x, sigma y and tau xy. Okay, and if you want to draw them as matrix, matrix के फॉर्म में अगर आप ड्रॉ करना चाहते हो, then it will be a 2 by 2 matrix, sigma x, sigma y, tau xy, here also tau xy, tau yx and xy are equal. Okay, so beta we don't have to consider this one 3 by 3 matrix, we don't have to consider, we only have to consider this one. Okay, अब यहां पे मुद्दा क्या होता है? अंडरस्टैंड कॉम्प्लेक्स स्ट्रेस होता क्या है? ओके, कॉम्प्लेक्स स्ट्रेस इज व्हाट? नो मेरे भाई, एनर्जी कम नहीं होने देना है, एनर्जी कम नहीं होने देना है, एनर्जी पूरी बनी रहनी चाहिए। यस, तो मेरे भाई कॉम्प्लेक्स स्ट्रेस में करना क्या होता है? अंडरस्टैंड, सी, इफ देयर इज ओनली वन सिग्मा, इफ देयर इज ओनली वन टाउ, देन तो वी हैव नो इशू, बट इफ देयर आर सिग्मा एक्स, सिग्मा वाई, टाउ एक्स वाई, then what is your objective? Let's say you want to find sigma maximum and tau maximum. Okay, so in order to find sigma max and tau max, first you need to know how to find stress on oblique plane. Why? Because this sigma will not be maximum. See, these are the stresses on vertical and horizontal plane. ये stresses क्या है? Vertical plane और horizontal plane के. This is the vertical plane, दिस इज द हॉरिजॉन्टल प्लेन, जिसको मैं लाइन के फॉर्म में दिखा रहा हूं यहाँ पे। ओके, ये पूरा प्लेन जो है एक लाइन से मैं शो कर रहा हूं, ये पूरा प्लेन एक लाइन से मैं शो कर रहा हूं। ओके, सो दीज आर वर्टिकल एंड हॉरिजॉन्टल प्लेन स्ट्रेसेस। ओके, ऑन वर्टिकल प्लेन स्ट्रेसेस आर दिस मच, on horizontal plane stresses are this much. But it is not necessary that maximum stress will be on these two planes only. Maximum stress can be on any plane. So the first objective is to find the stress on oblique plane, and using that we calculate other things. Okay, so beta, stress on oblique planes, how to find it? Let's say this is our stress element. This is known as stress element. In order to show the stress at any point, we use this. किसी पॉइंट का स्ट्रेस दिखाने के लिए हम ऐसा डायग्राम बनाते हैं. ओके, सो लेट्स से we have sigma x, sigma y, tau xy. We have calculated their values, but I want the stress on this oblique plane. मेरे को इस plane का stress चाहिए. I want the stress on this plane. Okay, I want the stress on this plane. इस plane का stress चाहिए. Let's say this plane is at an angle theta. तो मुझे क्या चाहिए? मुझे इस plane का sigma और tau चाहिए. Okay. So how I can find sigma and tau on this plane? Let's say this is the plane. So इस plane पे there will be one sigma like this, and there will be one tau like this. Let me call it sigma theta and tau theta. So what is the equation to find sigma theta and tau theta? You need to directly remember. Okay, we have derived the equation. हम equation derive कर चुके हैं in full course, but here I will not tell you the derivation. I will just give you the direct formula. So sigma at theta angle is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. This is the equation of sigma theta, and tau theta is minus of sigma x minus sigma y by 2 sin 2 theta plus tau xy cos 2 theta. Just remember these equations. By putting the values of sigma x, sigma y and theta, you can find sigma and theta at any angle theta. अगर आपको ये दो इक्वेशन पता है तो आप किसी भी थीटा एंगल का सिग्मा और टाउ कैलकुलेट कर सकते हैं. बट whenever you use these equations, you need to remember the sign convention. Let me tell you a very important things. In different books, you will find little variation in these equations. In some books you will find there is no negative sign here, there is negative sign here. In some books you will find there is negative sign here. So you might be confused. In some books this is positive, this is negative. In some book this is positive, this is negative. What is happening? I am confused. So beta, don't get confused. Why this happens? Because in different books the sign convention is different. In some books they are measuring theta from vertical. In some books they are measuring theta from horizontal. So your equations will slightly vary. No issue. If you know the sign convention of your formula, what formula you use, if you know the sign convention of that formula, that's all you need to do. ठीक है? तो मेरे भाई, if you remember these two formula, if you memorize these two formula, then I will tell you the sign convention for using this. ठीक है? तो इनका sign convention क्या है? First of all, the sign convention of sigma. सिग्मा का साइन कन्वेंशन, तो सिग्मा का साइन कन्वेंशन तो यूनिवर्सल, इट्स अ यूनिवर्सल साइन कन्वेंशन. यूनिवर्सल साइन कन्वेंशन ऑल्दो कुछ होता नहीं है, बट स्टिल यूनिवर्सली इट इज एक्सेप्टेड दैट टेंसाइल स्ट्रेस इज अ पॉजिटिव स्ट्रेस एंड कंप्रेसिव स्ट्रेस इज अ नेगेटिव स्ट्रेस. ठीक है, यूनिवर्सली हम सब जानते हैं कि ऐसा ही होता है, राइट? नाउ साइन कन्वेंशन ऑफ टाउ. साइन कन्वेंशन ऑफ टाउ, ये क्या हो गया? तो साइन कन्वेंशन ऑफ टाउ क्या होगा? अंडरस्टैंड, टाउ ऑन डिफरेंट केसेस, either it will be like this या तो टाउ ऐसा लग रहा होगा किसी पॉइंट पे, ऑन एनी पॉइंट either the tau will be acting like this or it will be acting like this. Now this is considered as positive tau, this is considered as negative tau. I told you this in the shear strain case also, ठीक है, shear strain के केस का भी मैंने बताया था, shear strain में भी मैंने बताया था, this is positive tau, this is negative tau. Okay, now the most important thing, सबसे ज्यादा important sign convention is of theta, because most of the times people make mistake here only. Now first of all you need to understand that what equation I write, for that theta is measured from vertical. ठीक है, जो इक्वेशन मैंने लिखी है उसमें थीटा कहां से मेजर हुआ है, वर्टिकल से. बट बेटा देयर कैन बी टू केसेस, द थीटा कैन बी मेजर्ड लाइक दिस, द थीटा कैन बी मेजर्ड लाइक दिस. प्लेन ऐसा भी हो सकता है, ऐसा भी हो सकता है. दोनों में अंतर क्या है, व्हाट इज द डिफरेंस? हियर थीटा इज एंटी क्लॉकवाइज एंड हियर थीटा इज क्लॉकवाइज, राइट? एंटी क्लॉकवाइज डायरेक्शन में, क्लॉकवाइज डायरेक्शन में. सो बेटा दिस विल बी पॉजिटिव एंड दिस विल बी नेगेटिव. ओके, सो बेटा you need to know these sign conventions in order to use these two equations. If you want to use these two equations you need to use proper sign convention, otherwise क्वेश्चन में थीटा, ये वाला थीटा दिया हुआ है मान लो 60 डिग्री. अब क्या करते हैं हम लोग, what do we do, whatever angle they have given we assume that is theta. That is wrong beta, this is not theta, this is 90 minus theta. Our theta will be 30 degree. Okay, our theta will be 30 degree. Okay, so you need to know what is the sign convention of sigma, what is the sign convention of tau, and what is the sign convention of theta. Then only you will be able to solve the problem. Otherwise even if you are putting one thing wrong, एक भी चीज अगर आपने गलत की, entire solution might become wrong. Okay, so this is very crucial, know the sign convention. Okay, now Morse circle. अब Morse circle किस चिड़िया का नाम है, तो Morse circle is a circle drawn between sigma and tau axis. Morse circle is a circle drawn between sigma and tau axis. Okay, like this. On x-axis we take sigma, on y-axis we take tau. Okay, now where do we get the center of this? हमको सेंटर कहां मिलता है, where do we get the center? So the center of Morse circle is at sigma x plus sigma y by 2 and 0. This is the center coordinate. So beta you will see that center will always be on sigma axis. Center जो है वो हमेशा sigma axis पे lie करना चाहिए, because tau will be 0 at the center. Center पे tau 0 है, ठीक है. Now radius r. So what is the equation of radius r? The radius is given by this, root over sigma x minus sigma y by 2 whole square plus tau xy square. So you need to remember these two. आपको ये दोनों याद रखना है, coordinates of center and equation of radius. Okay, अब Morse circle draw कैसे करते हैं? How do we draw the Morse circle? Yes, 45 degree theta होगा तो फिर कोई दिक्कत ही नहीं है. Now how do you draw Morse circle? So you have two options. Either you use this method, you know the center and radius, so using these two you can draw the Morse circle, or what you can do is you can use this method. Let's say we have this stress element. sigma x, sigma y and tau xy, all are known, ठीक है, सब पता है अपने को. So what do you do is, what is the coordinates of vertical plane? Vertical plane के coordinates क्या होंगे? Sigma x and tau xy. Then horizontal plane coordinates will be sigma y and minus tau xy. Okay. Now this is your Morse circle. Okay. Now what happens is, let's say, now let me tell you that when I was teaching the complete course of SOM, I took positive tau here and now I am writing positive tau here. Don't get confused beta, it is not necessary. You can draw plus tau minus tau anywhere you want, उससे कोई फर्क नहीं पड़ेगा ज़्यादा, ठीक है. Now beta, what I need you to do is, you need to find vertical and horizontal points V and H. तो उनको ढूंढोगे तो कहाँ मिलेगा? ढूंढोगे तो सब कुछ मिल जाता है. So you will get vertical point somewhere here, horizontal point somewhere here, let's say. Okay. Now if you join these 2 points, you will get the diameter of the Morse circle. This will give you the diameter of Morse circle, and once you get the diameter, then तो you can easily draw the circle ना. एक बार diameter मिल गया, उसके बाद circle draw करने में कुछ खास दिक्कत तो होगी नहीं. Yes, now this is your Morse circle. अब यहां एक चीज ध्यान देना बेटा, here whatever angle theta you get between any two planes on Morse circle, it will become 2 theta. देख रहे हो, here vertical and horizontal planes are at 90 degree, but here they are at 180 degree. Okay, so if the angle between two planes in this case is theta, then in this case it will become automatically 2 theta. ठीक है. So बेटा, this is how you can draw the Morse circle. Okay, ऐसे आप Morse circle draw कर सकते हो. Okay, is this clear to everyone? Yes. चलो मेरे भाई, तो बेटा Morse circle draw करना भी सिखा दिया. Now after this there are some other concepts. The concept of principal planes. Now what are the principal planes? Principal planes are the planes at which tau is 0. Simple. ऐसे planes जिस पे tau क्या है? 0. और इनको ढूंढना बहुत जरूरी है. इनको ढूंढना क्यों जरूरी है? Because beta, these planes are the planes at which tau is 0, and on other planes you will get tau. बाकी हर plane पे tau मिलते हैं, but in planes पे tau 0 होता है. So it is very important to find these planes. Okay, it is very important to find these planes. Why? Because if these planes have only sigma, then the calculation becomes easier. Okay, using the stresses on these planes we can calculate other things. इन प्लेन के स्ट्रेसेस से हम बाकी चीजें निकाल सकते हैं, क्योंकि फिर वहां टाउ नहीं आएगा इक्वेशन में, फिर वहां टाउ नहीं आएगा. ओके, नाउ बेटा, हाउ टू फाइंड प्रिंसिपल प्लेन? सो लेट्स से वी हैव 2 प्रिंसिपल प्लेन्स. अपने पास 2 प्रिंसिपल प्लेन्स होते हैं. दिस इज द फर्स्ट प्रिंसिपल प्लेन and this is the second principal plane. Okay, so this is, let's say, angle theta p1. Okay, now principal planes will always be at 90 degree to each other. So theta p1 will be equal to what? Half of tan inverse of 2 tau xy upon sigma x minus sigma y. This is the equation of theta p1. And let's say I want the angle of second principal plane. मेरे को second का angle निकालना है. तो second का angle निकालने के लिए you don't have to worry too much. If you have the angle of first principal plane, all you need to do is theta p1 plus 90 degree and you get the angle of second principal plane. Simple, right? theta P1 plus 90 degree will become equal to theta P2. Okay. Principal stresses. Now what do we mean by principal stresses? So principal stresses are normal stresses. Normal stresses on principal planes. These are what? Normal stresses on principal planes. और इनकी वैल्यू हम कैसे निकालते हैं मेरे भाई? Sigma 1 2 will be equal to sigma x plus sigma y by 2 plus minus root over sigma x minus sigma y by 2 whole square plus tau xy square. So these will be the principal stresses for biaxial stress. अब biaxial stress के लिए there will be only two principal stresses. The third one will always be zero. तीसरा जो रहेगा वो हमेशा जीरो होगा किसके लिए? Biaxial stress के लिए. But if there was a triaxial stress तो आपको sigma 3 भी मिलता. Yes, we have hit the quadruple century, 400. Yes, Karan. Yes, Crown. Yes, Vivek. 400 plus likes. Thank you so much, guys. Thank you so much for such a lovely response. And by looking at these response, I like taking these marathon sessions again and again. मेरे को मजा आने लगा है अब marathon session लेने में. Even I don't feel tired. I don't even feel tired anymore. I can take 12 hours, 15 hours, even 20 hours marathon class. Sometimes we will attempt that. ठीक है, कभी वो भी attempt करेंगे. Yes, thank you so much guys. Thank you so much Varun. Thank you so much Rahul. Thank you so much Ameya. Thank you so much Anku. Thank you so much guys. So beta biaxial stress के लिए sigma 3 will always be 0. There will be only sigma 1 and sigma 2. Yes. Now beta, if you want to calculate principal stresses in some other way, then I have another trick for you. Let's say this is our stress tensor matrix. मान लो एक तो ये जादुई बोर्ड बन जाता है ना, अपने आप मिटने लगता है. Let's say we have this matrix. Okay, this is what? Stress tensor का matrix. I am just writing this in the matrix format. ठीक है, इसको मैंने matrix format में लिख दिया. Okay, the eigen values of this eigen values of A are principal stresses. If you know how to find the eigenvalues, you must know how to find the eigenvalues because you also have to revise mathematics. That is the most important subject. Okay, mathematics में eigenvalues निकालना तो सीखा होगा. So if you find eigenvalues of this matrix, those will be the principal stresses. अब eigenvalues की दो बहुत important properties हैं. ऐसे तो बहुत properties हैं, but there are two very important properties. The sum of eigenvalues, sigma 1 and sigma 2 are the eigenvalues. So the sum of eigenvalues are equal to the sum of these diagonal values, sigma x plus sigma y. And what is the second property? Product of eigenvalues are equal to the determinant, sigma x into sigma y minus tau xy square, right? So these two equations, they are also very useful. In fact, when we were solving problems of complex stress and strain, we have used these equations in a lot of problems. If you might have noticed, हमने जब stress strain के complex stress strain के question solve किए थे, तो बहुत सारे question में ये वाले concept हमने use किए थे, right? So these concepts are very important. Okay, sigma 1 plus sigma 2 equals to sigma x plus sigma y. Sigma 1 into sigma 2 equals to sigma x into sigma y minus tau xy square. Okay, so beta these equation is very important and these two equations are also very important. Okay, so these are principal stresses. Ab maximum shear stress. Now what is maximum shear stress? Let's understand. Okay, अब maximum shear stress कैसे निकालेंगे? So let's say you have this Morse circle. ठीक है, मान लो ये Morse circle है. Okay, for biaxial stress, I am talking about biaxial stress. Okay, right now we are focusing only on biaxial stress. Okay, now there are two types of maximum shear stress. One is known as maximum in plane shear stress. What is maximum in plane shear stress? It is the maximum shear stress in this plane only. इसी plane का maximum shear stress. Okay, तो यहां पे this radius will be equal to maximum in plane shear stress. Okay, so tau 12 will be equal to what? Radius of this Morse circle. अब radius of Morse circle क्या होता है मेरे भाई? रूट ओवर सिग्मा x माइनस सिग्मा y by 2 होल स्क्वायर प्लस tau xy स्क्वायर. बट देर इज अनदर वे ऑफ फाइंडिंग द रेडियस. एक सेकेंड है ना, मैं इसको 1 लिख लेता हूं, इसको 2 लिख लेता हूं. ऑल्दो इट डजंट मैटर, ठीक है, ये मायने नहीं रखता, लेकिन यूजुअल कन्वेंशन वही है. Now beta sigma 1 minus sigma 2 will give you the diameter na. Sigma 1 minus sigma 2 will give you this diameter. So sigma 1 minus sigma 2 by 2 will give you the radius. So you have two equations of finding tau 12. This one and this one. Okay. But this is only maximum in plane shear stress. ये in plane word बहुत important है. Okay. Now another one is known as absolute maximum shear stress. अब absolute maximum shear stress क्या है मेरे भाई? तो absolute maximum shear stress is what? Let's say again I will draw the same Morse circle. Okay, मैं वही Morse circle दोबारा से बना लेता हूं. Same Morse circle. But this time I am not going to draw only one circle. This time I will be drawing 3 circles. The third principal stress is 0, right? So third point, let's say, is here. So I will draw 3 circles now. One will be between 1 and 2, है ना? एक हो जाएगा 1 और 2 के बीच में. Another one will be between 2 and 3, and there will be a third one between 1 and 3. Now which one is the biggest circle? 1 and 3. So beta, the radius of the biggest circle will be the absolute maximum shear stress. Here there was only one circle, so radius of this in plane. रेडियस तीनों में से जो सबसे बड़ा होगा दैट विल बी एब्सोल्यूट मैक्सिमम. तो टाउ मैक्सिमम, एब्सोल्यूट मैक्सिमम इज मैक्सिमम ऑफ, अब यहां पे बेटा ध्यान देना, सिग्मा 1 माइनस 2 बाई 2, 2 माइनस 3 बाई 2 एंड 3 माइनस 1 बाय 2. ओके, सो बेटा द एब्सोल्यूट मैक्सिमम इज द मैक्सिमम आउट ऑफ ऑल 3. Now people get confused that if I am asking you to calculate tau maximum, then which one will you consider? अगर मैं आपको बोलूं कि tau maximum जो है calculate करो, then which one will you calculate? तो बेटा by default if nothing is mentioned then you have to calculate this only. That's why I am writing it tau maximum. तो अगर आपसे कुछ भी नहीं बोला जाए, अगर आपसे सिर्फ मैं ये बोलूं find tau max, then you always calculate this one. But if I specifically mention in the question find maximum in plane shear stress, then you have to calculate this one. ठीक है, तो maximum shear stress निकालते टाइम ये बहुत गलतियां होती हैं, so you need to understand this concept really well. Okay, इसको बहुत ध्यान से बनाना. ठीक है, so this is how you calculate tau maximum. Okay. So these were all the equations you need to remember. Now combined bending and twisting. अब combined bending and twisting में let's say a body is subjected to bending moment as well as twisting moment, तो principal stresses का formula क्या हो जाता है? You need to remember this, 16 by pi d cube. Let's say a circular shaft is subjected to bending and twisting, so 16 by pi d cube m plus minus root over m square plus t square. This is the equation of principal stress for hollow shaft. अगर hollow shaft हुई तो simple, instead of d cube write d outer cube 1 minus k to the power 4. Okay, so this is the equation of principal stresses in a circular shaft subjected to bending moment as well as twisting moment. Okay, now sigma maximum will be this one, 16 by, क्या है यार ये, this is really annoying, you know, I don't know why this happens. एकदम से ये चमत्कारी बोर्ड बन जाता है. 16 by pi d cube m plus root over m square plus t square. This is sigma maximum. And what will be tau maximum? Tau maximum is given by 16 by pi d cube root over m square plus t square. So you need to remember these formula for combined bending and twisting. Okay, so if there is a circular shaft which is subjected to bending moment m and twisting moment t, you can directly use this formula. You can directly use this formula. Okay, अब यहाँ पे ध्यान दो, if there is a hollow shaft, all you need to do is replace d cube with d outer cube 1 minus k to the power 4. That's all. Okay, now here there is a concept called equivalent bending moment and twisting moment. I have explained that concept well. मैंने अपने फुल कोर्स में इक्विवेलेंट बेंडिंग और ट्विस्टिंग मोमेंट का बहुत अच्छे से कॉन्सेप्ट एक्सप्लेन किया था. इनका मतलब क्या होता है, सिग्निफिकेंस क्या होता है. सो इफ यू वांट टू अंडरस्टैंड देम, वॉच माय फुल लेक्चर. अदरवाइज जस्ट रिमेंबर द इक्वेशन. तो m इक्विवेलेंट इज half of m plus root over m square plus t square, and then equivalent twisting moment. T equivalent is equal to root over m square plus t square. Okay, so sometimes they directly ask in the question, 1 mark question, find equivalent bending moment, find equivalent twisting moment. ठीक है, 1 मार्क का क्वेश्चन आ सकता है. तो 1 मार्क का क्वेश्चन अगर आ गया तो फिर इस तरीके से we can find out the equivalent bending moment and equivalent twisting moment. Okay, all right, now दिस वॉज कंबाइंड बेंडिंग एंड ट्विस्टिंग. ठीक है, एक ही फॉर्मूला है, उसी को जोड़ तोड़ के इतनी सारी चीजें, सिग्मा मैक्स, टाउ मैक्स, इक्विवेलेंट बेंडिंग मोमेंट, इक्विवेलेंट ट्विस्टिंग मोमेंट. ओके, दैट्स द एंड ऑफ कॉम्प्लेक्स स्ट्रेस. कॉम्प्लेक्स स्ट्रेस में सिर्फ इतना ही है मेरे भाई. नाउ कॉम्प्लेक्स स्ट्रेन. अब कॉम्प्लेक्स स्ट्रेन में पढ़ने के लिए सिर्फ एक ही चीज है, यू ओनली नीड टू स्टडी वन पर्टिकुलर थिंग, स्ट्रेन रॉसेट. अदरवाइज देयर इज नथिंग. व्हाई? Because the concept of complex stress is very similar to complex strain. Complex strain and complex stress में कुछ भी नहीं होता है. You just need to replace sigma with epsilon and tau with gamma by 2. You get everything very similar. ठीक है, आपको करना क्या है, सिग्मा को एप्सिलॉन से रिप्लेस कर देना है और टाउ को गामा बाय 2 से रिप्लेस कर देना है और आपको कॉम्प्लेक्स स्ट्रेन मिल जाएगा. तो मेरे भाई यहां पे भी वही कहानी, दैट वी हैव triaxial strains, but we never study triaxial strain. We always study biaxial strain. अब मैं पूरे कॉन्सेप्ट को वापस से एक बार घुमा देता हूं, रिवाइज कर देता हूं, डबल रिवीजन हो जाएगा. ओके, ऑल्दो यू डोंट नीड दिस, आपको ये सब कुछ पढ़ने की जरूरत ही नहीं है. You only need to study, you only need to replace sigma with epsilon, tau with gamma by 2. You will get all the equations of complex strain, but still I will write the equation so that you can tally. ठीक है, तो आप tally करते जाना. ठीक है, आपको याद तो होगा ही, अभी अभी आपने देखा. तो बेटा here I will get, instead of sigma I will get epsilon, and instead of tau I will get gamma by 2. तो मेरे भाई this will become what? Epsilon x. This will become what? Epsilon y. And this will become what? Gamma xy by 2. Okay. And if I write them in the matrix form में अगर मैं लिखूं, then I will get this epsilon x, gamma xy by 2, gamma xy by 2, epsilon y. Same thing. I am just repeating them again and again. अब strains on oblique planes, तो मेरे भाई वही सेम इक्वेशन एप्सिलॉन थीटा का इक्वेशन क्या आ जाएगा? एप्सिलॉन x प्लस एप्सिलॉन y बाई 2 प्लस एप्सिलॉन x माइनस एप्सिलॉन y बाई 2 cos 2 theta plus now here not tau, what will come? क्या आएगा यहां पे? एक सेकेंड बेटा, these wires are getting tangled, plus gamma xy by 2 sin 2 theta. Okay, now the second equation is where people make mistake. Don't write like this. ये किया तो गलत. This will be gamma by 2, right? You need to replace every tau with gamma by 2. तो यहां tau theta होता है तो gamma theta by 2. Okay, equals to minus of epsilon x minus epsilon y by 2 sin 2 theta plus gamma xy by 2 cos 2 theta. Okay, yes, very good Aditya, very good. तो मेरे भाई this is the equation of epsilon theta and this is the equations of gamma theta. ठीक है, कुछ याद करने की जरूरत पड़ रही है? Do you need to remember anything? No, just one thing, sigma epsilon tau gamma by 2. खत्म. Yes, चलो दिखाएंगे मेरे भाई. यहां नहीं दिखा सकता, I can't show you this here. I will show you in my personal telegram channel sometimes. Okay, Morse circle. Now there is a Morse circle for strain also. अब Morse circle of strain जो है Morse circle of stress के जैसा ही है. Again same thing. Instead of sigma here I will write epsilon, instead of tau gamma by 2. Okay, now what will be the center? अब यहां पे सेंटर का कोऑर्डिनेट एंड रेडियस क्या हो जाएगा मेरे भाई? सेंटर विल बिकम epsilon x plus epsilon y by 2 and 0, and radius will become root over epsilon x minus epsilon y by 2 whole square plus gamma xy by 2 whole square. देख लो, अपने आप उड़ जाएगा, फिर अपने आप वापस भी आ जाएगा. So this is so irritating. All right, so this is the equation of center and radius, coordinates of center and radius. ठीक है, कुछ याद करना पड़ा? नहीं, कुछ भी याद करने की जरूरत नहीं. यस, नेक्स्ट इज प्रिंसिपल प्लेन्स. अब आपको एक चीज यहां याद करनी है एंड दैट इज प्रिंसिपल प्लेन्स ऑफ स्ट्रेन क्या होगा? planes at which gamma will be 0, right? जैसे वहां tau 0, यहां gamma 0. अब ध्यान दो, the plane at which tau will be 0, gamma will also be 0. So what does it mean? It means principal planes of stress and strain are same. जो स्ट्रेस के टर्म्स में प्रिंसिपल प्लेन होते हैं वही स्ट्रेन के प्रिंसिपल प्लेन होते हैं. तो हियर थीटा P1 will be equals to half of tan inverse of 2 tau xy की जगह gamma xy upon epsilon x minus epsilon y, and this will be equal to half of tan inverse of 2 tau xy upon sigma x minus sigma y. So whether you use this or this, you are going to get the same theta. आपको वही थीटा मिलने वाला है क्योंकि वही प्लेन दोनों के लिए प्रिंसिपल प्लेन है. एंड थीटा P2 विल बी थीटा P1 प्लस 90. यस यस यस. चलो, तो बेटा दिस इज प्रिंसिपल प्लेन्स. अब प्रिंसिपल स्ट्रेन्स, तो प्रिंसिपल स्ट्रेन्स विल बी एप्सिलॉन एट प्रिंसिपल प्लेन्स. इनका फॉर्मूला क्या हो जाएगा? सेम वही चीज, एप्सिलॉन एक्स प्लस एप्सिलॉन वाई बाई 2 प्लस माइनस रूट ओवर एप्सिलॉन एक्स माइनस एप्सिलॉन वाई बाई 2 होल स्क्वायर प्लस गामा एक्स वाई बाई 2 होल स्क्वायर. These are the equations of principal strains. Same here, right? Then maximum shear strain. अब यहां वही सेम दास्तान, मैक्सिमम इन प्लेन अगर बोला तो क्या हो जाएगा? रूट ओवर एप्सिलॉन एक्स माइनस एप्सिलॉन वाई बाई 2 होल स्क्वायर प्लस गामा एक्स वाई बाई 2 स्क्वायर. और अगर कुछ नहीं बोला, अच्छा यहां पे डिवाइडेड बाय 2 भी होगा, सॉरी. अगर कुछ नहीं बोला तो एप्सिलॉन मैक्सिमम बाय 2. अब बाय 2 कैंसिल हो जाएगा तो मैं डायरेक्ट ऐसा लिख सकता हूं, विल बी मैक्सिमम ऑफ एप्सिलॉन 1 माइनस 2 बाय 2. सॉरी, बाय 2 कैंसिल हो जाएगा ना, यहां से बाय 2 और यहां से बाय 2 विल बी कैंसल्ड. सो आई विल डायरेक्टली राइट इट लाइक दिस. Same thing yaar, same thing. Only mistake people make is that on right side they replace tau with gamma by 2, but on left side they forget replacing it by gamma by 2. They just write gamma. तो gamma left side भी you have to write gamma by 2. Okay, left side भी आपको gamma by 2 लिखना है. Left side सिर्फ gamma लिख दोगे तो गलत होगा. Okay, तो यहां see gamma by 2 2 2 2. So all 2's are cancelled. Okay. So maximum shear strain. Okay, now there is only one concept that you need to understand here, and that is strain rosette. So what is strain rosette? Strain rosette are combination of 3 strain gauges in 3 different directions. ठीक है? So let's say we have these 3 strain gauges. Okay, मान लो let's say this is my x axis. ठीक है, मान लो ये मेरा x axis है और मैंने 3 स्ट्रेन गेज लगा दिए. ओके, 3 स्ट्रेन गेजेस, 1 2 and 3. I have put 3 strain gauges in 3 different direction. Strain gauge number A, strain gauge number B, strain gauge number C. Okay, I have got the readings of all 3 strain gauges. Okay, and there are 3 different angles. अब angles यहाँ पे कैसे लेते हैं इस चीज का ध्यान देना बेटा. Angle for A will be measured like this. This will be theta A, this will be theta B, this will be theta C. Okay, so X से angle लेना है. Okay, so बेटा theta A, theta B, theta C. This you have got. Now you need to write the equation of epsilon. So epsilon A will be equal to what? Epsilon x plus epsilon y by 2 plus epsilon x minus epsilon y by 2 cos 2 theta A plus gamma xy by 2 sin 2 theta. Now यहाँ पे if you are confused why I am measuring theta from horizontal, theta तो vertical से measure करते हैं, तो बेटा I have explained this concept in my full course. यहाँ horizontal से vertical से वाला confusion क्यों हो रहा है, that I have explained in full course. So if you are confused here, then beta watch that full course. Okay. Otherwise, those of you who are following me, they know that why we measure theta from horizontal in this case, है ना. अब epsilon b के केस में भी it will be something like this. फिर epsilon c will be something like this. So here you get three equations and three unknowns. Epsilon ABC are known, theta ABC are known. What are unknowns? Epsilon x, epsilon y and gamma xy. These three are unknowns. So after solving these three, you get epsilon x, epsilon y and gamma xy. Now there are two types of strain rosettes. Rectangular strain rosettes and delta strain rosettes. Let's understand them. So in case of rectangular strain rosette, we put the strain gauges like this. तीनों strain gauges को हम 45 पे रख देते हैं. Okay, we put the strain gauges at 45 degree to each other. So this angle is 45. This angle is also 45. Okay. So here you will notice that this is in x direction and this is in y direction. तो यहाँ पे देखो theta A is 0 degree. Theta B is 45 degree. Theta C is 90 degree. Okay. तो ये तो सीधा आपको epsilon x दे देगा. तो epsilon x will be epsilon A. Epsilon y will be epsilon c, है ना. Now I only need gamma xy, and in order to find gamma xy, we have this relation. By putting theta b equals to 45 degree, we get this relation. Okay, so gamma xy will be equals to 2 into epsilon b minus epsilon a plus epsilon c. Okay, so in rectangular strain rosette, it is very easy to find epsilon x, epsilon y and gamma xy because we have these simple relations. That in many problems you will see rectangular strain rosette only. Maximum cases में rectangular strain rosette ही मिलेगा आपको, right? Yes Vivek, 7 hours are almost completed. 7 घंटे almost हो गए. Now बेटा delta strain rosette में, in delta strain rosette we put the strain gauges at 60 degree to each other like this. ठीक है, हम strain gauges को क्या करते हैं 60 डिग्री पे सेट करते हैं. अब यहां पे you will only get epsilon x directly. Epsilon y and gamma xy के लिए you will be solving two equations. Okay, here theta a will be 0, theta b will be 60, theta c will be 120 degree. Okay, अब इसी को मैं ऐसे भी रख सकता हूं. I can put it like this also. This also. I can put it like this also. A, B, C. अब यहां पे ध्यान दो बेटा. Here theta A will be 0, theta V will be 60 and theta C will be minus 60. But it doesn't matter. Even if you put it like this or this, your final answer will be same. आप ऐसे रखो, फाइनल आंसर सेम ही आता है, ठीक है। और इसी को मैं ऐसे भी रख सकता हूं, आई कैन पुट इट लाइक दिस ऑल्सो। This is also a form of delta strain rosette. This is A, this is C, और मैंने B को उल्टा कर दिया है, so this is B, ठीक है। तो मेरे भाई मैटर नहीं करता है, इट डजंट मैटर, आप इसको कैसे भी रखो, इट डजंट मैटर, ठीक है। देखो यहां एंगल क्या हो जाएगा, दिस विल बी 120, this will be 120, this will be 120. So even if you put it like this or this or this, your final answer will remain same, okay? And let me tell you that maximum chances are that you are going to get rectangular strain rosette, ठीक है। maximum chances यही है कि आपको जो question मिलेगा एग्जाम में, that will be based on rectangular strain rosette, not delta strain rosette. delta strain rosette के ऊपर question नहीं मिलेगा, डेल्टा स्ट्रेन रोसेट के ऊपर क्वेश्चन नहीं मिलेगा। यार ये असामाजिक तत्व जो हैं ये बहुत हो गए, ठीक है, इन सबको ब्लॉक करवाना पड़ेगा। सो डेल्टा स्ट्रेन रोसेट के ऊपर क्वेश्चन आने की संभावना बहुत कम है। मैक्सिमम चांसेस 99% चांसेस आर दैट यू आर गोइंग टू गेट क्वेश्चन फ्रॉम रेक्टेंगुलर स्ट्रेन रोसेट ओनली, ओके। So do you understand? Do you understand? बेटा you only need to remember, ये रट लो, आराम से बन जाएगा, ठीक है। रेक्टेंगुलर स्ट्रेन रोसेट के ऊपर till now there has been only one question I guess, and that was also not in GATE I think, ठीक है। मेरे ख्याल से ES का क्वेश्चन था, GATE में तो शायद अभी तक आया ही नहीं है, ओके। So there are very less chances of getting question from strain rosette, okay. So this is complete कॉम्प्लेक्स स्ट्रेन। तो कॉम्प्लेक्स स्ट्रेन में स्ट्रेन रोसेट का बस एक कॉन्सेप्ट अलग से पढ़ना है, द रेस्ट ऑफ द कॉन्सेप्ट्स आर वेरी सिमिलर, ओके। नाउ वी ओनली हैव प्रेशर वेसल एंड कॉलम। अब प्रेशर वेसल तो नन्ना मुन्ना राही है, कॉलम में तो कुछ है ही नहीं, ठीक है। सो लेट्स क्विकली रैप अप, ओके, मे बी वी विल कंप्लीट इट बाय 4:30, ओके। लेट्स क्विकली रैप इट अप। सो बेटा प्रेशर वेसल्स आर व्हाट? प्रेशर वेसल्स आर द वेसल्स व्हिच कंटेन हाई प्रेशर फ्लूइड, ऐसे टैंक्स या स्टोरेज डिवाइस जिनमें हाई प्रेशर फ्लूइड भरा हो। फॉर एग्जांपल बॉयलर्स, एलपीजी सिलेंडर या फिर ऑक्सीजन सिलेंडर, व्हाटएवर सिलेंडर यू हैव वेयर वी हैव फ्लूइड एट हाई प्रेशर, दैट इज नोन एज pressure vessel, okay. Now pressure vessel are divided into two categories, okay, thin pressure vessel and thick pressure vessel. A thin pressure vessel में D by T ratio is very high, मतलब thickness is very less, it is less than or equal to D by 20, and here thickness is greater than D by 20, okay. What is thickness? If it's a pressure vessel it must be hollow, है ना, क्योंकि इसको स्टोर करना है ना, तो कुछ ऐसा होगा, it will be something like this, right? So this is the internal diameter D and this is the thickness T. So if the thickness is very small then it is thin pressure vessel, and if the thickness is large enough it is a thick pressure vessel. Why thickness is small or large? Depending upon what is the pressure inside it. If the pressure is very small, 0.5 megapascal, 1 megapascal, 2 megapascal, then it's a thin pressure vessel. But if the pressure is huge, 100 megapascal, 50 megapascal, 200 megapascal, then thick pressure vessel. So depending upon pressure, we have thin and thick pressure vessel. Now why do we put them in different categories? इनको अलग अलग कैटेगरी में क्यों रखा गया? Because beta, if the thickness is very small, I can assume that stresses throughout the thickness are constant. But if the thickness is large, then I have to consider the variation of stress. So इसीलिए equations of stress and strain in both cases are different. थिक प्रेशर वेसल इज नॉट इन योर सिलेबस, आपके सिलेबस में थिक प्रेशर वेसल है ही नहीं. देयर इज ओनली थिन प्रेशर वेसल इन योर सिलेबस. ओके, थिन सिलिंड्रिकल प्रेशर वेसल एंड थिन spherical pressure vessel. Okay, so let's see thin cylindrical pressure vessel. So let's say we have a thin cylindrical pressure vessel of length L, internal diameter D, wall thickness T. ठीक है, these are the dimensions of the cylinder and it is subjected to internal pressure P and this will be the gauge pressure. ठीक है, ये कौन सा प्रेशर होगा मेरे भाई? गेज प्रेशर, मींस अबव एटमॉस्फेरिक प्रेशर. ओके, जो भी एटमॉस्फेरिक प्रेशर के ऊपर का प्रेशर है दैट इज P. सो इनसाइड दिस देयर इज गेज इंटरनल प्रेशर P. नाउ वी नीड टू फाइंड द स्ट्रेस एंड द डिफॉर्मेशन. सो व्हाट टाइप ऑफ स्ट्रेसेस आर डेवलप्ड? So there are three stresses developed. Okay, longitudinal stress in the direction of length, circumferential stress in the direction of circumference and radial stress. Okay, जिसमें से we don't consider the radial stress. Why? Because radial stress is negligible compared to longitudinal and circumferential stress. So we don't consider that. ठीक है, हम लोग radial stress को consider ही नहीं करते. We only consider circumferential and longitudinal stress. So if I consider a small element on the surface of this cylinder, अगर मैं इस surface cylinder के surface पे एक छोटा सा element consider करूं, then you only have these two stresses. Sigma R we don't consider, so you have sigma L, you have sigma C. Okay. Now what is the formula of sigma L longitudinal stress? Very simple. Sigma L is equal to PD by 40, where D is internal diameter, T is thickness and P is pressure. So sigma L is PD by 40 and circumferential, also known as hoop stress, is PD by 2T. So you can see that circumferential stress is 2 times of longitudinal stress. Okay, sigma L का formula, sigma C का formula. Okay, now once you get these two, अब आप sigma max और tau max निकाल सकते हो. Okay, once you get these two, you can calculate sigma max and tau max. Okay, तो यहां पे ध्यान दो. If I draw the Morse circle for this, it will be something like this: sigma tau this will be sigma C, sigma L. Okay, so let me consider this principal plane number 1, principal plane number 2, principal plane number 3. So beta sigma 1 will be sigma C, sigma 2 will be sigma L. So here principal stresses are sigma L and C only. तो आपको अलग से प्रिंसिपल स्ट्रेस निकालने की जरूरत नहीं है, बिकॉज इस प्लेन में देयर इज नो टाउ ना. So these are principal planes. Okay, now if you got principal planes, then sigma maximum will be maximum of these two, sigma C, यानी PD by 2T. अब tau maximum are of two types. Tau maximum in plane. Tau maximum in plane मतलब इसी में से tau maximum निकाला, then what will be tau maximum बेटा? It will be sigma C minus sigma L by 2, means PD by 2T minus PD by 4T by 2 means PD by 80. This will be what? Tau maximum in plane. But absolute tau maximum will be how much? So absolute tau maximum will be, the biggest circle will be between 1 and 3, sigma c minus 0 by 2. Sigma c minus 0 by 2 means PD by 40. Okay. So these will be the formulas of sigma max and tau max. Yes. Now, longitudinal strain. So longitudinal strain epsilon L will be sigma L by E minus nu sigma C by E. And if I put the values, it will become this, PD by 40E 1 minus 2 nu, which will be delta L by L. This will be the equation of epsilon L. Circumferential strain will be sigma C by E minus nu sigma L by E. And if I put the values here, then I will get PD by 40E 2 minus nu. And what will be circumferential strain? Change in diameter per unit original diameter. So from here you can calculate the change in length, and from here you can calculate the change in diameter. But we also have to calculate change in volume. So how do we calculate change in volume? Epsilon V will be epsilon L plus 2 into epsilon C. So if I put the values here, I will get this, PD by 4TE 5 minus 4 mu. This will be change in volume per unit original volume. ठीक है, और वॉल्यूम क्या होगा मेरे भाई यहाँ पे? द इक्वेशन ऑफ वॉल्यूम विल बी pi by 4 d square L. Now here a lot of students get confused that it's a hollow cylinder, so why you are using a equation of solid cylinder? So beta change in volume matlab ki how much change in volume, total volume means volume is the space occupied. Okay, so even if it is a solid cylinder or hollow cylinder, it is going to occupy the same space. So that's why we are not bothered whether it is hollow or solid. Okay, the equation of volume will remain same. Okay, so these are the equations of deformations. Now thin sphere. So let's say we have thin sphere. So in case of thin sphere, you don't get longitudinal stress because there is no length, there is only circumferential stress. So on the surface of sphere, you will only get sigma C in both direction. X direction में भी वही, Y डायरेक्शन में भी वही. ठीक है, यहां पे अगर आप देखोगे then sigma C will be like this. ये सब डेरिवेशन मैंने कराए हैं. ओके, सो बेटा व्हाट इज द इक्वेशन ऑफ सिग्मा C हियर? सिग्मा C will be PD by 4T. Okay, this is the circumferential stress. Okay, now what will be sigma maximum and tau maximum? तो बेटा अब यहां पे तो आपको x और y दोनों में सेम स्ट्रेस मिल रहा है, राइट? यू आर गेटिंग सेम स्ट्रेस इन x and y. So this is what? This is a hydrostatic state of stress, biaxial hydrostatic state of stress. And if you draw the Mohr circle for this, इस केस के लिए अगर मैं Mohr circle draw करूं, if I draw Mohr circle for this case, then what will I get? I will get a point, है ना? मेरे को एक पॉइंट ही मिलेगा बिकॉज सिग्मा सी सिग्मा एल बोथ आर सेम, तो मेरे को एक पॉइंट ही मिलेगा. 1 और 2 वही रहेगा. तो बेटा इस केस में सिग्मा 1 सिग्मा 2 बोथ आर सिग्मा सी. व्हाट विल बी सिग्मा मैक्सिमम? सिग्मा सी मीन्स पीडी बाय 40. ओके, in case of sphere. Then tau maximum in plane. अब in plane मतलब 1 और 2 को देखोगे तो ये तो 0 होगा. But absolute tau maximum will not be 0. It will be sigma c minus 0 by 2 means PD by 80. So these will be the equations of sigma maximum and tau maximum. Okay. ये याद करने की जरूरत नहीं है. If you know this sigma c equation and if you know this, then you can find out what will be sigma maximum, what will be tau maximum, right? इसके लिए आपको अलग से कुछ रट्टा मारने की जरूरत नहीं है. Okay. Now circumferential or hoop strength. So epsilon c can be written as sigma c by E minus nu sigma c by E. So this is given by PD by 4TE 1 minus nu, which will be delta D by D. And what will be volumetric strain in this case? 3 times of epsilon c. So simply it will become 3PD by 4TE 1 minus nu delta V by V, change in volume. So we can find change in diameter, we can find change in volume. अब यहां वॉल्यूम की इक्वेशन क्या होगी? Volume of sphere 4 by 3 pi r cube, but in terms of diameter pi by 6 d cube. Okay, so you can find change in diameter as well as change in volume. Although इसके ऊपर क्वेश्चन कम ही आता है, change in diameter, change in volume ये सब निकालने नहीं आता है, स्ट्रेस के ऊपर ही आता है. Okay, so this is the end of pressure vessel. Now there is only one chapter left, columns, and after this the entire strength of material revision will be done. So how you guys are feeling? How is the josh? How is the josh? Beta, because we are in the last one chapter, last chapter. तो कैसा जोश है? सब सो तो नहीं गए हैं? अभी भी सब मेरे साथ हैं? Everyone is here with me. Yes, who is here with me right now? Who is here with me till the end, till the very end? कौन कौन मेरे साथ है मेरे भाई? स्ट्रेंथ ऑफ मटेरियल के फुल रिवीजन में till the end. Yes, yes, धनंजय, yes, आदित्य, yes, करण, yes, शुभम, राहुल, आदित्य, कृष्णा, very good. Yes, yes, अनिमेश, yes, yes, दिव्येश, yes, परमेश्वर, ऋतिक, वरुण, yes, यस 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 यस, फोड़ दिया भाई, फोड़ दिया, ऐसे ही फोड़ते रहेंगे. यस शुभम, यस विवेक, करण, यस कृष्णा, रुद्रेश, यस अंकुर, यस. चलो मेरे भाई, तो मेरे भाई आखिरी एक चैप्टर भी खत्म कर लेते हैं. नाउ कॉलम्स इज द लीस्ट इंपॉर्टेंट चैप्टर बिकॉज कॉलम से आज तक बहुत कम क्वेश्चन आए, बट यू कैन be sure because in GATE 2020 there was a question from column. Okay, और बहुत ही छोटा चैप्टर है. Okay, what is column? Columns are structural members which are subjected to axial compressive loads. Okay, axial compressive loads like this and due to which they buckle. Okay, अब buckling का concept अगर आपको समझना है then you have to consider this particular problem. If you want to understand what is buckling, then you have to understand this. Okay, let's say that we have a bar like this. Okay, now if I give this bar a very small deflection, okay, initially it was straight and now I gave this bar a very small deflection. Okay, so beta understand what is happening here. This is the force P and I gave it a small deflection, let's say X. So the spring force will be Kx. Okay, this is the point B. Now understand what is happening here. This P force is trying to deflect it. The moment of P into X is trying to deflect it, move it away, and moment of spring Kx into L is trying to restore it. एक मोमेंट इसको डिफॉर्म कर रहा है, दूसरा मोमेंट इसको रिस्टोर कर रहा है. If the restoring moment is greater, अगर restoring moment ज्यादा है, देन इट विल बी स्टेबल, और डिफॉर्मिंग मोमेंट ज्यादा है देन इट विल बिकम अनस्टेबल। इज इट क्लियर? अगर रिस्टोरिंग मोमेंट ज्यादा है तो ये इसको स्टेबल रखेगा, बट डिफॉर्म करने का मोमेंट ज्यादा है देन इट विल बिकम अनस्टेबल, क्योंकि ये डिफॉर्म होता चला जाएगा। नाउ देयर विल बी वन पोजीशन व्हेन द मोमेंट ऑफ दिस एंड दिस विल बी इक्वल, दैट इज नोन एज क्रिटिकल कंडीशन, बिकॉज दैट इज द लिमिट, दैट इज द लिमिट, दैट इज द बाउंड्री। तो एट क्रिटिकल कंडीशन, at critical condition, P critical into X will be equals to Kx into L। तो यहां से P critical क्या आ गया बेटा? This will be KL, but this is assuming that the bar is rigid। यहां मैंने क्या assume कर लिया? बार क्या है? Rigid। Okay, this is a rigid bar। Okay, but beta all the bars will not be rigid na, so in that case this critical load can be calculated by Euler's theory। according to Euler's theory, P critical is given by pi square I minimum by LE square, where I minimum is what? Let's say we have a rectangular cross section। ठीक है, मान लो अपने पास एक रेक्टेंगुलर क्रॉस सेक्शन है, दिस इज एक्स एक्सिस एंड दिस इज वाई एक्सिस। ठीक है, तो मेरे भाई आई मिनिमम इज मिनिमम ऑफ आई एक्स एंड आई वाई। ओके, आई मिनिमम क्या होता है? आई एक्स और आई वाई में से जो भी मिनिमम हो दैट आई विल पुट इन द प्लेस ऑफ आई मिनिमम। ओके, so if it is a rectangular section it will be minimum of ix and iy, if it is a circular section both will be same। okay, so depending upon cross sections you can choose I minimum। now what is this LE? LE is the effective length। LE क्या है? LE is the effective length। and what is effective length? under different support condition the value of effective length is different। okay, so beta we have 4 एंड कंडीशंस, 4 सपोर्ट कंडीशंस हमारे पास है। वन एंड फिक्स, अदर एंड फ्री, बोथ एंड फिक्स, सॉरी बोथ एंड हिंज्ड, वन एंड फिक्स, अदर एंड हिंज्ड एंड बोथ एंड्स फिक्स्ड। ओके, और हर केस में वैल्यू जो है अलग अलग है। अब आपको इसको याद रखना है, तो कैसे याद करना है ये ट्रिक मैं आपको बता देता हूं। ओके, P critical is inversely proportional to 1 by LE square। मतलब if LE is more P critical is less, अगर LE ज्यादा तो P critical कम। Now beta you need to understand one thing, P critical is less means it will easily buckle, P critical is more means it will not easily buckle। P critical कम है मतलब फट से बकल, P critical ज्यादा है मतलब जल्दी बकल नहीं होगा। ओके, नाउ यू नीड टू रिमेंबर 4 वैल्यूज ऑफ LE। आपको LE की 4 वैल्यूज याद रखनी है। 2L L, ये L बाय रूट 2 है मेरे भाई। ठीक है, इसको मैं L बाय रूट 2 लिख सकता हूं, एंड L बाय 2। 4 वैल्यूज आपको याद रखनी है LE की। LE इज इक्वल्स टू L, L बाय 2, L बाय रूट 2 एंड 2L। ये 4 वैल्यू रैंडमली यू रिमेंबर। ओके, L, L बाय 2, L बाय रूट 2, 2L। नाउ अंडरस्टैंड, you need to remember one thing, if both ends are hinged LE will be L। दोनों एंड्स अगर हिंज है तब तो LE L है। बाकी 3 कंडीशन क्या है? वन एंड फिक्स, अदर फ्री, बोथ एंड फिक्स, वन एंड फिक्स, अदर हिंज। अब बेटा ये 3 जो बची, इनमें से सबसे जल्दी कौन बकल होगा? विच कॉलम विल बकल इजीली? द वन विच इज वन एंड फ्री, विच हैज वन एंड फ्री, दैट विल इजीली बकल। तो उसका P critical should be minimum, right? P critical of this should be minimum, and if P critical should be minimum, LE should be maximum। तो इन चारों में से मैक्सिमम कौन सा? 2L। so if one end is free and other end is fixed, then बेटा LE will be 2L। is it clear? अगर एक एंड फ्री है तब तो ये सबसे जल्दी बकल हो जाएगा ना, क्योंकि इसको ज्यादा सपोर्ट नहीं मिल रहा है, इट विल बकल इजीली। So beta LE will be maximum, P critical will be minimum, LE will be maximum. Okay. Then the next one, both end fix. अगर दोनों end fix हुए, then beta it will be very difficult to buckle because it is rigidly supported. दोनों end fix कर दिए, तो उसका P critical should be maximum, मतलब LE should be minimum. So which one has minimum LE? 0.5 L, है ना? So beta this one will be for both end fix. तो one end free, both end fix. अब बचा one end fix, other end hinge, तो उसके लिए L by root 2. So it will be very easy. It will be very easy. तो मेरे भाई यहां से आपको बहुत आसानी से याद रख सकते हो. आप ये 4 रैंडम वैल्यू याद कर लो. L, L by 2, L by root 2, 2L. Okay. L will be for both end hinge. ये तो सबको पता रहता है, याद रहता है. Now जो सबसे आसानी से बकल होगा उसका P critical minimum. If one end is free, it will easily buckle. So P critical will be minimum. So LE will be maximum, 2L. If both end fix, so it will not be easy to buckle, difficult to buckle. मतलब P critical maximum, LE should be minimum, L by 2. बचा one end fix, other end hinge. So L by root 2. So this is a very simple trick which you can use to remember this. Okay, so you only need to remember these 4 values. Okay, chalo. Now, limitation of Euler's theory of buckling. So understand, slenderness ratio LE is given by, lambda, slenderness ratio lambda is given by LE by K minimum, where K minimum is what? Minimum radius of gyration. K minimum क्या है मेरे भाई? Least radius of gyration. अब radius of gyration क्या होता है? This I have already explained, so I will not get into the detail. Okay. So this is known as slenderness ratio. Euler's theory is only applicable if lambda, slenderness ratio, is greater than or equal to pi root over E by sigma c. Okay, ये याद कर लो. You remember this. Euler's theory is only valid if this slenderness ratio is greater than or equal to pi root over E by sigma c. Okay, so you need to remember this equation. There will be theory question based on this. इसके ऊपर theory question आ जाता है कि Euler's theory जो है वो कब valid है कब नहीं है. So बेटा slenderness ratio के ऊपर भी question you might get LE by K minimum and lambda should be greater than or equal to pi root over E by sigma c. That's it. That's all you need to remember in columns. ठीक है, तो एक तो Euler's theory की equation, then LE values and then slenderness ratio. This is all you need to remember in columns. That's it. That's the end of strength of materials for you. तो आपका पूरा strength of materials रिवाइज हो चुका है. How many pages? Almost 230 pages. लगभग 230 पेज की आपकी पीडीएफ बन रही है. ओके, वी हैव रिवाइज्ड ऑल द कॉन्सेप्ट, राइट. 230 पेज की पीडीएफ बन रही है. आई विल अपलोड दिस पीडीएफ इन द टेलीग्राम चैनल. ठीक है, तो बेटा लगभग 230 पेज. सो वी हैव रिवाइज्ड ऑल द कॉन्सेप्ट्स. लेट मी जस्ट शो यू द syllabus. So we have seen introduction to stress strain, material properties, axially loaded member, torsion, shear force bending moment, bending stress, shear stress, deflection, complex stress, complex strain, pressure vessel and column. So this is the complete revision of strength of material for you in 8 hours marathon session. Not even 8 hours, 7 hours 30 minutes almost. And we have completed the entire strength of material in one go. एक क्लास में पूरा strength of material. तो मेरे भाई, if you download the PDF of this, then you can easily revise it whenever you want. आपको जब भी रिवीजन करना हो, आप इस PDF को यूज कर सकते हैं. You can use this PDF. I will upload the PDF. I will upload the PDF. PDF of this lecture कहां मिलेगी आपको? एक तो I will upload it here. tinyurl.com/Apuroop10. Okay, open any Excel sheet ऑफ सॉम की कोई भी एक्सेल शीट ओपन करना, ठीक है, क्विक रिवीजन, फुल कोर्स, कोई भी एक्सेल शीट ओपन करना, उसमें आपको मिल जाएगी. और दूसरा, माय टेलीग्राम चैनल, मेरा जो पर्सनल टेलीग्राम चैनल है उस पे भी आई विल अपलोड. ओके, सो यू विल गेट द पीडीएफ हियर इन दिस tinyurl.com/Apuroop10 और हियर इन माय टेलीग्राम चैनल. ओके, मशीन डिजाइन की पीडीएफ भी है मेरे भाई. I have uploaded it in Telegram channel. I have uploaded it here. तो बार बार मत मांगो मेरे भाई. I have already uploaded. ठीक है. Yes, I will bring Tom and Vibration lectures also. I will bring Tom and Vibration marathon class also. Okay. So बेटा, join this Telegram channel in order to get the PDF. ठीक है. Just go to Telegram app. Just go to your Telegram app. अपने Telegram app पे चले जाओ and search for Apuroop 10 and join this Telegram channel. And you will find the PDF here, or just open this link tinyurl.com/Apuroop10. ये लिंक जो है ऊपर पिन भी की हुई है. So बेटा, just click on that link and you will open tinyurl.com/Apuroop10. There also you will find the PDF. There also you will find all my lectures completely free. सारे lectures मेरे मिल जाएंगे. Okay, and बेटा, don't forget that we have recently started new batches for GATE 2022, 2023 and ESC 2021. So if you are interested in getting into these batches, then take Unacademy subscription. See, these batches are one of the best online batches right now. आज की डेट में ऑनलाइन जो भी गेट की या ईएससी की प्रिपरेशन कर रहा है उसके लिए बेस्ट पॉसिबल बैचेस आर हियर. Trust me, okay? If you believe in me, trust me, these are the best batches. Why? Because best of the best faculties are teaching in these batches, okay? And the best thing is there are multiple batches, multiple educators, so you can change your batch, you can change your educator. That is in your hand. That kind of flexibility you get on Unacademy Plus, okay? Now you might be thinking, if everyone is available here, then why do I need Unacademy Plus subscription? So beta, Unacademy Plus subscription will give you first स्ट्रक्चर्ड कोर्स. एक तो आपको स्ट्रक्चर्ड कोर्स मिलता है. ओके, एवरीथिंग विल बी वेल ऑर्गेनाइज्ड. यू विल नो दैट विच फैकल्टी विल टीच विच सब्जेक्ट, when which subject will start, which subject will end. So all this will be well structured. You can plan accordingly. Second thing, not only lectures, you will get dedicated doubt solving sessions, which is very important. If I am teaching you but you are not getting your doubt solved, you are not getting your doubt cleared, means you are not understanding anything. You are just memorizing everything. So doubt solving sessions are very important. Practice sessions, practice sheets you need to get. Weekly tests you need to get. Crash courses, rank improvement batches. So beta, if you are just thinking of qualifying GATE, then these content will be enough for you. But if you are thinking of getting a good rank, then you need Unacademy Plus. You need a structured course. You need guidance and mentorship of these faculties who are having years of experience. Okay. And if you want a more personalized help, then you can take Unacademy Iconic subscription where you are going to get a personal coach. A personal coach क्या करेगा? He will be studying you, your strengths, your weakness, what is your schedule, how many hours you can put. Accordingly, he will make your study plan and he will be analyzing your test score. He will be telling you from time to time where you need to improve. So he will be monitoring you 24/7. So he will help you in a more personalized way. Now beta, what are the benefits of Unacademy platform? So this is India's #1 online learning platform. अगर ऑनलाइन पढ़ना चाहते हो तो इससे बढ़िया प्लेटफॉर्म नहीं मिलेगा. आपको कुछ ऐसे टूल्स मिलेंगे जिससे आपकी पढ़ाई जो है बहुत स्मूथली हो जाएगी on Unacademy platform. You will be facing these types of live polling scoreboard which will be always telling you what is your rank, what is your timing when you are solving problems. The classes will be so interactive that you will feel like you are sitting in front of the teacher. Sometimes we feel like we are sitting in front of the students because the classes are that interactive. We are already continuously talking to each other. Okay. And doubt sending is also very easy. You can send your doubts in the picture format. You can attach your doubt like this in the picture format and there are dedicated doubt solving sessions. Every fourth lecture is a doubt solving session where only doubts will be solved. And the best thing, multiple branches, multiple batches, multiple educators. There are so many batches, so many educators, and all of them are very good. They have years of experience. All of them are rank holders. So it will be on your option. It will be in your hands which batch you want to join, which teacher you want to follow. All of that will be your option. All of that will be your choice. Okay. One subscription, all batches. That is the best thing. So take Unacademy Plus or Iconic subscription. Take 1 year, 1.5 year or 2-year plan. Don't forget to use this code Apuroop10. If you use this code, the moment you enter this code, you are going to get 10% off, which will be the maximum discount, and you will get my personal guidance and mentorship. You will be under my personal guidance because if you are using this code, means you are believing in me. ये कोड यूज करके एडमिशन ले रहे हो मतलब मुझ पे भरोसा करके आ रहे हो, मतलब कि आप मेरी जिम्मेदारी हो, मैं आपको पूरी तरीके से गाइड करूंगा, एंड तक आपके साथ रहूंगा. ओके, सो बेटा यू कैन सी दैट यू ओनली नीड टू पे 1650 रुपीज पर मंथ और लगभग 54 रुपीज पर डे. एंड ऑल्सो यू कैन पे दिस इन नो कॉस्ट EMI. आप इसको इंस्टॉलमेंट्स में, मंथली इंस्टॉलमेंट में पे कर सकते हो. ओके, and for Iconic subscription you can take 1 year or 2-year subscription plan. That's it. Okay, so I will see you soon on Unacademy Plus and Iconic subscription. Okay, don't forget to hit the like button, share and subscribe to this channel before leaving. I am not going to let you go. Yes मेरे भाई, सब कुछ तुरंत कर दूंगा. I will upload the PDF. I will upload the PDF in half an hour. ठीक है, आधे घंटे के अंदर जो है आई विल अपलोड द PDF. ओके, व्हाट एल्स यू वांट मी टू डू? और कुछ? एनीथिंग एल्स यू वांट टू से? एनीथिंग एल्स यू वांट टू से? यस, इंजीनियरिंग मैकेनिक्स का एक मैराथन करने वाले हैं. इन नेक्स्ट वीक वी विल बी हैविंग अ मैराथन ऑन इंजीनियरिंग मैकेनिक्स. सिंग अ सॉन्ग इन तेलुगु. सिंग अ सॉन्ग इन तेलुगु. ओके, चलो, let me sing a song in Hindi and then I will be singing a song in Telugu. Okay, which song do you want me to sing? अब मेरे को ढूंढना पड़ेगा. Any latest song? And see, my throat is not well right now, so I will not sound good, but still I will try. Okay, so this is one of my favorites and I have sung it before also. मैंने ये पहले भी गाया हुआ है, but अभी मेरे को और कुछ ध्यान में नहीं आ रहा है, तो मैं यही वाला गा देता हूँ. ओके, अच्छा नहीं, ये वाला शायद नहीं गाया. ओके, चलो. ओके ओके ओके, सो नाउ आई विल सिंग. पता म्यूजिक कुछ है नहीं तो मेरे भाई, और ऊपर से मेरा गला खराब है. ठीक है ना, तो ये मैं बहाने नहीं मार रहा हूँ, बहुत गंदा गाने वाला हूँ, तो अपने कान बचा लेना. ओके, हाथ थाम ले पिया, करते हैं वादा, अब से तो आरज़ू तू ही है इरादा. मेरा नाम ले पिया, मैं तेरी रुबाई, तेरे ही तो पीछे पीछे बरसात आई, बरसात आई. तू इत्र इत्र सा मेरे सांसों में बिखर जा, मैं फकीर तेरी कुर्बत का, तुझसे तो मांगू रे. तू इश्क इश्क सा मेरे रूह में आके बस जा, जिस ओर तेरी शहनाई उस ओर मैं भागूं रे, तू नज्म नज्म सा मेरे होठों पे ठहर जा, मैं ख्वाब ख्वाब सा तेरी आंखों में जागू रे. So this is the song that came in my mind right now. Thank you so much guys, thank you so much for appreciating, although it was very poor because मेरा गला जो है उसकी वाट लगी हुई है. Thank you sir, thank you sir, thank you so much, thank you so much, thank you so much. Okay, I hope you guys are doing really great. I hope सबके सब जो है वो पूरा दमखम लगा रहे होंगे अपने रिवीजन में, right? So beta, whatever type of classes you need right now, you just let me know and I will bring that for you. Okay? तेलुगु में अब मेरे भाई, तेलुगु में मेरे को इतना ज्यादा आता नहीं है. Okay? तो आज हिंदी से काम चला लो. In the next marathon class, I will sing a song in Telugu. Okay? और जिसमें भी गाना है. Thank you so much. Thank you so much. Thank you so much. तो मेरे भाई सबसे जरूरी बात जो मैं आप लोगों को बोलना चाहता हूं, राइट नाउ देयर आर ओनली 15-20 days left for your gate. Okay, and these are the most crucial 15-20 days for you. Okay, so you have to put all the efforts in these 15-20 days. Okay, and whatever practice sessions and revision sessions you guys can attend those lectures, because you need to repeatedly solve these questions, you need to repeatedly go through these theories. Okay, आपको बार बार यही थ्योरी पढ़नी है, यही प्रॉब्लम सॉल्व करने हैं. ओके, वी हैव रिसेंटली स्टार्टेड मोस्ट एक्सपेक्टेड क्वेश्चन सीरीज ऑन स्पेशल क्लास. ठीक है, तो उसकी भी आपको पीडीएफ मिल जाए, एक्सेल शीट मिल जाएगी. मोस्ट एक्सपेक्टेड क्वेश्चन सीरीज ऑन स्पेशल क्लास, यू विल फाइंड द एक्सेल शीट फॉर दैट. ओके, ये मोस्ट एक्सपेक्टेड एक्सेल शीट क्वेश्चंस की जो सीरीज है, ये आप लोग अटेंड करना मत भूलना. So go to tinyurl.com and you will find this Excel sheet of most expected question series. Okay, so every day at 2 p.m. and 4 p.m. we are taking these classes. ठीक है, तो अभी हमने SOM खत्म किया था, then machine design is also completed, then from tomorrow I am starting engineering mechanics and then theory of machine and then vibration. Okay, every day 2 classes, 2 p.m. and 4 p.m. This is a special class. Okay, so if you want to attend these classes, just go to this tinyurl.com/Apuroop10, find the Excel sheet of most expected question series and join that every day 2 p.m. and 4 p.m. Okay, so your practice of all these subjects of design will be over, and then for theory practice I will keep on taking these marathon classes, so your theory will also be revised. Okay, and I am also thinking of bringing a रिवीजन क्लास फॉर थ्योरी ऑफ मशीन एंड वाइब्रेशन. ठीक है, तो थ्योरी ऑफ मशीन और वाइब्रेशन की भी रिवीजन क्लास में लेने वाला हूं. यस, थैंक यू सो मच. यस यस यस, आई विल ब्रिंग मैराथन सेशन फॉर थ्योरी ऑफ मशीन एंड वाइब्रेशन ऑल्सो, वॉट एवर यू गाइज नीड. ओके, so I will upload the PDF in half an hour. Within half an hour I will upload the PDF. You'll find the PDF in my Telegram channel as well as in my tinyurl.com/Apuroop10. Okay, thank you so much guys, thank you so much for the lovely response. Keep liking and keep sharing. Okay, keep sharing these videos. Tell everyone that this is one single session where they can revise the entire strength of material. Thank you so much, lovely teaching you guys. This was an amazing session. Thank you. Bye bye. I will take a leave now. I'll have to take a rest now. So thank you so much. You guys keep rocking, keep working really, really hard and make me proud. I will see you guys tomorrow. Okay. Till then, bye bye. Take care. Bye bye. Bye bye everyone. Bye bye. Bye bye.